Hi there, welcome to this Gaming Engines for Windows 8 Jumpstart. We are very excited about all the content that we're going to be doing today. First, we'd like to introduce who you're going to be associating with today through video. So I'd like to introduce my friend here, Jeremy Foster.
That's me, Jeremy Foster. You can find me online at codefoster.com. Some of you, hopefully, have seen the series of Jumpstarts that Michael and I did on a different topic. If so, then you're familiar with the two of us. Anyway, you can find me online if you're looking to get up-to-date information on all things Windows 8, games for Windows 8, HTML and JavaScript for Windows 8. That's kind of what I do. So codefoster.com. Find me on Twitter at codefoster. And by the way, why don't you just go ahead and jump on your Twitter client now and throw me a shout out to @codefoster. And we're going to be using the #MVAJumpstart hashtag in Twitter today. So go ahead and include that in your shout out. We'll just get a little bit of a conversation going on Twitter. Although I know most of you are also on the chat session right now. So we're going to have some good community around this online session. We're going to have a lot of fun.
Cool.
And actually, one more thing I wanted to say. I did write a book, and I just wanted to show that real quick. So this is CSS for Windows 8 app development. And you can find that online at aka.ms/CSSbook if you'd like a copy.
Very cool. Yeah. Thank you, Jeremy. Yeah. Well, just briefly, my name is Michael Palermo, and I am also a peer of Mr. Jeremy, a Microsoft Technical Evangelist. And I love doing the Jumpstarts. I love the experience I had with the HTML5 stuff, but I'm so excited about what we're going to be doing today. With regard to little information about myself, published author in technologies such as ASP.NET, XML, C#. Love my current passion right now is CSS, HTML5, JavaScript, everything that's Windows 8. And if you want to find out more about me, you can go to my landing page with some cool links at the aka.ms/Palermo4 link. And that's enough about myself. I'm finished with all that. But you know what? Today, there is a third dimension with regard to our presenters. So I'd like to bring up right now Mr. Adam Tuliper. Come on, Adam, come on out. Woohoo!
Thank you, guys. It's awesome to be here today. We have some great content to cover, and when you guys are ready to talk about the third dimension, I think I'll join on board here because you can do some really cool 3D stuff we're going to talk about. I wish I had a book to plug, but I don't, so I can plug the book. This is a great book. I've actually read it. Thank you, Jeremy.
Yeah, I'm sorry we don't have a chair for you.
That's okay. I'm tall. My knees work quite well. I'm getting worn out a bit early. But I'm super excited to be here. I'm a software architect for many years and getting a lot of gaming lately in Win.js and HTML, JavaScript. So let's do this.
Where do folks find you online?
AdamTuliper.com.
Cool.
And at AdamTuliper on Twitter.
Great.
Yep.
Sounds good. Thank you.
Guys. See you in a bit.
All right, so you'll see him in following modules throughout the day. Let's go ahead and consider our agenda. So in this first module, we're going to be considering, prior to the break that is, these three modules, and the first one's planning your game. This is really important, so make sure that you stay tuned. We got some really good tips in here. Plus, we're in the next module, we're going to consider game assets. I mean, this is like the core of your game are all the assets. And then, I'm very excited about this. Jeremy is going to help us through the world of Construct 2 by Scirra. That's a gaming engine that we're excited to see. And he'll pretty much take the reign on that and show some cool stuff. And what are we going to do after the break, Jeremy?
After the break, we are going to let Michael talk about GameMaker from YoYo Games. So that's a different game engine and the second one that we're going to be talking about in this course. And after that, then we're going to have Adam on. Actually, you'll see Adam before Module 5 Unity, but Adam's going to come on and talk about the third dimension offered to us by the Unity game engine. Very exciting stuff in the Unity world. I think there might be monsters involved. Yeah, I think there might be monsters or dinos. I don't want to give too much away, but we'll just, Anyway, so that's Module 5 Unity, and then we're going to kind of wrap it up with some information about how do you make money on a game that you create. That's probably the important part in a lot of people's minds. So we're going to talk about monetization, and then we're also going to talk about how you submit your app to the store. When you've created it with an engine, it has to be packaged up and submitted to the Windows Store so that the whole world can enjoy your game. So that's it. That's what we're going to be talking about today.
Okay. So with regard to setting expectations for you right now who are watching, our target audience is really the beginning game developers. So if you haven't made a game yet, this one's for you. You're probably somewhat technically inclined to have some development skills, and we have some suggested prerequisite links that you should definitely look at on the screen right now. If you have those links and you want to brush up on some skills, that would be excellent for you to check into. But that's kind of the setting. We're not expecting that you've done this before. In fact, we're hoping that you're going to start doing it, especially after today. Now, the MBA community is one you certainly want to join. Free online training for both developers such as ourselves and the IT world. You have over 1.2 million registered users already, and we would like you to see where you rank. You can earn 50 MBA points for this event if you go to the link on the screen, the aka.ms MBA-voucher, and that is case sensitive, by the way, and then enter the gaming code as you see it there, and that expires, so make sure and do that, and show what you got, show your muscle. All right. Well, let's get right into this very first module with regard to content on planning your game. This should not be underestimated how important this step is. This step could really change the entire direction of where your game's going to go. So don't miss out on some of the tips here. This is pretty critical.
Michael, I actually heard that any project should be at least 80% planning and 20% execution. And I think as developers, we're tendent, unfortunately, to just dive right into the code. And because we've got a great idea, and that's awesome, but we dive right into the code, and I think we make too many course corrections, and we waste a lot of time, spin our wheels, when really we should sit back, do a better job at the planning process, and then when we execute, we can be super efficient, we won't have nearly as many bugs, nearly as many course corrections, we can just be on goal the whole time. So yeah, that's my 2 cents on planning.
Absolutely. And in fact, what I would even say to extend that is that if the excitement level to just code in general for any kind of project, imagine the excitement level that you'll have if you're going to start a game. So you'll even more so probably want to skip this step because it's so exciting to get involved right away. So definitely you want to plan it. So we're going to give you a tip right now on how you can do that, how you can start to plan your game. So first thing we're going to discuss is the analysis. What you should do, what you should study prior to even getting started with anything, and that is on the audience and the competition. Then we're going to look at platforms and architecture later. But right now, we're focused on analysis. And this is the way that we could start it off. Let's imagine this scenario, if you will. Someone wants to make a game. They want to make a word puzzle game. And that's all they have in their mind right now. I want to make a word puzzle game. Well, if they have that in their mind, but they don't do any further thinking on that, they might start the coding, but they might not have a very differentiated game. But let's consider now what you could say would be some thought processes that would guide you to wanting to do something very important, a very key thing that we're about to learn. So someone might say, I'm making a simple word puzzle game, so why would I need to analyze anything? It's too simple. What would it change? So keep that in mind. And the other person might say, well, why bother making a word puzzle game? I think there's hundreds or thousands of them out there anyway. But maybe there's a good reason for you to actually consider it. So what can you do to help you with your planning? Make a statement. What we mean by make a statement is not like a fashion statement, although maybe that's what your app's going to do or game. This is a best at statement. This is meaning you're thinking right up front, what is my game going to be best at? So let me give you an example with the word puzzle. The name of the game is Dr. Ow. By the way, that's word spelled backwards. Dr. Ow is a word scrambler game for Windows Phone and is best at engaging users to compete online with advanced puzzles. Now contrast that with how someone else could have their best at statement with a word puzzle game. Dr. Ow is a word scrambler game for all Microsoft devices and is best at helping children learn how to spell. So, do you think that word puzzle game would be different than the previous one? Absolutely. One's about hardcore online competition with word puzzles, and the other one's geared towards younger children to help them how to spell. You think that would guide also the way you would do your user experience? And a lot of other things? Absolutely. So I think that's key. You got to have the best at statement.
Yep, agreed.
All right, so now that you have your best stat statement, the next question is going to be who is really going to be your audience? So I had there know your audience, but it's really target your audience. You are going to make an impact not just by knowing them, but as you're designing and develop, you're targeting that audience. So of course, you're going to do your user experience for young children very different than you would for an advanced crowd. You're going to do your marketing strategy different based on who your audience is going to be and even how you're going to monetize. You might think, for example, hey, if this is children that are going to primarily be doing this, I don't know if they're going to click the purchase. Maybe I might be able to do a strategic ad somewhere. And yet, if it's going to be the other route where it's hardcore gamers, maybe there would be some in-app purchases or things that you can do in there that would entice the older crowd that might have the ability to make those purchases. So your monetization strategy might even change just based on who that audience is going to be. So that's really important to understand. The other thing we're going to look at right now is the competition. Now, when we say the competition, we could say it's just easily about, just looking to see who else has word puzzle games out there. And that's part of it. But you want to put these dimensions into your analysis. You want to understand, how is it that other word puzzle games are priced? What makes them peculiar? And what that really means is what makes them different. And then finally, what platforms are they on? See, all of those are analysis of your competition. What would be the case if you found a really cool game on one platform and it wasn't on the Windows Store yet? Well, that's an opportunity statement for you. So be thinking about that as well. Now, while we're here on this topic, the 3 Ps of competition, the pricing, the peculiarity, and the platforms, you want to keep in mind that the main thing here, and this is also in line with your best at statement, what makes you different? Because guess what? Word puzzle games right now are pretty popular. Imagine if one of the most popular ones out there right now decided not to get involved just because there were other ones already out there. So don't let other ones distract you, but be sure that you're different. What's your differentiator? And remember those 3 Ps, pricing, peculiarity, and platforms. Now, with platforms on the mind, I'd like to switch gears over and have Mr. Jeremy discuss with us, what do you mean by platforms, Mr. Jeremy?
All right, so I'm going to talk about platforms, and I'm going to do the next section on architecture as well. But I did want to just tack on to your idea of the audience and competition analysis and say that it might be possible that the only added thing that your app brings is a differentiated user experience, a usability. It might be that the app really does already exist in the market, but you've used it and it's not fun for the finger. I mean, it's not great for a mobile experience. It's not extremely usable. And so you can make the same app, or virtually the same app. Of course, you want to make sure you're not stepping on copyrighted ideas or whatever. But,
absolutely.
But you can make essentially the same app with a better usability, and now that is part of your best at statement. I'm going to be the best in my category at offering the same thing,
Excellent.
but it's going to be something that people love.
Love it.
Yeah. Okay, let's look at platforms. You have looked at the field, you've looked at the people that are going to be using your game, you've downloaded a number of other versions of your game so that you can figure out what already exists on the market and so on. And now you need to figure out what platform landscape you're going to be choosing, because this is going to determine what your development team looks like, what your schedule looks like, all of that. It's going to be very important. And there are lots of considerations here. The questions that I have on the screen are really big questions, actually. Mm-hmm. The first of which is native or web. This is a classic question. Right now, right now our landscape is one that makes this question inherently difficult. Should I create a native application that in the language of the platform I'm writing on? So if I'm writing on Windows 8, writing it in C# or XAML or HTML and JavaScript. Or if I'm on the iOS platform on iPhone or iPad, then I'm going to be using Objective-C and their design language. These are the native apps, okay? Web apps, you create these on a server, and there are some really big advantages to using this architecture. If you can create your app entirely on the web, then we're going to see a slide later, your data, your logic, and your UI all exist in the cloud. You can update it anytime you want. It's updated for everybody. and it's a common experience for everybody. And the advantage is actually more pronounced in games because games tend to create their own design language, and so you don't necessarily need the operating system's design language. You don't necessarily navigate lists and access menus the same way that you do in the operating system. You may very well just be using the game the way that it determines the design. So always ask the question, can I create this using the web stack and using a traditional web app delivery? But keep in mind that this web app is going to be running in the browser. And you're going to be constrained to the browser, and there's some serious limitations that you're going to have to face. One of them is you're not going to have access to the full device. There are some tricks, some ways of getting some geolocation and some of these device-specific features, but by and large, you're going to be missing out on a lot of native features when you choose the web. You also may very well be missing out on some performance. So try it on the web, try it in HTML and JavaScript, make a quick little prototype and see if it's going to work performance-wise for your app. You may be able to gather some experience so that you'll be able to determine just intuitively if it's going to work in the HTML and JavaScript through a browser. Now, we're talking today about using game engines to make Windows 8 apps, and you have to keep in mind that when you choose the web stack for making a Windows 8 app, you're not making that same decision. You're not making those same trade-offs because an HTML and JavaScript app run on Windows 8 is actually running natively. So you have full hardware acceleration. You're not going to run into the same performance issues, and you have full device to that, full access to that device. So you don't have those considerations to make. So that's a good story for developers right there. But that's just a classic question. You're going to have to make that decision right up front. Another question, is this going to be mobile? Is this a game that you're going to expect people to play on a large screen with a large processor with a machine that's plugged in, essentially? Or is this going to be a good game for playing on the bus? I know I have a lot of those games that I wouldn't play it on the bus. It just doesn't work on that small screen. And there are other games that work great on a small screen. In fact, it feels a little bit silly on a large screen. Right. So ask yourself, is this a mobile game? When you answer the question, yes, this is mobile, you are determining that there are going to be significant constraints to your project. You have to consider the battery, you have to consider the processor, you have to consider the form factor, you have to consider all of these things when you know that you're targeting mobile. Okay? And a number of these engines will target mobile for us right out of the box. I know that Construct 2 is the framework that I'm going to be talking about today. And with Construct 2, you can just export your project for Windows 8, for the tablet and the desktop, or you can export it for Windows Phone. So you'll usually make some design considerations there, but they make it pretty easy for you. And if you're going to that environment, then you need to make sure that you make those decisions. All right. You need to figure out if you want to be on all of the platforms, or would you rather just kind of target one platform and be differentiated on that platform. The Windows 8 and Windows Phone design style, the tiles, the simple graphics, is a very exciting, very unified, very elegant design language, and it's very popular. You can create a game that takes advantage of this design language and really thrills your audience just in that alone. Of course, the gameplay is still going to be very important, but when an audience member when a user has an app, a game that's running on Windows 8 or on Windows Phone 8, and it takes full advantage of all of that, the design style of those platforms, users really like that. So that you might want to target just one platform just because that's where you are. I know developers and I know entire dev shops that say, we don't really want to get into cross-platform. We just want to put our eggs in this basket and make apps for this platform. They can get excellent at making apps for that platform. They can make sure that they're making native apps. There's some serious advantages to that. Cool. What do you think about the differences between between web apps, native apps, mobile and non-mobile? Any considerations you want to bring up there?
So obviously it's going to be a matter of also, you worry about all the different devices and all that kind of stuff and the compatibility factor. But with all that said, I personally feel that, of course, and we're going to be leaning towards this today, that putting the game in that absolutely perfect scenario where you're going to get the best experience with the proper device and the absolute, I would say, I think, of course, I'm being biased, that the Windows 8 platform is going to provide a fantastic, or is providing a fantastic experience for those, especially with the touch-enabled devices. So, I'm slanted to start to think that I like the web app stuff. In fact, of course, HTML5 is a passion of mine. But I just love the fact that I can also use those technologies if I choose to do so to create an app for Windows 8 as well.
Yeah, that's very cool. I was talking at a presentation recently, and I was looking for a good example of a cross-platform game on the Windows platform. And actually, there were a lot of them to choose from. And I was pretty surprised. I went and downloaded Skulls of the Shogun on Windows 8. And then I downloaded it on Windows Phone, and it was a really fun experience on both devices. I didn't expect it to be so fun on a small form factor on the phone, but it really was good gameplay. They did a great job with that. Yeah. And I get to level 3 in the game, and it's kind of a story. It's unfolding. You're in the afterlife, and you're a samurai with a gigantic mustache. And I think that it's safe for kids because there's no killing, because everybody in the game's already dead.
Oh, great.
You're in the afterlife. Anyway.
That's good.
So you play this on Windows 8 and it works great, and you play it on Windows Phone and it works great. So yeah, just a good cross-platform story. Another question that you need to ask yourself is, what do I have for developer bandwidth? Are you a one-man shop? Are you developing these apps on your own in your basement in the evening? You've got a day job. That's like a lot of us. That's me. And or do you have a buddy that you're doing this with? Is it 2 of you so you can work together on that? Or are you a pretty decent sized shop? You've got a separate test team, or a tester even. You've got a separate graphical designer. Those are some serious considerations as far as what your developer bandwidth is, how much you're going to be able to handle, and they're going to determine how much you can bite off. I know whenever I see a really well done game, something pulls at my heart, and I go, man, I would just wish I could take the time in the evenings and weekend and make something that's that good. I have to remind myself there's a good chance that was a whole team of people working on the graphics, and then working on the gameplay, and then doing all the testing. It's a big effort. Some of these games are a massive effort. I know I have a friend that works on some major video game titles for Xbox, and he tells me about it, and it's a huge effort. They have massive teams, and they have all kinds of resources, and they bring in actors, and they have professional Foley artists, and just everything that you need,
Yeah, so if you're the one-man shop, you got to do all the roles, where sometimes you have an entire team just for one focus.
Yeah, you got to wear all of those hats, absolutely. Now, what this game development with small teams, just you or 2 or more people often bring up is this scenario of distributed development, a distributed team. You're in one geography and you've got a teammate that's in another geography entirely, and you guys are going to need to be working together. And probably a lot of you as developers have at least some experience with source code and source code management, source code control systems. And if you don't, you really should get good at that. It's a fundamental skill for computer scientists in today's world. A lot of you are familiar with distributed source control systems like Git. Git is kind of the one that's coming out on top over Mercurial. That might be subjective. I'm not sure. I think it's fairly objective, fairly easy to say that one's kind of coming out on top. And things like GitHub are an excellent repository for some collaboration on the same project. I know that I work with some of my teammates on source control, and it allows us to just really get a ton done at the same time, simultaneously. And I want to tell you that there's a lot of ALM offerings through Team Foundation Service. Team Foundation Service is Microsoft's Team Foundation server, except we're hosting it in the cloud, and you just go to tfs.visualstudio.com and you can sign up and get your own prefix. So for instance, I am at codefoster.visualstudio.com. I go there. That is my own Team Foundation server in the cloud. And the cool thing about this is that I can still use Git as my source control, so I can drop down to the command line. I'm doing distributed. I can work really well on a plane. I can commit all my changes and collaborate with my fellow developers. But because I'm on Team Foundation Service, I get the full ALM on top of that. So I get work items, work item tracking, a burn down chart. I can really get good control over my team, what it is that we're working on, when it's due, and everything, because Team Foundation Service gives us so much resource.
That's very cool.
Yeah. So that's a lot to bite off. One more point on platforms and platform selection, and that is, well, we kind of talked about this already, but just the resources that you have. Do you have the graphic designer? Do you have the testers? Do you have the ability to throw a lot of man hours at this, or don't you? And then finally, the question is, if you're going to use a game engine, which one are you going to use? Now, today, in this course, we're going to be presenting 3 different game engines. There are more. There's lots of them.
There are?
But we're going to be talking about Scirra Construct 2, YoYo GameMaker, and Unity 3D. Those are the 3 frameworks, the 3 engines, rather, that we're going to be talking about today. And if you want to choose one of those, if those fit the game that you're doing, if they fit your platform selection, then go ahead and make that choice. Which platform would you choose? Which engine would you choose?
Well, I think what we're going to find out is with the 2-dimensional games, it's going to be a knockout, duke 'em up on the Scirra's Construct 2 and the YoYo Games GameMaker. I'm going to have to look at your module first on Construct 2 before I have an opinion on that. I'm highly biased to GameMaker by YoYo Games. But if I was going to go 3D, I'd probably be looking at what Mr. Tuliper, who's going to probably steal our thunder, is going to show us later with Unity.
So why don't you have a GameMaker shirt on?
I don't know.
I'll tell you why.
Because I didn't get one, that's why.
It's because the T-shirts are coming from Ireland and they didn't get here in time.
Hey. Okay.
Not that a Windows Phone T-shirt is any less exciting, but
This is a good backup.
Yeah, it's a good backup. Okay, so another point. I want to clear up some terms here. Okay, there's lots of terms that are being thrown at you. A lot of you might be new to the gaming world entirely, and there are lots of gaming terms. We won't have time to cover them all, but one that I think is really important to cover right now is this. There are libraries, frameworks, engines. You'll hear these terms sometimes used interchangeably. In fact, you heard me slip up and use framework when I meant engine today.
Right.
And so I want to clear this. Yeah, exactly.
Come on.
So here I'm going to clear this up.
Good.
A library is just code that somebody else wrote, packaged up, and you're using it. Okay? It's good to use libraries because it means that you're not reinventing the wheel. Somebody already did this. You're using it in your game. Now, there are open source libraries that lots of people contribute to. You can look at the licenses for them, and there's a good chance that you'll be able to use that in your product. Okay, that's the world of open source right now. Very exciting. But these are libraries. Your game is going to take what we call a dependency on a library, but it's a relatively light dependency. If something went wrong and this library fell out of existence and you couldn't find the source code anywhere for some crazy reason, you would probably be able to swap out a different library, do some rewirings, and you'd be back up and running. Okay, that's a library. Code that somebody else wrote that you're using. Libraries usually have a good API, so you'll hear that term as well. API is just how you interact with it. You want to look for libraries that have an API that is easy for you to learn. Okay, a well-formed API. That excites real developers. If you don't get excited about a real API, ask yourself if you shouldn't be a banker.
Okay.
You might just make a great banker if APIs don't get you excited. Okay, frameworks. Now, a framework is like a library. It's code that you bring in. Somebody else wrote it. But we call it a framework because it's kind of like your skeleton. You're founding your game on it. You're doing your game in that framework. Okay? The Java virtual machine is essentially a framework. The .NET framework is essentially a framework. Okay? These are things that you're taking a dependency, but you're really invested in that dependency. And if it went away, you would have to completely rewrite your application. Okay? Because you're taking a strong, hard, solid dependency on a framework. Okay? Now, the 3 things that we're going to be talking about today are not really libraries or frameworks, because it's not like you're going to create a new project and then bring in the GameMaker library or GameMaker framework. No, you're going to open GameMaker and you're going to start your game in GameMaker. And we call it an engine because you're going to create your game in this engine, and then this engine is going to churn out the results. It's going to churn out the other projects.
Right.
Now, the huge advantage to an engine is that it can churn out the projects. You build it using the rules of the engine, and then it can churn out the projects in various platforms or various languages. Right. So you go ahead and make your game in Construct 2, and then you say, I'd like to create that as an HTML5 game. And now I'd like to create that as a Windows 8 game, and now as an iPhone game. So you can do that. It's a big advantage. It's a good way of getting onto multiple platforms practically simultaneously. There's usually some tweaking that has to happen.
Sure. And I'd also like to comment on that too, that within those engines then, some of those other elements might exist. For example, one of the engines might in itself import an open source library, or they might have a support for a particular kind of framework. So the engine is kind of the tool that gets it all rolling, and then within that tool, we might be grafting in some of these other things that Jeremy's been talking about.
Yep. Very cool. Okay. Let's move on to the next section, which is, I'm going to talk about architecture. Okay, the architecture of your game. Now, architecture is not necessarily a consideration on a micro level when you're using an engine. It still is. It's good to know these architectural concepts, but you don't have to have a computer science degree in order to make a game using an engine. You don't have to have a lot of the theory, but if you do, it helps. But there still are architectural considerations, even when you're using an engine to create your game. And I'm going to talk a little bit about those. But before I get into the architecture of the application, I want to talk about the architecture of your team. So I mentioned this a little bit, but when I was talking about distributed teams, but ask the question, is your development team, is that just you? Or do you have other people that you're working with? And you should ask yourself if it wouldn't be a good idea to either grow or shrink your team. If you could get your game that you're working on into a platform like CodePlex, which is an open source project hosting system online, you can use Git underneath it, and you can host your game on CodePlex, and then all of a sudden you can invite your neighbor or your friend from school or whoever, your colleague at work, in the evenings and weekends to come work on your game with you. You know, get them plugged into your source control system, and they can help you out. They can work on your game with you. So you might want to grow. You might really do yourself a favor by growing just a little bit. You might find somebody who has really good design skills because you don't. Or maybe you're the designer and you need to find somebody who has some skills in writing code because you don't. So you might think about growing your team. You also might want to think about shrinking your team. I can imagine there are some situations where you might want to shrink your team.
You have to explain.
You might have too many cooks in the kitchen. Have you run into that?
Maybe.
Yeah. Sometimes a project is hard to push forward if you've got, 4 people that are trying to, do what they want to do. And it might be better if for your game, if you just pared down and 1 or 2 of you worked on this one and you set a couple of other guys working on a different project entirely. So make those considerations. Architect your team for success. Make sure that they're going to be contributing and not taking away from the success of your game. It's important.
Sure.
And then do you have the tooling for working distributed? And I already talked to you about TFS. It's free for teams of up to 5. So you may as well go to tfs.visualstudio.com and get started with that tooling. That's a good idea.
Yeah.
Let's talk for a second about the architecture of the application then.
Okay.
Another huge consideration, especially in today's world. Have you heard the term cloud lately?
Yes.
About 7 times a day?
Yes.
If not more. What is the cloud? Why are we talking so much about the cloud these days?
Well, because it is a central place where everyone can put their stuff.
But haven't we had that for years in the form of like online hosting companies and the internet?
Yeah, so why do we have this cloud?
So what's the modern fiction to cloud?
I don't know.
You're at a loss for words.
I'm at a loss.
Actually, I think that most of it is a fad. Although there's a lot of new stuff, new and exciting stuff that does differentiate cloud computing from other servers on the internet that we've been using for years, such as the ability to scale, the ability to scale up and scale down, and the ability to not just have infrastructure as a service where we basically have servers that we host in the cloud and then we can go install whatever software on them we want. But we now have a lot of platform as a service offerings where it makes it super duper easy. You don't have to get into your server management. You basically just go, you want data, and you just go to your service and you create data. You use something like CouchDB or Azure Mobile Services, or if you want to put an API in the cloud, you can use something like Buddy or Parse or, again, Azure Mobile Services. There are lots of services that are in the cloud. You don't have to worry about the scale. You don't have to worry about the architecture. You just get to take advantage of those and use those for your app. So there are definitely some extremely strong advantages to the modern cloud. Now, if you were to write an application for, let's say, a phone, and you wrote the whole application on the phone, we would call that a client app. Okay? It's running on the client, entirely on the client.
Okay.
And we could split the application out into 3 sections: the data, the logic, and the UI. And that's what I'm showing on this slide here: the data, the logic, and the UI. Okay.
And you're saying that's all on that phone right now?
This is all on the phone. Notice there's nothing in the cloud on the top. There's only 3. All 3 sections, all 3 segments of my app are on the client.
And your top section is billowy.
It is. It's billowy. Did you notice that looks like a cloud? Thank you. Thank you for noticing that. Now, at some point you realize this is not ideal. What is not ideal? Let's look at data first. What's not ideal about having all of the data for my application on the client?
Well, you couldn't share anything, I suppose.
Yeah. If I made a new high score and I wrote it into my data store, what happens to the other users that use the app? They don't get to see my high score, right?
True.
Because that data only exists on my phone. Not a good way to do it. And not in today's world.
I agree.
Not on devices that are assumed to be always connected, or even usually connected, or occasionally connected. Even if it's an occasionally connected device, we should still be sharing some data with the other people that are using the app. It's a given. So let's move that data component up into the cloud.
What?
Now, how do we do that?
Yeah.
And there's lots of ways to do that, okay? Lots of ways to move your data up into the cloud. I mentioned a couple of them. Azure Mobile Services is a really cool offering. I love Azure Mobile Services, and I'm using it in a number of the apps that I work on. The thing I like about Azure Mobile Services is it feels like a NoSQL solution. I basically just create my JavaScript objects and drop them into a table. But behind the scenes, it's actually storing that data in an Azure SQL database. And so I have the full advantage of sitting on top of SQL Server. And so I could connect to it with a connection string, and I could access that data in a very low-level, powerful way. But for me as a developer, in 90% of my use cases, I just want to make my objects, drop them into my database, and then go pull them out in a very modern, easy, NoSQL fashion.
So with your analogy that you've been using, you're saying that maybe now that high score could be something that could be stored out there and in the cloud.
Completely.
Instead of putting it on the local device, it would actually go in the cloud somewhere.
Absolutely.
Cool.
So now I might have what kind of a table might I have to store that high score? I might actually just have a table called scores. And in order to build on the client side, in order to build a list of all of the high scores, all I have to do is ask that table, could you please give me the highest 10 scores? And then that database would give me the highest 10 scores. And that's what I show in my game. So now I have a solution for my data to put it in the cloud so that I can share it on my multiple devices. So all the users that are playing my game are able to see the same data. Okay? Now, the little flow chart there represents the logic in your application. Okay? This is some people call this business logic, which doesn't necessarily apply in games. Game logic. This is the rules. This is the decisions that need to be made in the game.
Okay.
Now, if you have that logic on the device, you're repeating it, on every device, which is, from a resource standpoint, probably not too much of a consideration. It's probably okay. One of the problems is if you have sensitive IP, if you have IP, intellectual property tied up into the logic of your game, like you have stuff that you have paid your developers big money to work on for years, you have to be really careful, because when you put logic on the device, you have to assume that it can be compromised.
I see.
Even with today's best ways of obfuscating and encrypting your source code on the devices, you have to assume if it's on the client. Here's what we say: never trust the client. Anything that's on the client could be compromised. Never trust the client. Okay. So one huge advantage to putting the logic into the cloud is that you're in control of the cloud. People don't have access to that. It's up there behind your authentication system, and it's for the most part safe.
Right.
Unless your cloud gets hacked, but this is dramatically lower chances of that than the client being hacked. Okay.
Sure.
So that's one of the big advantages to moving your logic into the cloud. What does this actually look like? This looks like a really good API. Now, I feel like this, the way that you see this slide right now, my data and my logic are both up in the cloud. I feel like this is nirvana.
Oh.
This is a good place to be because this means that when you're ready to create a new app on a new machine, you don't have to recreate that logic in a new language. You already wrote it in your language of choice in the cloud. You've created a nice API coming out of that, not just for accessing your data, but for actual usage of the app, for your actual game rules, for your actual logic, okay? So this is, it's nirvana, but it's also idyllic in some ways. You'll end up compromising and putting quite a bit of logic in the app on the client, most likely, okay? Now, you could also put your UI in the cloud, and what would that look like?
It starts to think of kind of like a website.
It looks like a website, basically, right? Because a website is saying all of the data, the logic in the form of JavaScript, and then even the UI in the form of your HTML files and the CSS styling and layout, all of that exists on the cloud. And there's some big advantages. If you want to change anything about the UI of your application, you change it in one place, and it's good for all developers, right?
Yeah.
So this is a good place to be for some applications, for some systems. This is a really good place to be. But I still feel like this is nirvana because what this offers you is, especially for business applications, for applications that have some content and some interaction beyond just game interaction and game content, this allows me to create a native UI. So when I'm on my Android device, I feel like I'm on an Android device.
Right.
And when I'm on a Windows phone, I feel like I'm on a Windows phone.
Right.
I create my UI, and it takes some work to create an application on each native device.
Right.
But it doesn't take as much work as reproducing all of that logic.
Right.
Okay.
So that seems to be the key when we're planning this. And of course, we're not talking about how to do all this right now. We're in the planning phases, but we're saying at the big level, if you're going to have your logic and your data up there in the cloud, then boy, that gives you a lot of scalability with regard to management and scale. And yet, if you put the client, if you actually take the time to create the client, the game targeting that device or that platform, well, then you do kind of get the best of all worlds. That's really cool.
Yep. So these are just some considerations that you're going to have to make when you're deciding that you're going to take on the fun and exciting venture of building a game. So think through all of those. And what we're going to do is we're going to move into our next module after a brief break for all of our live listeners. And our next module is going to be about the assets that make up your game.
Yeah, and in fact, before we go there, some of the questions have been regarding, well, what if I don't have some of these engines installed? Can I do this today? And the answer is absolutely you can watch. Absolutely, you should be engaged today. Even if you don't, we might even be going into how you could acquire or get a hold of some of these gaming engines. So, take advantage of this opportunity to see it in action. If you do have it installed, that's great. You just don't have to have it installed.
Yeah, and actually that's a good point. At the beginning of each of our modules, we'll spend a couple minutes telling you how you can go to the websites, download most of these have a free or trial version,
right.
and a lot of them are very generous. So you can download these engines and install them and get it going right away. As a matter of fact, even if you're making a Windows 8 game, you can install these frameworks on on Windows 7 and get going right away, even if you haven't upgraded to Windows 8 yet.
Absolutely.
But I think you should upgrade to Windows 8.
Of course.
Yeah.
Very good. So that is all we have for now, and we do look forward to that next section on assets. It's going to be good.
We'll see you really soon. Okay, so let's start right off talking about audio. I'll just say right off the bat, there's not a ton that needs to happen on the audio front. It's a pretty simple area, but you're going to need to find some audio assets. So I'm going to talk about the types of audio that will be in your game, and then the ways that you can create that audio if you so choose. If you want to do your own audio, your own Foleying, that's the name for somebody that records audio for a soundtrack,
What's
for a
the
movie.
name?
Foley. F-O-L-E-Y.
Foley.
Foley artist. That's what he does. The Foley artist does things like, shaking the tin to make thunder and shoes on the table to make the footsteps.
Pretty cool. I didn't know that's what the name was.
That's a Foley artist.
Awesome.
Yep. But probably more likely than you creating yourself an audio studio, you're probably going to go find audio. And there's some good resources online where you can find those things. So let's just dive right in. So first of all, what kinds of audio end up in your application? Well, you're going to have sound effects, okay? The character just landed on the ground and it makes a little thud. Thank you, Mr. Foley. The character is running across the screen and you hear a little pitter-patter. Thank you. So these are sound effects, thunder, explosions, bullet fire, whatever. These are sound effects they're going to be in almost every game. Speech. Now, in some games, you're actually going to have characters, and they're going to be talking. Now, if you have to get into lip syncing, and matching a character's mouth to his words, this is going to be pretty advanced. But you're probably going to want a team to do that. But there might be speech in your game. It may not actually need to match it up with lips, but you might have some speech. And then there's a good chance that you're going to have some music. Music is very emotional, very engaging, and it's going to be one simple way to dramatically improve the impact of your game. And I don't just mean adding some music. I mean adding the right music.
Soundscape, music, right, yes.
Absolutely.
Very important.
Yeah, you could start a game and then all of a sudden you've got this energetic soundtrack and immediately you're feeling like, I'm going to get into it.
Yeah.
This is going to be a good game. So let's mention the various audio formats. There are a lot of audio formats out. MP3, WAV is kind of an uncompressed audio envelope. We've got WMA, which is a Microsoft format for doing audio. That's really cool technology that's built into WMAs, but they're not as popular. And then there's the audio component of various video tracks as well. So there are lots of, and there's Orgvabis. There's lots of different. A lot of different formats for audio that'll show up in your game. And two of these game engines that we're going to be talking about today, that is Construct2 and GameMaker, actually end up as an HTML JavaScript game.
That's cool.
Yeah, and so they actually have to create audio that is an HTML5 supported standard. What about Unity? What does that do?
Unity supports a whole bunch of different audio types, but we'll have just a little bit of audio in there, but it supports. I've dropped many different types in there. It supports a lot of different types of audio.
You're going to keep that card in the sleeve.
Yeah.
All right. So there's going to be a lot of different formats, but yeah, Construct2 and GameMaker, even though they need to be in certain formats in order to work, you can drop in a lot of different formats and they'll do the transcoding for you. That's pretty cool. So if you want to create your own audio, the easiest way is to just open Sound Recorder in Windows and hit record, and you can use the microphone on your PC. Now, it's probably not going to come up with excellent results. You're not going to have studio quality sound once you start using some better hardware, some better software, and also creating yourself a little sound studio. Yeah. But if you're just doing a kind of a scratchy game, nothing wrong with recording your own audio and Sound Recorder.
I had a musician friend of mine who would carry around anywhere he went a portable recorder because you never know when you're going to get that right sound. He would just go out in nature, record sounds of nature, use them as effects for things, so you can really be dynamic about what you record too.
You may want to run out to the Windows Store and download the game Angry Turds.
You heard it right.
I didn't name it. Angry Turds is an app that was written by a colleague of mine, actually using Construct2 with no prior programming experience, and she did all of the own recording herself.
That's great.
Using Sound Recorder.
That's cool.
Yeah.
Very nice.
So once you've recorded some source audio, you can edit it, at least rudimentarily, but if you get good at it, you can even do some advanced editing in an open source program called Audacity. It's a good open source package for visualizing your waveform, doing all your splits, cuts, joins, fade-ins, fade-outs, all kinds of noise, all kinds of audio edits. You can. Some of these actually even have noise filters. I don't know about Audacity if it has one, but some of these audio editing packages will have noise filtering so that you can pull out noise and clean up your audio a bit.
Which is very important.
Yeah, it really is. I know that I have primarily used a package by Sony called SoundForge, And there's actually some good audio track capabilities in their video editing software called Vegas as well.
Definitely.
Yeah.
SoundForge, so they use SoundForge. WaveLab as well is another good one. Lots of good packages, professional packages out there. But Audacity is a good, solid package in of itself too.
Yeah. Yep. Easy to find, easy to pay for.
Yep.
Everybody can handle a credit card charge of zero. So that's if you want to create your own audio. Now, like I said, more often than not, you'll probably be going and finding your audio. There are a lot of audio sites out there where people contribute. Maybe we've got independent Foley artists that get paid for contributing, their audio samples, and they're available. Some of them for free, some of them for pay, and there's nothing wrong with paying $2.95 or $10.95 or $99 for the right audio. If you've got it, if you're going to put it in your game, especially if you're going to make some money on it, that's a smart decision. Freesound.org in Compotech. Free SFX and voice jockeys. If you don't want to remember all of those, I kind of created a consolidation of all kinds of media at codefoster.com/media. So go to that one link and I'll list all of these out for you. I'm kind of using that as a repository of media information. So if you have any suggestions, go make a comment there and I'll add it to the list.
That is the best resource. I'm privileged to work on the team with both Jeremy and Michael, and we talk about internally that's the common resource that we go to, codefoster.com/media. It's easy to remember, and it's a great resource.
Cool. Yeah, I'm glad that's helpful. So that's it for audio. Let's move into the images world. So this is going to be a big one compared to audio. Your game is going to definitely be made up of lots and lots of images. So same thing, you're going to want to make the decision at every turn on should I create these images or should I go find these images? Which do you tend to do?
Well, so coming from a development background, the common clash that you have is you can either develop really well or make very good graphical assets. The two lots of times don't overlap. So for me, I've always been a coder. When I sit down and try to develop something, I'm like, you know what? Let me see if a professional artist or a student has done something a lot better, and generally I find something they've done a lot better. However, for certain simple things, especially working around you guys, I realize some of the simple shapes are easy to create. So now I'm kind of exploring that route a little bit more.
Excellent. Excellent. Yeah, so we're going to actually do a little bit of a tutorial here on creating your own images. The one thing I want to make sure that everybody knows, I still see a lot of designers and developers, probably more often developers who have just a little bit of design experience, say, well, I need to start creating some graphics, so I'm going to use the ubiquitous Adobe Photoshop, very popular application, without looking at the differences between bitmap graphics and vector graphics.
Oh, yes.
And as wonderful as bitmap graphics and bitmap graphics tools are, for a lot of things, they're just not the right tool. So I'm going to talk about the differences between those, some of these packages that are available to us. Then we're going to talk about finding our art and paying for art.
Excellent.
Okay, so long time ago, in a land far away, actually in a land far away since I grew up in Alaska.
That is a land far away.
It is a land far away. One of the first programs I used was Mac Paint.
Wow.
And I went out to images.bing.com and I found an image of Mac Paint. This is Mac Paint for the Macintosh Plus. And this is a bitmap graphics package.
That's actually not a bad picture, being from 1892.
Hey, I'm not that old. Yeah, and the reason why I'm showing you this is because going back to these relatively low resolution graphics really drives home the point that a bitmap graphic is just a bunch of dots. If we zoom into this, we see all of those dots. Back in Mac Paint days, there were two colors for your dots, black or white. And as a matter of fact, you can't really see it, but the kind of grayscale looking things are really not grayscale at all. They're just combinations of black and white dots that look like grayscale. But even today, 20, 30, some odd years later, we still have graphics formats, even though they've evolved dramatically, that are just collections of little colored pixels. Okay? That's a bitmap graphics. That's a bitmap graphic. It's that easy.
Like, would that be, for example, what we take on our phones?
Absolutely.
When we look at our grainy pictures that we've got of our family, think it's a great shot, we zoom in a little bit, and Uncle Bob is made of 3 squares.
Do Uncle Bob's teeth really look like that? Okay, so I've got a sailboat on the screen. This is a bitmap version of a sailboat. So let me zoom into that sailboat, and you can see clearly that even though zoomed out, it looks like a sailboat. Zoomed in, we come to the awareness that it's made out of these little tiny colored dots, okay? These little tiny colored dots are really good at portraying real-life graphics, but they're not very good at giving us good editing control over that image. Now, there are filters and brightness and contrast and image settings that we can change, certainly on these, but it's not good for instance, on the sailboat, allowing me to grab the mast and rotate it, right?
Right.
That would be very difficult. Enter vector graphics. So this is the same boat. I've actually traced this. That's the process of turning a bitmap graphic into a vector graphic. This is the same sailboat in vector graphic. Now, the advantage is that it's much more manipulatable. Is that the right word?
Sounds good.
Manipulable. But the downside is that it's lost some of its realistic quality. It doesn't look like a real sailboat if you really look at it. But because it's vector, now this image can be scaled to almost any size. When I zoom into this, notice that it doesn't lose any quality whatsoever. I'm even going to zoom in again, and you can see that it hasn't lost any quality whatsoever. This sailboat can be depicted at any size we want. In fact, I could take this sailboat and I could print it on a piece of paper, or I could put it on a tablet, or I could even blow it up and put it on a billboard, and it's always going to have the exact same quality. Because a vector image, unlike a bitmap, which is made out of dots, made out of pixels, a vector image is made out of rules. It's made out of lines that describe the edges of things. It's made out of colors that fill things in. It's a set of rules, and those rules apply even when it gets as big as a building. So that's the advantage to vectors. When we bring these into games, we suddenly have the ability to resize our images to any size that our game needs. We have the ability, if we've made George the superhero, we can grab George's arm and rotate it upwards because we can grab just George's arm and do a rotation. So,
I wonder if the person that created vector graphics said in high school math, "I'll never use math later on in life."
It probably entails some mathematical formulas.
Yep.
In fact, one of the fundamental shapes in vector graphics is a Bezier curve, which is a very mathematical concept,
Yep.
and very often mispronounced.
That's right, because this looks like Bezier. Bezier, not to be confused with brazier. Important distinction.
Very important. Okay, so I'm going to take you to a website called Inkscape.org. Inkscape.org is the website home of Inkscape, the vector graphics package that is open source.
Cool.
Very nice, okay? I highly encourage you to check out Inkscape, especially because of the cost. Not just because of the cost of free, but also because it's open source, and that's always wonderful and fun. We love open source at Microsoft. But also because it's a really good package. It really does a great job at vector graphics. It's not a big compromise that you're getting a free open source package and it only does X, Y, and Z.
That's right.
It does a lot, okay? But as it just so happens that I'm not too experienced in Inkscape because I, a long time ago, got into CorelDRAW, and I've just always paid for CorelDRAW. It doesn't cost too much, in my opinion, based on what it offers. And so I'm familiar with CorelDRAW, so that's what I'm going to show you today, is CorelDRAW, using CorelDRAW to do some vector graphics.
But now do all these same concepts apply in Inkscape?
They really do. The buttons will be in different places, they'll have different icons, but the concepts are all the same.
Excellent.
So let's review the different graphics packages really quick, okay? Inkscape, CorelDRAW, those are vector packages. Those are analogous to Adobe Illustrator. So a lot of people have experience with Adobe Illustrator, okay? Those are vector packages. For bitmap packages, we've got Adobe Photoshop. Everybody in the world knows about Adobe Photoshop, just like everybody in the world knows about Michael Jordan, right? Ubiquitous. There's also Corel Photo Paint, comes with CorelDRAW, comes with the suite. That's their bitmap solution. It's a good one. That's what I use. If you just install Windows, what do you get?
You get Paint.
Paint.
Yes.
A lot of people using Paint. It's pretty impressive. How many people still use Paint?
It's actually, and the interface has gotten a little bit better over time. Yep.
It's gotten a little bit better.
A little bit better.
And then you can also download Paint.net. Paint.net is a really full-featured, very capable, free alternative to Paint that brings in layers and effects. Yep. And you use that one?
I do. I actually really like the interface. It's easy to use.
Yeah.
I really like Paint.net.
How about GIMP? Have you used GIMP?
I've used GIMP. GIMP is very powerful. Interface-wise, I prefer Paint.net, but feature-wise, I would have to give it to GIMP because GIMP's got a ton of features.
There you go.
Yep.
There you go. Okay, so let's go ahead and do a little CorelDRAW demo. Remember that the concepts are going to apply across the board, so I'm going to go ahead and open CorelDRAW on my system. By the way, there are various versions of CorelDRAW. You can go check those out and compare them at corel.com. I really love this package. It's very
cool
capable.
piece of software. Yep. You introduced me to it. I'd heard Corel back in the day, many years ago, and you kind of reintroduced me to it. It's a good package.
Yeah, it's able to bring in almost any image format you want, and it's able to export almost any image format you want. So it's real compatible in that way. Okay, so we're going to spend a little bit of time creating an asset. Now, here's what I want. We've got Adam, we've got Michael off camera. We've got a number of tech guys off camera. I need a popular opinion on what sprite, as in what little game character or something, should I build right now. I don't want to do my own package. I just want to do Oreo?
Mario.
No, let's not do a little too complex.
Turn this down.
I'm going to filter, but we need a good idea. Some shape. Might appear in a game.
Light bulb.
A light bulb. That's a great one.
It's easy to draw.
Yeah, it is a little bit easy to draw.
Frog.
And a little bit hard in a way.
Yeah, frog from Frogger.
That one could work too.
Frog.
Yeah. Let's start with
Turtle.
the light bulb. I like the light bulb idea. Let's do that.
Oh, light bulb.
We're doing a light bulb.
The peanut gallery tells us light bulb.
See, I started out inviting opinions, and then I was so...
You get into trouble sometimes. You open it
right.
up to your friends and colleagues, and it just goes downhill from there.
CorelDRAW is great at allowing me to create a template, and so I can create a template. I've made one here called Windows 8 app, and it starts out at the base resolution of Windows 8, 1366 by 768, and it's RGB, which is a good color system to use for the screen when you're targeting the screen. And so when I create this and zoom out a little bit, I actually have a really nice Windows 8 screen ready to go. You see PowerPoint. I'm doing this wrong. You'll see this in just a second. All right. I'm going to show you CorelDRAW in a way that you'll actually be able to see. So this is called CorelDRAW. Sorry about the technical difficulty there. This is called CorelDRAW, and I've created a new template. Let me just do that again because you didn't see it. I'm going to create a new template, and it's going to ask me what template I want to start from, and I'm saying a Windows 8 app. Notice I have a Windows Phone app in here as well with the base resolution of Windows Phone. But I'm creating Windows 8, so 1366 by 768. Now keep in mind that you're not constrained once you create a template. You can do whatever you want, but it's a good place to start. Whenever I create that and then zoom out a little bit, I get to visualize my tablet screen. So it really is helpful, okay? Now, on this screen, I could work on the full surface here, like that, or I could work with a lot of little graphics, like maybe some here, some up here, and some over here on the right, and some down here. And it really doesn't matter because these are all vector graphics, and so I'm always going to be able to export these at whatever size I want. So I really don't have to feel like I have to think about what size it's going to be yet. Okay, so I've started out with a shape. I'm going to move it to the middle. This is a basic shape, and you'll find that in your vector packages, most things are made out of or built up out of the basic shapes. So you're going to start with squares and circles and things like that, and you're going to end up developing the resulting shape. It's made out of all these little ones. You might combine them, add them, subtract them, whatever. And in the end, you're going to end up with the shape that you're interested in. So in order to create this rectangle, I clicked in my toolbar over here on a rectangle. You'll find something similar in Inkscape. I've also got an ellipse tool that allows me to make circles and oblong circles like ellipses. I've got lots of complicated shapes, stars and triangles. Not that a triangle is all that complicated, but I'll throw it in that category relative to a circle. We've got tables. We've got many forms of lines. Most of these tools have flyouts, so I can choose, for instance, the ever-popular Bezier curve.
Bezier.
So you can brush up on your French there.
Oui.
Maybe some of you are from France and you can help us with this pronunciation. Drop that in the chat line. Go ahead and tell us how to pronounce it in the chat room. Let's try that. Okay, so let's go ahead and make ourselves a light bulb. Now, what kinds of shapes might a light bulb be made from? Thank you. I'm going to create a rectangle that's going to form the base of the light bulb, and then I'm going to form the bulb of the light bulb, the bulb part of the. I'm not a light bulb expert, but I'm going to assume this is called the bulb part of the light bulb. And now I want to make sure that these aren't off-center just a little bit. See how I got them off-center? So one of the nice things about a vector package is there's a real good description of individual shapes. And so I can actually choose both of those and center them. And it can center those relative to each other. In fact, if I have a lot of shapes on my screen, I can select all of those shapes and center those very quickly, align everything up with each other, okay? So I'm going to return to something like this. Maybe I want that stem to be a little bit larger. I want to make sure they're centered. And now these should really be the same shape, right? They're made out of these two fundamentally different shapes, but I want those to be the same shape. So I'm going to use the Shift key and highlight both of those. And I'm going to go up here to my toolbar and I get these Boolean operations that I can apply to multiple objects at a time. And the first of them is weld. So I can hit weld, and it's now welded those two shapes together. Those now exist as a single shape, okay? And it's not, if I create a rectangle that's kind of an intelligent shape, it acts like a rectangle, I can do something like grab the corners and turn it into a rounded rectangle. But this shape that I've combined together has now just become a generic shape, and shapes are made out of nodes. And if I drop down to my next tool over here, which is the shape tool, I can now have full control over the individual vertices or nodes of this two-dimensional shape. So now a light bulb doesn't have as clean of a seam here, so what I'm going to do is I'm going to tell this node, first I'm going to zoom into it, and I'm going to tell this node, actually pause. Notice it looks like I have pixels here, right? This is just a handy thing that CorelDRAW does for us to help us to know what this is going to look like when it is rendered, but it's not actually been rendered yet, so I can go up to the View menu and choose Enhanced Mode, and now it shows it to me as vector, okay? I like that format. So I'm going to zoom into these 2 pixels, and I'm going to tell this node here, you should not be a cusp. A cusp is something that can have an abrupt change of angle. I want you to be a smooth curve. And I can do the same thing with this one. I want you to be a smooth curve. And now if I zoom out, I've got something that roughly looks like a light bulb, but it's a little bit tweaky, I admit. So I'm going to grab just those 2 nodes, and I'm going to move those down a bit. Now that looks much more like a light bulb.
Nice. Do you remember the game Q*bert?
Yes, I do. It looks like Hubert, doesn't it? No, Q*bert.
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 Yeah, I think it was Q*bert, not Hubert. Now,
that was his cousin.
But it sounded, yeah, it was his cousin Hubert. Now, this light bulb doesn't have a long enough stem for my taste, so I'm going to go ahead and drag these vertices down a little bit. Then I'm going to take myself a rectangle, and I'm going to make a rectangle here, and the snapping is attempting to help me, but it's not actually helping me, so I'm going to zoom in a little bit, drag that out a little bit more, and then I'm going to center it on there, make sure that it's perfectly centered. That's still a rectangle, so I can grab my shape tool, and I can round the corners here, make those look round. And then I can actually skew that so that it's shaped like the thread on a light bulb, make it black. Now I can drag that and make multiple copies of it. So now I've got the threads of the light bulb. I can use the Control key to keep it constrained as I raise that so that it stays lined up the way I had it. And then I know at the bottom of a light bulb I usually have a something that hits the inside connector. So I'm going to try to create that. And here's the way I'm going to do it. I'm going to take this rectangle and convert it to curves. And then I'm going to grab these 2 bottom nodes, and I'm going to use this stretch or scale nodes, and it's just using those 2 bottom ones, and I can scale those in. And then I can actually simplify this shape a little bit. Well, I'll skip over that. That looks good enough, but let's go ahead and make that black. Let's go ahead and zoom out all the way. And let's fill our light bulb in with yellow and have no outline. And there we've created ourselves a light bulb.
Cool.
Woo! I think these would look better in kind of a dark gray. Maybe this should be black. I could get all sorts of designery on you right now, but I won't.
That's a pretty good looking light bulb.
Yeah, that's a decent light bulb. Now the cool thing about this being in vector, once again, is this could be exported to a variety of formats at a variety of sizes. So let's just pick one. Let's just say we're going to use this in our game. We're going to create a game with Light Bulb Man. Okay, Light Bulb Man's going to run around the screen. He's going to do whatever light bulbs do on the screen on a video game. This is your idea. You're the game developer. You come up with a great idea, something that people are going to love, and the sillier the better, right? I mean, flying birds.
That's right.
That are battling pigs doesn't have to make sense. Okay, so let's go ahead and export this. It doesn't matter what size I have it in here. I'm going to go ahead and select everything, and keep in mind that it's only going to export, if I choose, only the things that I want. So I'll just drop a little blue circle over there to prove that it's not going to export that. I'll select what it is that I want to export, and I'll hit Control E, which is the same as going to File, Export. Control E. It says, where do you want to put this? Let's go ahead and drop this on my desktop. We'll call it light bulb, and we'll use PNG. What's great about the PNG format?
Supports transparency.
Transparency, beautiful. Yep. It also doesn't have any loss in the compression. It's a lossless compression. That means that when you save as PNG, you know that you have full fidelity. You don't get any weird little artifacts in your image in an attempt to make the image smaller. It still does make the image smaller, granted not as small as a JPEG, but it makes it smaller, but it doesn't destroy any quality whatsoever, doesn't degrade any quality. So we'll choose PNG, excellent for video games because of what Adam said, the transparency. We'll say export. Now, it's got to bring up another screen to say, okay, I have to turn this into a PNG for you. And when I turn this into a PNG, at this point, you're going to have to determine what size you want it. Okay? I might be rendering a 30 by 30 icon that's going to show up as a really small character in my game and never be very large at all. And I want it to look good as a 30 by 30 icon. Or, as you'll see in the game that I'm going to do later, this image might be growing to the size of the screen, and those little pixels would get scaled up and look terrible. So let's go ahead and pretend that I'm going to export this as a 30 pixel wide image. Now I can zoom in. It's going to give me a little preview of what that's going to look like. And notice that it's super pixelated, but that's okay because it's going to show up small. Okay, so we want it to be pixelated. In fact, it's even anti-aliased, meaning that it's going to look really good small because it's going to apparently smooth the edges of my character. But now let's say, no, this is actually going to go, this is going to be the billboard version of the light bulb so that I can advertise my game on the side of the road. That's going to get us some downloads. So let's say we'll put this in feet. And now we'll say, I want this to be 9 feet tall. Why did it choose 4.86? 9 feet tall. Let's try that one more time. 9 feet. I don't know why it does that. Anyway, I can choose. Maybe there's a max size on it. Oh, it's rendering a preview, which at 9 feet is pretty gigantic. So it's just taking its time there. Don't worry about that. So it's taking its time rendering this, but what it's actually doing now is it's drawing lots of pixels, right? This is going to go on a billboard.
9 feet.
It's 9 feet tall, and if we walk into it, we're going to have to not walk into it. We walk up to it. We're going to have to not be able to recognize those pixels until we get really super close, right? So do you think I just brought CorelDRAW to its knees?
A 9. Think of the memory map size that would require for a 9 foot.
Should I have not done that?
Oof, that's pretty intense. Your machine might slow down. How much RAM do you have on there? 9 foot light bulb. So about 1 trillion gigs of RAM.
Michael, can you do that math for us real quick? 9 foot light bulb, how many pixels is that? I think it's about as many pixels as the Lumia 1020 camera.
Nice camera.
41 megapixels in that camera.
Pretty good. Which means you can zoom in on the teeth very nicely.
A friend of mine was not able to read the menu at a restaurant, took a picture with his Nokia Lumia 1020, and then zoomed in on the camera and was able to read the menu.
That's cool.
Across the restaurant.
That's very cool.
Impressive. Look at this. What else is impressive is CorelDRAW has actually rendered this for me. I'm going to have to zoom out to 1 by 1 and find the edge of the light bulb so that I can show you. Oh, see, even zooming out on it, it's going to be difficult. So that I can show you. Look how small those pixels are.
Wow.
You impressed? Oh, now where is it? Come on. Now. Well, we're ready to transition anyway. It'd be nice if we could actually see the edges of that light bulb. But if we don't get to, then we'll just move into a more exciting topic anyway, and that is the topic of 3D game assets. Do you think we should give it a little bit more time?
Let's see. The case of the elusive light bulb.
Zoom to actual size. No, not actual size. Zoom to pixel. I want to zoom to fit. So I want to be able to see the entire... There we go. There we go. Okay, here we go.
It's Tyranno light bulb. Gigantic
So I'm
bulb.
zooming in. This is in enough quality to be printed 9 feet tall on a... there we go. There we go. There's the pixels.
You may have just made the lights dim in Redmond.
I think so. Okay, so that's it. Now you've rendered a PNG that's completely ready to pull in as a game asset to your game. And we're going to show that when we get into the individual game modules.
Cool.
But that's about it for images.
All
Ready
right.
to talk about 3D?
I think now is a good time to transition to 3D assets. Get my slides up here.
That was a very two-dimensional light bulb.
Definitely two-dimensional. I felt the warmth and heat coming in 3 dimensions, though. I felt warm looking at it.
Yeah.
Alrighty, so let's talk about 3D assets. 3D assets are really essential to a 3D game. You can take 3D assets and render them to the 2D world if you have a chance of getting 3D assets. We'll look at some very shortly here. But what are 3D assets? So we've looked at what you had there is definitely, it's two-dimensional, right? You have an X and a Y. Now, 3D assets describe something almost in a physical world. An X, a Y, a Z. Imagine having something in your hands that you could rotate around. That's a 3D asset. They're mainly made of models, or called a mesh, a bunch of points in space, and we'll look at what a mesh is shortly. 3D assets can also be considered textures, which are generally actually 2D images that you apply to a mesh, to a 3D model. Animations, and I kind of group this all up in one because a 3D asset is usually comprised of a mesh, a texture on it, animations, and we'll look at all of these in just a little bit. But 3D assets are essential to any 3D game. Now, the aspiring artists, designers out there, you can design your own. If you're going to design something basic, maybe a wall, a small building, it could be actually fairly easy, and I'll show you a demo of that. But if you want something like, I don't know, a Spinosaurus. You guys were laughing at me in the discussion on the dinosaur pack I just purchased. But I wouldn't sit down and design my own dinosaur. Dinosaurs are made up of a huge amount of detail. So I might go somewhere else to try to find that, which brings me to finding assets. Now, how can you find your own 3D assets? There's a whole bunch of locations to get them. My favorite one is Unity's asset store. Since I'll be talking about Unity later on, Unity provides a great asset store. In fact, after this demo, I'll show you the asset store. TurboSquid.com, the 3dstudio.com, CreativeCrash.com. There's a whole plethora of them, and you can go on there and buy your 3D assets. If you want a 3-dimensional light bulb, you don't want to make your own, you can probably go on there and find one. On the flip side, if you want your own 3-dimensional dinosaur or very complex object, you can go on there and find one for free, or you can buy one on there. So they provide some great assets. A lot of them also provide you audio assets and other image assets that you can buy as well. So next, let's talk about some of the packages that people use to create the software. You've got Autodesk, which is really the leader in owning a lot of the packages now. They own Maya, 3D Studio Max, Lightwave. Those are paid products. Blender is an open source project. It is a free solution that you can get, and that's the one I'll demo with shortly. You can get Modo, Cheetah 3D. So there's many different packages, all with different capabilities. But we will look at a free one. So I have actually used pay ones in the past, and this is the first time I'll be doing a demo with a free product. The opposite of your approach. All right, so let's talk about what a 3D asset is comprised of. The basic of it is a mesh. So we've all seen these before. They kind of look like a wireframe, and it's described in some 3D space. Imagine grabbing that and rotating around. It's in a basic form. It's a definition of all the points in that 3D object. So here we have a picture of a dolphin, and you think of each little point, those little triangles you see on there, all the polygons. It describes what that looks like in 3D space. Those meshes are contained in a variety of file formats. Some of them are commonly defined formats owned by some companies. For example, there's FBX, OBJ, 3DS. Those are some common exporter types that many packages will export to. Then there are other proprietary formats that get exported out from the software itself. For example, 3D Studio Max can export to Max. If you were using Blender, you can export to a Blender file, MB, MA, etc. A lot of the main packages can import from other packages, and as we'll look at Unity in a little bit, Unity can import a bunch of those as well. So it's really powerful, really cool. Now, outside of the mesh, that just defines what an object's going to look like in space. So you've got this dolphin. It doesn't have anything assigned to it. And there's different ways that light interacts with objects. If we think about how light is hitting us now, am I just a consistent single color? No, I have a texture. There's bumps. I have the way that light is reflecting off me. So you have bump maps, specular maps, reflection maps, transparency maps, all different ways that you can apply texture to these empty 3D meshes to make them look like real-life objects. And there's also a term, a UV map, and we'll look at that in Blender. And this took me a little bit to wrap my head around because a UV map actually has nothing to do with UV or ultraviolet. I'll talk about that momentarily. Now, file types for texture maps think of a brick. You want to apply, you have a cube, and you want to make it look like a wall. So you want to apply some sort of picture that looks like a bunch of bricks to it. You can create those in standard tools. You can create those in Photoshop, GIMP. You can use just a picture of an object. You could go out and take a picture of a brick wall and use that and assign to your object. And I'll show you that in one moment here. So let's look at the Unity Asset Store and an example of editing a mesh and applying a texture to it. Switch it over to my browser. And we'll check out the Unity Asset Store first, and then we'll follow by a little quick Blender demo. Let's get out of PowerPoint. See my browser yet? I see a desktop, so let me go to... Sorry for the momentarily technical difficulties. Voila! We have the Unity Asset Store. And you can load this from inside of Unity, and I'll show you that in just a little while here when we look at Unity in a later module. But the Unity Asset Store is one of my favorite places to go and to find assets. In here, you can look for 3D models. Maybe I want to find dinosaur. So if we search just for dinosaur, we can see tons of dinosaurs come up here. Way better than anything I can create probably in the next few years, even if I was a professional artist right now, dedicating all my time to it. Look at this Velociraptor. So some really cool models. You want a dinosaur in your game? No problem. Allosaurus, $5. It's a done deal. $5, not too bad, right? I've purchased a dinosaur pack we're going to use in a demo later on for Unity. But for now, let's look at creating a basic asset all by yourself in Blender.
Can I add something?
Certainly.
I am a huge proponent of free software, but the only thing I love more than free software is really good pay software. I love to give the right person a little bit of my money so that they can make something that I don't have to. I think that's wonderful.
That's a very good point. And there are some excellent packages out there that are paid software products. I thought you were going to say free food, actually. Maybe since I'm hungry, I was thinking of food. The only thing better than free software is free food.
Okay, you've got me there. That is better.
So this is the Blender interface. Again, Blender is a free product. The interface is a little bit different than what you're used to. That's kind of one of the points discussed with Blender, that the interface doesn't quite match other software. It might take a little bit to get used to. So if you're going to dive into Blender, I'd recommend checking out some tutorials online. We'll look at just some basic stuff. The default scene starts out with a 3D cube here. We can rotate that around. Now, in any 3D package, I'm going to state this right up front, a 3-button mouse is essential. If you are on a system that does not have a 3-button mouse, there are generally ways around that. They have hotkey combinations. Maybe you can hold down Control and one of the buttons, and that will then emulate the middle mouse button. But I have a nice little 3-button mouse here that I've attached to my laptop, so I'm going to use this here. And in using that, I can just hold my middle mouse button down and rotate an object all around. So this object by itself is pretty boring. If I said, Jeremy, I want to make a very basic building, you would say, Adam, how do you make that basic building? So let's go into 3D view. We can change our modes by the upper left-hand corner here. Bunch of modes that Blender can operate in. And for this demo, we're only going to look at 3D view and later on UV image editor. So let's check out the 3D view. Now, other packages have quad view. And what I mean by that is you can see front, top, right. So in Blender, you can say Control-Alt-Q, and voila. If I say that right. Somebody in France is going to correct me. It's voila. Already my pronunciation's off. So here we have our top camera perspective, and we can zoom in with the scroll wheel and the mouse. Now I want to make a building here, so I need to switch into edit mode to do something. And the way that you do that is you just hit tab on the keyboard, and my object immediately lights up. And I can use A to highlight everything, deselect everything, highlight it again. That's just A. So what I want to do is I want to pluck off the top vertices on this object right here. Let's look at this as a wireframe. Another thing that might be confusing the first time you open Blender, you say, well, what's this menu up here and what's this one down here? In Blender, you can create a new instance of a window almost anywhere. You can scroll this over and you have a new view. You can move this back. Uh-oh, I just... So sometimes it's almost too powerful for my own good. I end up just doing little mouse movements and making all these new views. So let's get rid of this view by just dragging that over on there. So I want to delete these top nodes here. I'm going to go to wireframe. And this is just made up of a few vertices. I want to delete these top ones just so I'm left with a little plane. Yes, I can come into Blender and just say I want to add a new plane. That's under Info View. You can say add a new mesh, plane, cube. So all the default objects, like Jeremy was talking about before with triangles and squares, you can do some of that here, but in a 3D view. And remember, like I said, with 3D, you can rotate things around. It's like a physical object. So I want to go into this view here in edit mode, and I want to delete the top vertices here. So I'm going to hit Control Tab, Control Tab, and I want to go into face select mode. We have the ability when we select in here to use a mouse cursor to select just a vertex, a single edge, or an entire face of an object. Here I'm going to go into face select mode, and select in Blender is not left mouse click. You can configure that, but by default it's a right mouse click. So let's go ahead and face and delete that. And now I'm left with just a plane, not a 3D object anymore. And what I want to do here is, let's zoom in on this a little. We have a 2D object. We need to extrude it out in the 3D space. So if I hit E for extrude, notice I can grow this object out. So if I do that, now I've got this kind of rectangle there. So the difference between our 2D software and 3D, we have something 2D to start with a lot of times, and then we just extrude it in a 3D space. So I'm going to extrude this. This will be the base of our, extrude this. That's the base of our building. Zoom out a little bit. And I'm going to scale this top here to be a little bit smaller so I can make another segment of this building that comes up. So I'm going to do extrude. I'm going to hit E. You can also use the menus over here. Extrude. And you can see the shortcut, E. Let's extrude. But then we want to scale to about 0.8. Let's go. And notice in our top view there in the left-hand corner, that next level of our building is now smaller. And if we extrude here, we now have a smaller segment coming up. So we're going to do the same process again. We're going to extrude, S for scale. I'm actually going to hit Shift Z to make sure I'm only scaling in my Z coordinates here. And you can type in, before I typed in I think 0.8, or you can actually just use the keyboard here, the mouse. And notice on my top view, you can see that scaling. So I think the next level, right about there, looks good. And let's extrude this straight up, just by hitting E and moving the mouse. And we're going to scale this again. This will be the point on our building. Let's go a small point there, enter, extrude this puppy up, and there's the peak of our building. So let's come up here. There's our building. Or, if you're imaginative, this could actually be the start of a tower defense game. This could be a tower with windows on it, or you could actually just throw a turret on the side of this, and now you have a gun. So you can really use these assets in different ways. So now, let's talk about textures. In order to talk about textures, I'm going to simplify this. I'm actually going to trash this demo and just go back and load up a cube again, because it's easy to see a texture on a cube. And we're going to load factory settings. If your file menu in Blender disappears, because the same thing happened to me, I'm like, wait, where'd my menu go? Chances are, let's see if I go into 3D view, notice the menu disappears because we're in a different mode now. Here, I'm going to go back to Info, and that's where we get the expected file menu. It can also collapse. I admit the interface here is different, as I said in the beginning, than some programs we're used to seeing. But hopefully a little bit of explanation here on these modes makes that a little easier. So File, and we're going to Load Factory Settings. One thing to be aware of, that Blender by default will not ask you to save your project. So I don't care about saving this, but I'm just going to load factory settings and say goodbye building, and my building is gone. If you say, that's that's crazy. What do I do about that? You can set up a temporary and autosave in your Blender settings. So it automatically autosaves every now and then. So if you do that, you can get back to it. There are options to configure for that. So we have just a cube again. Now in this cube, in order to apply a texture to it, there are different ways, and different software handles this in different ways. So we're going to talk about the UV map. And let's go into edit mode here. And if I go to the U, if I press U, I get this menu that pops up here. And if I do Control E, I get a completely different menu. So why are there two menus and so many hotkeys and menus? Well, let's talk about the simple way and the more complicated way. If you say, I just want to apply a texture to this, you do what's called UV unwrap. So I hit U, and I do unwrap. And it doesn't look like that does anything. But I'm going to open up another window here. And I'm going to change this mode, oopsie, this one here, to UV image editor. And I just see a big block here. And on this, I can assign a texture. I'm going to open an image, and we'll go. Notice the file picker is not what you would expect to see. So the interface, again, is a little bit different. Now I have this basic cement mesh defined here.
Would you call that innovation or nonconformance?
Nonconformance. Innovation. I don't want anybody from Blender to get mad at me. Depends how you look at it. This is a hotly debated topic in the Blender community.
Yeah?
Yeah. It takes a little bit to get used to. Some people love the menu structure, the power of it, and that you can just duplicate, create new things anywhere. If you are jumping into it from another software that you're used to, it can be very difficult, and you can pull your hair out. So it just depends on how much you want to take the time to get used to the interface. I would recommend, as a very first thing you do, hop into an interface tutorial. It will make your life a whole lot easier.
Well, at least we can edit that since we're not live or anything, right? We're not live, right?
Wait. All right, so that's the basic way of assigning a texture. I want to talk about a little bit more complex way. And in this, what we're going to do is UV unwrap. And all this does, imagine if I had a logo I wanted to apply this whole cube. How do I stop it from wrapping from here? Let's say the logo says Blender. It might be BLE here, and then NDER over here. We can't necessarily control where that is, and it might be tough to see that ahead of time. So this is where UV unwrap comes into play. It tries to take each of these coordinates and unwrap it into something flat that you can give to an artist or yourself to fill in. So what I can do here, let's go into the I'm going to go in the edit mode by hitting tab, and I'm going to Control E for edges, and I'm going to actually go into Control tab, and I want to do edge select, so I can just select an edge when I want. And let's go Control E again. I need to mark a seam, so I'm telling Blender how to unfold this object. I've got a seam there and a seam there. I can fold this up, scroll the cube up, roll it over, and mark an edge here and here. We'll just do this to start. Then I hit U and unwrap. And let's go back to that same screen I showed you before. Opening up a new view, and down here selecting UV image editor. And something did not look the way I wanted it to, of course. My unwrap isn't looking the way I wanted it. So let's try one other thing so you can see what the smart unwrap does. Let me load up another building that I did save here. This one I made sure I saved before I exited. And let's go to a UV unwrap of this. I'm going to get out of quad view. And in here, let me select everything, load up my U menu, and Smart UV Project. I'm going to say, go ahead and look at all of my edges in here, and I want you to kind of figure out where you should unwrap this. And you're saying, well, what's this unwrap thing all about? UV, you said this had nothing to do with ultraviolet light. Let me open an image of that texture again. Select this. Now we can see what this looks like. Actually, before I didn't select my texture. I think that's why I didn't see everything loaded up here. So this is a flat projection of this entire building. Blender has come in here and said, oh, I see there's this vertex here, this edge, this edge, this edge. I'm going to flatten this out. Now this is pretty complicated, and there are a lot of edges in here. And any 3D artist that's probably watching this now says, there are way too many polygons in this object. You could have done this with a flat face here, a flat face here, which would make it much more easy for rendering software to handle, and it wouldn't look so ugly. And that's very fair. And that's the same way it would look with a cube. A flat face here, a flat face here. It's subdivided this because I started this out from a plane that had many divisions on it. But what I want to show is that Blender flattens this out into a 2D image. So I could give this to an artist right now, and they can actually paint the windows in here on each one of these. So this polygon right here, you can map over here, paint a little window, another window, and then it gets applied to your object. And that is how an artist will give you back your texture.
So in this case, it's a building, but that could just as easily be a character, like a monster or a human or something like that, right?
Could be a monster, could be a human. One of the demos that you'll see with Blender quite often, let me load up a new one here, is, let's go back to Info and go into our file, start this up again, load factory settings, add mesh, and down here, if you want to get a little bit experimental, you can see monkey. Monkey, that's right, monkey. So I believe the story behind this let me select all these, delete, and add the monkey again. Hello.
That's a fundamental shape, right?
I believe it's Susan or Suzanne is the name of the monkey. I forget. It's appeared in several movies. I think Jay and Silent Bob, this monkey was in. I believe that's where this monkey comes from. So it's just kind of a little bit of tongue-in-cheek humor that it's there, but it also gives you something to kind of experiment with. With this monkey, let's go into edit mode and smart UV project and bring up that UV. And now it's probably a good time to talk about why it's called UV, at least my understanding of that. X, Y, and Z are taken up in this namespace already. And so UV, think of it as kind of like an XY, but X, Y, Z are already taken up. So UV unwrap maps these points over to here. It's purely two-dimensional. Don't let the term UV make you think ultraviolet light. It's a completely separate subject. So this monkey here has been unwrapped, and we can see all the different faces here, all the different parts that make up that mesh. So an artist would come in here, do the eyes, nose. You can actually hand paint inside of Blender, and there are some software products that will allow you to paint a live mesh. Actually, Photoshop, I think, is one of them now that supports taking an object and essentially hand painting it. But you can do that inside of Blender. If you want to test your artistic abilities, you can come in here and paint it directly. I did see a really cool video on, I think it was YouTube, where somebody went in and they created a sword from scratch and started painting all the textures on there. It was a phenomenal video. So there's some really neat tutorials out there on using that. Once you have your object, though, you want to use it somewhere. And you can export to some common formats. So before I said there were some common formats that are used: 3ds, FBX, OBJ. So if you want to import these into a variety of software packages, you can use these formats. Unity actually supports natively the Blender format. So you can take this file and just save it. Call this monkey, save Blender file. And Unity can actually use that file all by itself. But if you wanted to import this into another 3D package to do some more work on it, you could just export this as one of the supported types, import it in there, and away you go. So that is it for talking about our 3D meshes and how to basically assign a texture to them, to look at a texture, what a texture is, what our UV mapping is. It's just a way that you can unwrap this three-dimensional object and apply some sort of texture to it, wrap back your object again.
So it sounds like it's quite a bit of work, but I might want to go ahead and create my own 3D model. If it's something that I can't find anywhere else, I can't buy, and I don't want to pay somebody to do, I might want to break into 3D modeling and create it myself.
Yeah, in fact, if you wanted to create your own basic world to a game, we saw creating some primitive objects on there and just extruding. You could create a rectangle, extrude that up, paint a little texture on there, take a picture of the wall out back behind your house, assign that texture, and now you have a wall that you can just tile and use inside of your game. So you can do some real basic stuff with it too if you want to create your own basic assets. Now with that said, there's probably 1 million free painted walls out there you can just download off the net on the sites I mentioned before. But it is pretty easy to create your own basic assets. Yeah.
They might not have your own custom graffiti.
They might not have your own custom graffiti. That's a very good point. A buddy of mine decided to make the area that he grew up into a game. So how are you going to get those pictures and that kind of thing to share it with your friends? Yeah, that's a very good point.
Yeah.
The graffiti.
Okay,
cool.
so should we wrap up the assets section and take a break?
Sure, let's talk real quick on learning resources for some of the 3D mesh, 3D assets. And you can go online training. There's plenty of sites out there. Many free tutorials. You can find literally thousands of them out there. There are some subscription-based sites which go into some very deep content by industry experts. Blender.org has tutorials on there if you want to get started using Blender. And one actually quick thing I want to show you real quick because it's a very neat project from Autodesk called 123D. It's a free application. We wanted to try to do something really fun for this demo late last night. Time didn't work out, but let me switch over to 123D real quick and show you what that application is. This will just take 1 second. So this here is 123D, and 123D allows you to take a whole bunch of images of a physical object. One of the demos here they include is a picture of a Buddha statue. And you take all these images around it, and then you send it to their site, and you can then export it. You can 3D print it, or you can export it and create your own mesh. So if you have something cool in your house, or you've modeled something, or you're playing around with a 3D printer, you can export those files here. You make something. You can take pictures of it, bring in these files, export your mesh, and you have a Buddha.
Wow, that's really cool.
We were going to try to do Michael last night. We're actually going to try to take a bunch of pictures and have Michael do a guest appearance in the game later on, but I couldn't just get enough pictures in the time and processing time.
we couldn't get passed through legal, actually.
That's funny. And on the right-hand side, you get some featured ones, dinosaurs. It's a really neat project. So if you want to play around with an easy way to create 3D meshes,
if you happen to have the Windows version of Connect, you can also download a package called Connect Fusion, and that will allow you to simply point your Connect at an object and kind of rotate it around that object, and it will capture a model out of that object. So we can turn real-life things into models now.
That's right. That's a cool project, too. Thanks for mentioning that. Alrighty. So in summary, you had some awesome work on audio, images, Inkscape, Corel, 3D assets. We looked at a bunch of different sources on finding those assets. They're very easy to find. There are many great free 3D resources and 2D resources and audio resources out on the net. And don't forget codefoster.com/media. It's the best collection out there.
If there's one that's not there, go there and leave me a comment. I'll add it to the list.
Yes.
All right. Thanks.
Thank you
for
very
the next
much.
module. We're going to break into Construct 2.
Yes. Very cool.
Hey everybody, and welcome back. Hope you enjoyed your break again. Adam and I in the seats again. Sorry, Michael. Michael's got a little bit of a break.
He'll be back soon.
No worries.
No worries.
Well, I don't know if you're like me, but this feels like the meat of it.
Yes.
We've done a little bit of the preliminary work. Planning is important. You've got to build your assets. You may not have a designer to pawn that off on.
Something's got to run your game.
Yeah. We've got to build a game at some point, right? Yeah. Okay, so what we've decided to do is start with Scirra Construct 2. It's just one of the engines. It's just one of the ways of doing it. Now, all of these different engines have their own very characteristic ways of working. So ultimately, you're going to have to choose which one you like the best. If you ask me, I'll say I like Construct 2 only because I know it. Of course, I can appreciate what the other ones do. If you ask Michael, he'll say GameMaker. And if you ask Mr. Unity, I'm sure he'll say...
Before Unity, I was touching both GameMaker and Construct 2, so I have an appreciation for those two. They're very good in their respective spaces. Yes.
Yeah, but we are going to start out with Construct 2. We're going to start out with a relatively simple demo, okay? Because we're going to have a bit of a progression here. So in this one, you're going to see a really simple demo, but I don't want you to think that that's because Construct 2 isn't capable of creating very complicated, robust, full-featured games. It really is. It's a very powerful engine. And so what I'm going to do is I'm going to show you some of the awesome games that have been created with it that are more than I could do in 30 minutes talking to you. So let's just go ahead and jump directly into Construct 2. Construct 2 is a separate download. This is not something that runs, for instance, in Visual Studio as a library or a framework. It's its own IDE. Now, to get that, all you do is you go to your browser and you type in Scirra.com, S-C-I-R-R-A, and click. Can anybody guess where I would click there? It would probably be the download button. You click the gigantic download. I love the download buttons. They're so much easier these days.
Depends who you ask. Some might say buy.
Probably the makers of Construct 2
That's
would
right.
say buy. You can click on download and you can download the free version. You can do your own research on the site. You can get a free package that'll come with certain constraints, but albeit they're generous with what they're offering you for the free version. In fact, you can put a whole app in the store with just the free version. Then you can get a personal license, and then you can get business licenses as well. So click on download. It's going to download the latest iteration. Scirra is really, I think it's an amazing team. They're based out of the UK. It's a small group, and they iterate really quickly on this software. And as you'll see in just a second, it's a really impressive package of software.
Definitely.
So, yeah.
Advantage of being a small group at times.
Yeah, right. Yeah, iterate really quickly. Okay, so let's go ahead, and this is what you're going to see when you first open Construct 2. This is Scirra Construct 2. It's got a nice, friendly interface. It looks at least remotely similar to applications that you've worked with already. Comes with a nice start screen, so you can get started with a new project, open an existing one, and it even gives you links to all of the tutorials for Construct 2. And one of the things I love about Construct 2 is that it has a lot of tutorials. And it seems like most of them take me anywhere from 30 to 45 minutes to go through, and I come out the other end just having learned a ton about what's possible in Construct 2. So I'm going to talk more about some of these different templates and stuff that are available in a little bit, but for now, I'm going to start with a brand new, fresh project. I'm going to hit New Project, and I'm going to create an empty project. Notice how long this list is of different kinds of things that I could create. But I'm just going to start with a new empty project because I don't want you to feel like there's any smoke and mirrors going on here. I'm going to go ahead and get that open, and we're going to start from scratch. So I just want to let you know where we're at. Actually, let me jump back into my slides a little bit, just kind of position us a little bit. And could we get the timers reset so that we know kind of where we're at? So we're going to start with, oh, sorry. Let me just get right back to where I was. We're going to start with the project setup, okay? And this is the sequence of steps that we're going to take in building our game. We're going to start with the project setup, and then we're going to learn how to create the hero of our game, and then we're going to learn how to control him too, move him around on the screen and stuff. We're going to spawn some enemies programmatically, so at this point we're going to be implementing some logic. We don't want to do this declaratively, we want to actually spawn some enemies logically, so that's that section. And then we're going to control the sizing. In this game we're going to be changing the sizes of things. And then we're going to look at the collisions. Of course, in a lot of games, there are collisions from one character to another, scoring of one. Maybe your hero collects things. Maybe he does something and he gets a score, and you want to relay that to the user of the game. Anyway, so these are the steps that we're going to go through. Actually, let me back up one slide here and look at the game concept. So here's the game that we're going to be creating. In this game, I was going to use a boat as the main character, but it doesn't really matter what we use. And so what I've decided to do is just go ahead and use the light bulb. We've already created the light bulb, right?
You have it.
Yeah. And it'll be nice for you to see end to end. Here's how you take a concept, turn it into art, and then go ahead and turn that into a game. So I'm going to go ahead and use the light bulb. And these light bulbs, it won't make sense because they're light bulbs, but these light bulbs are going to be, you're going to have a hero. We'll make him a different color so you can differentiate. And then we will introduce programmatically a whole bunch of other light bulbs, and we'll try to avoid the light bulbs that are larger than us and consume, eat, run into, collide with the light bulbs that are smaller than us, and that will make us grow. Okay?
It's a tough world being a light bulb.
It is. It is a difficult world, and everybody wants to be the biggest light bulb, right?
Yeah.
And then we're going to get a point for every light bulb that we consume, and if we get hit by a light bulb that's bigger than us, we get reset. And I think the strategy is you don't want to necessarily take the user out of the game and make them go through the process of starting the game over. You just want to reset them and keep them playing because then you keep them there. If you're ad supported, you want to keep them there at all times, right? You want them to keep rolling your ads. So that's the game that we're going to be creating. So we're going to jump back over into Construct 2. Here is Construct 2. Is everybody able to see that? There we go. And we've started a brand new project. And here's the first thing that I'm going to do. The first thing that I'm going to do is rename my project to something that makes a little bit more sense. So I'm going to right-click on my project and hit rename. And we're going to call this Bulb Battle. I just came up with that spontaneously. Bulb Battle. Thank you very much. I'm then going to rename the main layout here. So a layout is like the declaration of your programming assets. It's kind of analogous to an HTML file that declares what objects you have, whereas in the JavaScript, you're going to actually be writing some code for them. The layout is where you're going to be dropping all of your game assets so that you can actually see them. You can lay them out. You can see them against their background.
Would that be kind of like a layer in one of the image editing software where you have everything kind of dropped into a layer?
Yeah, you drop everything into layers. You can see it. It's visual. Now, if you want, Joe the light bulb to start moving around the screen, you can't just do that with the mouse. You're going to have to write some code, or at least implement some logic in some way.
Yep.
And we'll get to that in a minute. But for now, we're just declaring the assets.
Cool.
So that's the layout. I'm going to right-click on that. And I'm just going to call that main. Now, this is the only layout that we're going to be using in this game. But you could create other layouts. And in fact, in most production games, you will, because you want to take the user to a different screen. They're playing the game, and then they're at the start screen, and then they go to the high score layout, whatever. But in this game, we're only going to have the one, but we'll still call it main. Now, the event sheet records all of your logic. So this is how things happen, the conditions, the loops, the logic, okay? And normally, one event sheet applies to one layout. There's a one-to-one relationship. So I'm going to right-click and rename this event sheet, and I'm going to call it main events, okay? I now have Bulb Battle with my main layout and my main events event sheet, okay? Now, this right now is showing me my layout, and if I hit Control minus, it'll zoom out. Control plus will zoom in, and I can see where I'm at. Now, I get this white, looks like a piece of paper. That represents my layout. That's my main layout. I also have a little dashed line on there. Do you see the little dashed line? That dashed line represents the current window. So I know that I would only be looking at this section of the game, even though there's more layout off screen. Okay, that would be a scrolling game. In this case, the game would be capable of scrolling sideways or scrolling up and down. All right, that's a scrolling game. Now, for the sake of simplicity, we're going to keep this game so that it's not scrolling. That means that we're going to set the layout size and the window size to the same thing, and we're going to set them to something that works well with Windows 8. So, Bulb Battle, I go to the project itself, and on the left, I have the window size, currently 640 by 480. That's not the size we want. We want 1366 by 768.
Important numbers to remember.
Yeah, very important. You should commit those to memory.
Definitely.
Now, when I apply that, you'll see that the size of the window has changed, and it doesn't match the size of the layout. To change the size of the layout, I click over here on my main layout, and now I can go set my layout size to the same thing. Do you remember it?
1366 by 768.
Thank you, sir. tab to get off that, and boom, I got a layout that's the exact same size as my window. That means that I have a game that's not going to scroll at all. It's going to be nice and simple.
We should say it one more time. This is meant to, it's the 3-time rule, right?
Yeah.
1366 by 768.
Thank
one
you.
more
Say
time.
it 10 times quickly. All right, so we need to start declaring some of our game objects now. We need to start dropping some of our assets on the screen. Well, do we have them created? Well, we need Lightbulb Man. We need Lightbulb Man, and he was in CorelDRAW, right? We exported him at 30 pixels and at 9 feet. We're going to have to go do a little bit more work in that. So let's go ahead and get CorelDRAW back open. Did we save the Lightbulb?
I don't recall.
That was off. I don't think I saved the Lightbulb. Oh boy. That means we're going to have to recreate the Lightbulb in a hurry. Let's do that. Okay, so remember, and this is for review. Here's the bulb. Here's the stem. Line the two up using highlighting multiple objects using Shift, and then highlighting multiple, and then pressing C to line them up. And then we weld them together by selecting them and hitting Weld. And then we created a rectangle to form the threads. We centered that with our object. We made multiple copies of that. Actually, before we made multiple copies, we first rounded the corners of that, and then we skewed it. So to skew it, I click twice on it, and then boom. Now I'm ready to make multiple copies. There we go. Now for our hero light bulb, let's make him green. Just kind of feels like a hero. Green light means go, right? Whatever. I'm actually going to fly out this color chart, and I'm going to choose a color of green that I want. That's pretty nifty. I actually want to shrink up this part of the bulb a little bit, create myself a rectangle that goes here on the bottom, is centered, and turn that into generic curves and grab a couple of those vertices and resize those vertices to make it taper. Turn that one gray as well. And there we go. We've got ourselves our light bulb.
He needs a he needs a cape and a nickname of Retrobulb.
All right, so for the hero, let's make a cape. Hey, you ask and you shall receive.
Very nice, very nice.
How red is this cape? There we go. I'm going to need the cape to taper a little bit, so I need to convert that to curves. Resize just those top two, bring them in a little bit, center that. And do we want to look at his back, or should let's go ahead and hit Shift page down to bring that to the far background, and now we have a light bulb with a cape.
That's awesome.
Now one more consideration. Thank you. One more consideration is the objects, the characters. When you export them from your graphics software, you have to consider how the game engine handles it. And in Construct 2, it considers that your object should be pointing to the right to be at 0 degrees. Okay? Some say up is 0 degrees. This one says to the right is 0 degrees. So I'm going to go ahead and point it to the right. That's the super bulb flying to the right to the 0 degree direction. So let's go ahead and export this as is. I'll put this in a temp folder that I have, and I'll call this super bulb. And it's going to be a PNG, and on the next screen it's going to ask me what size to create that. And I'm actually going to make this relatively large because in this game, super bulb is going to be growing, and we want him to always look good, even when he's gotten quite large. And he'll shrink down and look all right, but we don't want to make him too small so that he would expand and look really bad. So I'm going to make him 600 pixels wide. And now we need to create a derivative of super bulb that I guess this would be called Bulb Luthor. Is that right? This guy does definitely. Does he have a black cape? Does Luthor have a cape? I don't know.
Why not?
Okay, and let's make him red. The universal sign for evil. Okay, there we go. Let's call this Bulb Luthor. There we go. Invisible background, he's also going to be able to grow, so we'll make him 600 pixels. Notice it chooses the height automatically based on the aspect ratio. It's transparent. We've got both of our assets.
That's cool.
Yeah. So now here we are back in Construct, and we want to bring these assets into the game. There's a number of ways to do this. you can actually just drag assets in, and in fact, that's the way I would encourage you to do it if you had an animated asset. So if we had Super Bulb with a flapping cape, and we had time to animate that, we would create all of those frames of the flapping cape. We would have an array of PNG files. We would highlight them all and drag them into the game, and it would automatically create that, not as a bunch of different sprites, but as one sprite with an animation.
Automatically.
Automatically.
That's awesome.
Or automagically.
Automagically. That's definitely magic.
So, but I'm going to do this a little bit different way. I'm going to right-click, or I can actually double-click anywhere on the game board, and it'll allow me to import a sprite, create a new sprite object. So I'll create that sprite, and I have a chance to name him. It's a really good idea to name your sprites in the game because you're going to be interacting with them programmatically, and you want to know their name. So this is not Superhero, this is Super Bulb. Insert that. And it asks me where to put it. Notice it's asking me, it's telling me that it's going to put it on layer 0. That's important if you're going to get into multiple layers. The layering in Construct 2 is actually really good. It allows you to do certain effects to an entire layer at a time. Maybe you put all your enemies on the same layer, and you can grayscale all your enemies. Or you can make multiple layers of background, and then you can actually have a parallax scrolling of your background so that you add another three-dimensional like effect. Not that it's
very
truly
cool
3D.
visual effects, yeah.
Yeah. I'm just going to click, and that's going to bring in a new sprite. And now Construct 2 gives me a way to create images here. Like I could paint on this if I wanted to, but it's pretty rudimentary. You probably want to use your own tool, Inkscape or CorelDRAW or whatever, to create it, and then just bring it in. So I'm going to load an image from a file. That's here. And I'm going to go find that file on the disk. And that was superbulb.png. It brings it in. Now notice that I'm going to go ahead and make this just a little bit larger so you can see it. Notice that I'm seeing a little blue overlay. This overlay is the collision map for this sprite. And it's intentionally simplistic. It only has a handful. It looks like we've only got 8 vertices in our collision polygon there. And that's good. You don't want to have to do too much math behind the scenes for collisions. In fact, you don't have to do any math. Construct 2 handles the math for you, but you don't want the JavaScript to have to work too hard to figure out if things have collided. So I could go and create a really definite collision map around my shape, but I shouldn't necessarily. Usually for your shape it's just fine, but you might want to tweak it a little bit. So I'm going to move these out just a little bit, move this one. You don't want to, it'd be better to have it optimistic and allow for, notice that this is not going to be considered a collision if there's a very small collision on the top there. So anyway, whatever you choose. There's another button in here that is the origin and image points, and that's important because that's going to determine the point about which your object rotates. That's the origin, and it's also going to allow you to specify multiple image points, and those can be places where action happens. So maybe you have a sprite with a gun, and you want to generate a bullet out of the tip of the gun, and you would create another image point at the tip of the gun so that when you generate a bullet, you can generate it at that image point. I'm going to move this origin so that instead of centering around the true center of my sprite, I'm going to center around the light bulb, because that kind of looks like a good place to rotate around. All right? That's all I really need to do for this bulb. I don't need to worry about the fact that it's really big. If I do have big expanses of white space above or to the side of it, I can crop it. That's a really good idea to do. I can go ahead and close this, and now I've got my light bulb. It really doesn't matter either what size my light bulb is in my layout here, but I should keep it proportional. So if I want to resize it for visual sake, keep your finger on the Shift key and keep it proportional, okay? So we'll go ahead and make Super Bulb pretty small. And there he is. That's Super Bulb. I've brought him into a blank layout that's ready for Windows 8 as far as the size goes. Let's do it.
Let's do it.
Let's press F5 and run our game.
Go
There's
Super
F5.
Bulb.
Now what happened here? This actually opened a browser. Construct 2 creates games in HTML and JavaScript. And so to preview them, all you really need to do is open in a browser and look at it in the browser. Okay? Now when we're ready to package this up for Windows 8, we'll add some more Windows 8 characteristics to it. But for now, it works just fine to preview it in the browser. And Construct 2 is perfectly aware of all the browsers out there, and it'll allow you to preview it in whichever one you want. But notice that I am currently at localhost 50000. That's a temporary web server that Construct2 has set up for me.
Very cool.
Yeah, super cool. So there's Bulb, there's Super Bulb, and he's attractive, if I do say so myself, but absolutely incapable of moving, which is not a good feature of a superhero.
No.
If I use the arrow keys on the keyboard, he doesn't respond. Also not a good feature in a superhero. I can't use the mouse. I can't drag him. I can do nothing with my superhero. He's
sleeping.
He's an invalid. He's sleeping. It's sad. So I need to give him some movement. Now, if you were making a game using a library or even a framework, or if you were just writing the whole thing yourself, adding movement to a character in response to the user on the keyboard or the mouse or whatever is not a super simple thing. You have to add some variables that store the velocities in the x and y direction, and in your game loop you have to look at these velocities and you have to advance the position of the character. You have to do some work and you have to respond to some events on the keyboard. There's a lot of things to do. But when you're using an engine, it's a lot simpler. I'm going to go back to my declarative mode here, my layout, click on Super Bulb, and then over here on the left in my properties bar, I have a list of the behaviors assigned to this sprite. Currently, none. But I'm going to click on behaviors and then add, and I can add a behavior. Now, a behavior is just a collection of code, basically, that applies to any given character. All right? For this one, I'm going to add the 8-direction behavior. Now, 8-direction behavior allows your character to move in any of the 8 directions. Actually, it transitions real smoothly, though, so it looks like he's able to move in 360 degrees. But it allows you to control his motion in 8 different directions. So you can use the arrow keys on the keyboard. You can use the D-pad on the number pad on the keyboard, things like that. Okay, so let's just go ahead and add that direction, or that 8-direction behavior, close that out, and hit F5 again. Now sometimes, at least in my experience, sometimes the browser caches and you don't have the newest version of your game running. All you have to do is hit Control F5 in any of the browsers, and that'll do a forced refresh and make sure that you have the latest version. And now, using the arrow keys on the keyboard, I'm able to fly around on the screen.
Go Super Bulb.
Go Super Bulb. He doesn't look fast enough for a superhero, but we can fix that pretty quickly. He is also able to fly off the screen, which oftentimes is not your intended behavior and makes it pretty easy to lose your superhero. Not a good feature of a citizen. So I'm going to add another behavior. Back to behaviors, add, and there is a bound to layout behavior. Keep this guy on the layout. Remember, the layout might be bigger than the screen, but in our case it's not. Run this, and superhero flies and bumps up against the edge of the screen. That's the gameplay that we want, okay? He is confined. All right. Now, he's bumping up against the edge of the screen. He's able to move in any direction. He doesn't move as fast as we want, but the speed at which he moves is a property of the behavior that we gave him, that 8-direction behavior. And so it appears in the properties bar over here, and we can actually go right over here to the max speed and say, this guy should be able to fly at 800. 800 what? 800 speed units. Don't worry about the units. You'll quickly come up to speed on what those are. It's actually relative to pixels and ticks, and it's scaled and so on. Just know that 800 is fast and 200 is not as fast as 800. How fast is his acceleration? Well, we want him to be able to get going really quick. So let's accelerate him at 1200 acceleration units. Let's go ahead and run that. And now he's able to get going faster, and he's able to go faster.
Look at him go.
Yep. He's I would say he's flying now. Okay, so we've got our superhero. He's able to move. There's nothing to do. We're going to have to create some enemies. Now, we only have one hero, so it wasn't hard to create him declaratively, but we're going to have lots of enemies in this game. They're going to be flying around from every different direction, okay? And so we don't want to create those declaratively. We want to create those programmatically, say every half a second or so. We want to create a new one, generate it, and have it fly onto the screen. So let's do that. So what I'm going to do is I still need to declare one, but I just don't need to put him on the screen. So I'm going to double click, bring in a sprite. We'll call this Bulb Luthor. We'll create it, bring in, And this is recorded, so if I move a little bit too quickly on some spots, you can always go back and rewind and watch it. So bulb Luthor is a PNG. It's quite large. It's cropped well. If the origin point, let's go ahead and move that origin point to about the center of the bulb. The collision polygon looks fine for us. Let's close it. It's too big. Let's go ahead and shrink that down using the shift to keep the aspect ratio. Now I'm going to move it off the screen. Why would I do that? Because I don't actually want to show this one enemy right when the game starts. I want to show no enemies. Okay? So I moved it off the screen, and now I'm going to introduce it programmatically. And here's where we break into events. Events are your programming. They're your logic for your game. And remember that your events happen on your event sheet, and that happens behind your layout. If I look at this layout, the main layout, notice that it says its event sheet is main events. So that's how they're associated. So I can open main events, and what am I looking at? Nothing.
Nothing.
Just blank. There are no events right now. If you want to create an event, you click on Add an Event. I'm going to zoom in just in case that's not entirely apparent. There's a little Add Event link here. And when I click on that, it brings me into a dialog, an interface, a wizard for adding a new event. Now, the event that we want to create is essentially this. Every half a second, I want to create a new enemy. All the events work as such. There's some condition on the left, and then there are some one or more actions on the right. Whenever the condition is true, the actions happen. Okay? That's the way events are structured. The condition is what it's asking me for about right now. It's what it's asking me about. And so the condition is, it's actually a system level thing. I'm going to double click on system, and at the bottom there is every X seconds. Okay, so this is like a system level event, every X seconds. Now I'm defining the action that I want to happen. Actually, I'm actually right now defining a parameter for the every X seconds condition, and that is how many seconds are you concerned with. I'm going to do 0.5, done. And now I've created myself an event that has one condition but does not yet have any actions. Now every half a second, something's going to happen. What is it that you want to happen? You add an action. So I'm going to click on Add an Action. What do I want to do? I want to create a bulb Luthor, a new instance of a bulb Luthor. You'd think that I'd start there, but this is a little bit tricky. You don't. You start with System again because it's under System where you have the ability to create an object that doesn't yet exist. So I'm going to create an object. Next. Which object? I get to choose. I want to create a bulb Luthor. There it is. On what layer? 0 is fine. That's the only layer we're using. Where do you want to put it? 0, 0 would put it at the top left corner. 100, 100 would put it down into the right a little bit. Let's just choose that for now. Done. Now, bulb Luthor, if I run this now, they're getting created one on top of another, but you can't tell because they're not doing anything. They're not moving anywhere. So let's actually give the bulb Luthor the ability to move. Now I gave Super Bulb the ability to move by giving him 8 direction because I needed him to be able to be controlled. But bulb Luthor, I'm going to add a behavior, and it's not the 8 direction that I want. It's actually bullet motion. So bullet motion isn't controlled by the user. It's controlled programmatically, and it generally moves in a linear fashion. So I'll add that. Because I added bullet motion, I now have, for instance, the bullet speed and angle and so on. And it handles a few things for me, like it points these guys in the right direction. So let me just run that now, just after adding that behavior. And you can see that my bulb Luthors are actually moving now. Their default angle is 0 degrees, and they're moving at their default speed of 400, and they're getting generated every half a second. Okay, so let's figure out how to give these a little bit more intelligence. They're getting created. They're on the screen. That's great. But we need to give them some more intelligence. And to add intelligence, you're always going to the event sheet. So on the events, every half a second I create a guy. But what I actually want to do is I want to create him, and then I want to move him to his right place. So when I create him, instead of creating him at 100, 100, let's create him at -100, -100, so that he's off the screen. And now, shortly after, very, very shortly after he gets created, we want to move him to the right place. Now here's what we're going to do. We're going to move him, we're going to generate him essentially in one of the 4 sides of the screen and have him move onto the screen. So I'm going to move a little bit quickly here, but once again, you'll be able to go back and review. so I think it should be okay. I'm going to add a global variable to my event sheet by right-click, add global variable, and I'm going to call this the spawn location. It's a number. I'm sorry, I want it to be text. Okay. That adds that at the top of my event sheet. That's where all my global variables are. And now, after this gets created, I can do what's called a sub-event. Right-click on this little handle over here. You can't right-click here, that's on the condition. Or here, that's on the action. You have to right-click over here on the event handle. And then you can add a sub-event. There's a shortcut for it, which is pressing the letter S. So I can click on that event and hit S. And when I add a sub-event, it immediately asks me what's the condition. Well, I can check to see what my spawn location is. Well, first I'm going to have to set my spawn location, so I can add that here. I'm going to add, I've got a spawn location as a global variable, so I'll go to the system level, and I'll set the value of spawn location. Notice that it's the only variable now, so it was on there by default. And I'm going to set it to one of 4 values. There's a choose function to make that nice and easy. I'm going to set it to top, right, bottom, and I'm just using the prefix, or left. Okay, so that variable is going to get one of those 4 values. Now I can add my sub-event, and I can go to my system, and I can compare a global variable. Compare which one? The spawn location to. Is it equal to top? So now whatever actions I define here are going to occur if the randomly chosen spawn location was the top of the screen. So what do I want to do here? Oh, I want to change the position of my Bulb Luthor. I want to generate him somewhere along the top of the screen. So I'll go to my Bulb Luthor. Here's a little shortcut. You can type in something like set position, and it brings up the actions that match that. So it makes it nice and easy to use your keyboard. Where do I want to put him? Well, before, remember, I was putting him at a set location. Well, now, in the Y direction, I want him to be at 0. That's somewhere along the top of the screen. And in the X direction, I want him to be random, somewhere between 0 and the width of my layout. Okay, so that means I'm going to place him somewhere along the top. Now, if he gets generated at the top, we want him to be moving initially, generally in a downward direction. So I'm going to add another action, go to Bulb Luthor, and I'm going to type in angle, and you're going to see that there are a couple of different set angles. There's one for setting the angle of the position of the character, but we're actually interested in the angle of his motion. So I'll go to set angle of motion. Keep in mind, this property only exists here because we gave him the bullet behavior. So set the angle of motion. We'll set that to random between, if I do 135 to 45, or I could do that backwards, whatever, 45 to 135, that's going to be somewhere generally downward direction because 0 degrees is to the right and 90 degrees is down. So it's within 45 degrees of 90. Hopefully that makes sense to you. Now I want to do the same thing for the other 4 sides, except change them up a bit. And in the interest of time, we're going to be moving a bit quicker here. So this is the right direction. This is the bottom of the screen. And this is the left side of the screen. And if he's spawned on the right, then I want my position to be X direction of layout width, that's on the far right, and my Y direction to be random between 0 and layout height. Notice the IntelliSense, very helpful. If he's on the right, his angle of motion should be random between 135 and 215. Notice I've done this before. I'm not just doing math extremely quickly. If he's on the bottom, his X should be random from 0 to layout width, and his Y should be layout height. His angle of motion should be generally up, so it should be anywhere from 215 to, 225. Did I do that last one wrong? It'll still work. To 315. And if he's on the left, we want to set him at X of 0 and Y of random 0 to layout height. And generally moving to the right. Little trick on this one, random between 45 and minus 45 will work. Cool. Now let's run this. And we've got characters coming in from all 4 sides of the screen randomly.
That's a lot of bad guys.
A lot of bad guys. Yep, we're going to have to avoid those. And I can already move, so I've got a game here trying to avoid bad guys, but we're going to make it a bit more interesting here. So one of the things that we're going to do is we're going to allow for the adjustment of the size of things on the screen. So I'm going to add a global variable. I'm going to call this initial size. I'm doing all caps because it's just by convention, because it's a constant. And I'm also going to set another global variable called the scale multiplier. And I've found that what works well for that one is 0.04. It's also a constant. So I'm creating some constants that, as you've seen, I can use in the various conditions and events, conditions and actions in my events. So now what I want to do is I want to determine when the layout first starts what size my main character is. Well, my main character needs to have a custom property called size. It doesn't have one by default. And I can do that by clicking on it, going to the instance variables, and adding one called size. It's a number. And my enemy has an instance variable, also called size. It's a number. Keep in mind, you can do this using families, where if things are related, you can group them into a family and apply certain logic to multiple things at a time. But that's not supported in the free version, so I don't want to show that here. So now my main character and my enemies both have a size variable. So now I can flip back and I can say when my layout first loads, so that's going to be a new event. Notice here's one event. I can collapse it. I'm going to create a new event and say system. And in system there is a layout on start of layout. Okay? I like to move this one up to the start because it's on start of layout. On start of layout, I want my super bulb's size to be set. So I'm going to go to set the value of a local instance variable. I want to set his size to the initial size. Okay? That's how I get him to be whatever size I want him to start out as. And the initial size, by the way, we'll start that out as 4. This way, I have an abstraction on the size of things where I can set the size of my hero to 4 or 10 or 20, and that can be directly comparable to the other characters in the game, even if they have their own scale multipliers. Okay? Okay, so I've set the size of my main character. Now what I want to do is set the size of my enemies, and I do that when I first create one. So I'm going to add an action right here whenever an enemy gets created, and I'm going to set the size, that is set value of an instance variable. I'm going to set it to what? What size are enemies when they're created? Let's make it random. Random between 1 and 10. Okay, now I'm setting the variables of this hero and these enemies, but that's not going to do anything right off the bat because I'm just setting a variable. In order to make that actually affect the size of the character on the screen, I actually have to change their scale value. So down here at the end, I'm going to create another event. This one's important. This condition is important. Notice that this event sheet it's not so much linear. It doesn't really matter where things are because this event sheet is running at every single game tick. This is the game loop that you're looking at. And if you want something to happen in every single tick, you double click on system and you say every tick. Every tick, what do I want to happen? I want my super bulb, I want to set his scale, and I want to set his scale to be the scale multiplier times his size. Well, what's his size? His size, I can either use his name, superbulb, or in this case I can use self.size. That's his instance variable that I created.
IntelliSense, that's great.
IntelliSense is wonderful, yeah. So now that's going to scale him relative to his size. And so if he goes from 4 to 5, he's going to be scaled correctly. Also every tick, I'm going to set that for the bulb Luthor. Now, if you're tuned in, you're thinking, how do you know which bulb Luthor? There's tons of them on the screen, right? Well, if you don't specify, then it means the object. And it means all of the instances of that object that are currently on the screen. So if I set the scale of my bulb Luthor to the scale multiplier times, it's weird that the words bulb Luthor and super bulb are just flowing off the tongue now. So I want to set it to bulb Luthor's size, and I'm done. Now, every single tick, it'll make sure that they get changed to the size that they are, okay? Now, that does it for that. Let's hit F5. Now my guy is scaled to a certain size, and look at this. My enemies are random sizes between 1 and 10, right?
That's cool.
Yep, now we're going to, oh, he hit me, but there's no collision, so it doesn't matter. I can run into things and it doesn't even matter. So we need to implement collision very quickly. Always very quickly, we're always running out of time. So real quickly, let's implement collision. Now with collision, you start with an object, so let's start with superbulb and type in collision, and there's an event on collision with another object. Double click, which object? Well, when he runs into bulb Luthor, I want something to happen. So that's the condition. And now over here in the actions, what do you want to happen? Well, if they collide, I really don't know what I want to happen yet until I determine who's bigger. So again, I'm going to create myself a sub-event. Okay? This sub-event is I'm going to use the system and compare variables, and I'm going to look at the sorry, I did that wrong. I'm going to compare two values, and I'm going to look at the super bulb's size and see if that is greater than or equal to bulb Luthor's size. If that's true, I was bigger. What do I want to happen when I'm bigger? Well, let's say that bulb Luthor gets destroyed. Destroy. That instance will go away. It'll disappear. Maybe I want to spawn another animation and have an explosion appear or some kind of thing appear. But anyway, he'll get destroyed. Now, what do I want to happen in the opposite case? Well, for that, I can right-click on this event and say add an else. This means I was smaller. In that case, let's reset super bulb size to the initial size. So let's set the value of a variable, and that variable is my size, and I'm going to reset it to the initial size. All right? So now, if I'm bigger, he's gone. And I also, if I'm bigger, I want to increase my size. So I want to add to the size variable 1. So now I'm going to grow. I'm going to get a little bit bigger. For the purpose of illustration, let's get quite a bit bigger and see how this works. Let's go ahead and run this game. There we go. I'm as big as I am. My characters are that, and every time I eat one, I grow. Now, the thing is that I don't have great gameplay yet because pretty soon I'm the master of the field.
Pretty soon you're going to be the 9-foot bulb.
Exactly. Now all I have to do is sit here, and pretty soon the whole screen is going to be green when my character grows so huge. I like that little shimmy. Okay. So what I'm going to do is I can adjust this and grow only the certain amount, but watch this. When I create an enemy, instead of making him a random size between 1 and 10, let's make him a random size that's relative to my superhero size. Superbulb dot size -5 to superbulb dot size +5.
That's pretty neat.
There we go. Now the playing field is level. I can't eat him. It looks like I can eat him, and I did, and I grew. I have to avoid him. Oh, I got him, and I got him. Whoa. Avoid him. I think I can eat him. That's the magic of this game, is trying to figure out who's bigger. Oh, and then he got me. So look at that little tiny guy. He got me, so I get reset to my initial size, and that's it for the game. There's some more steps that we can take to add some scoring and so forth, but hopefully that's plenty for you. So what I'd actually like to do now is show you a couple of other games that were created with Construct 2 so that you can tell what else this game framework is capable of. I'm sorry, this game engine. See, I did it. So I'm going to take you to my start screen. On my start screen, I just pinned a bunch of games that were all built using Construct 2. These were all actually finalists in a competition that Scirra and Microsoft held over the summer, where game developers created these games and then they got judged, and these ones were all finalists or winners in that contest. So I'm just going to show you a few. This one is called Headless. We've got ourselves a chicken, and notice they have good graphics, and they make it a point to tell you that you can use your tablet, your mouse, or your keyboard. That's important. And in this game, I'm just going to turn it up so you can hear it over my microphone. I'm going to fly.
Good music.
Get some more blood, and I got to get some more blood before I run out, because I do, after all, have a missing head. Want to make sure I don't run into any fences.
There's that parallax effect you were talking
There's
about
the
earlier.
parallax. Look, the background is moving at different speeds. That's really important. Feels good. I don't know about you, but I feel good right now playing Headless.
I'm feeling hungry for chicken. I don't know.
Yeah, I feel like chicken too. I noticed, I think that Chick-fil-A was a sponsor on that. It looked like. I don't know. Maybe that was a joke. Anyway, look at this one. This one is using a framework, a template that comes with Construct 2 for creating tower defense games. So this allows me to move these towers that all are different immune system components, and then the germs come through your digestive tract, and you're trying to kill all of those. This one's fun. I actually, in preparing for this, I got a little behind because I kept playing this game. This is a really fun game. And there are a lot of things that you can buy, like antibacterial pills and all kinds of stuff. Let's keep looking. Okay, so how about Battle Space Commander? This one's really impressive. This was one of the top, if not the top. I don't remember which one was the top, but this one's super impressive. You can log in if you feel like it. using any of the major authentication providers. It's constantly firing for you, so you don't have to worry about it. You can fly around, and you've got to make sure you take out these rocks so that you don't collide with them and damage your shields. You also have boosters, so you can get going faster. Let's find some. Oh, there was a ship. Let's find that ship. We've got to kill one thing before we're done with this demos.
I don't know how they made this game, but this almost looks like a good example of taking a 3D object, flattening it to something that looks really good 2D, and using it in a 2D game.
Agreed. Yep. So that's Battle Space Commander. Very good. This one's creative. This is called Waterfall. Oh, it's very soothing music and a nice graphic. It makes me calm. That's good. All right, and when we play this game, we play a level. It remembers your levels, and you're trying to split this water up. I'm not good at it yet. And you're supposed to water all of your plants. There we go. I've watered both of the plants, so now I can continue on to the next board. Very creative. They did a good job with that. And that can be made with the same framework. This is Sauce Park.
Sauce Park.
There we go. I mean, there's nothing like shooting athletic equipment with condiments. I mean, if you want random, you've got it right here in the form of Sauce Park. And explosions to boot. Come on. Bring it on. I've got my ketchup. I'm ready. Come on. There we go. Soccer ball. No, sorry. Baseball. Thank you. Thank you, tech guys.
He's on fire.
He's on fire. Very good graphics. You've got some good audio in there that really makes that game stand out. Also, of course, made with Construct 2. There was another one I wanted to show you here. Actually, two more. This one is Numbers. This one's good because it's a real departure. Actually, I think this is the one that won. This one, they did a really good job. You're dropping numbers down, trying to get things to stack up, and then you can reduce the numbers by touching them and then get things to disappear. So a little bit of a Tetris knockoff, but with you actually have to use your brain because you got to do a little bit of math. So very different looking, that one, and I really like it. And finally, Mortarmelon. This one actually wasn't in that contest and in the finalists, but I noticed this one before, and so I want to show it to you because it's pretty creative. It's a little bit Angry Birds-ish, except you're launching a watermelon. Once again, random's always good in the game world. You're trying to get it through these fields, or through these levels, and get as much fruit as you can and get it into the basket. So, voila. There we go. That's what Construct 2 is able to do. And now we're going to continue on with a little summary of what it is that we saw in this breakout. This was dedicated to Construct 2. We looked at, and we didn't see the breakouts on the way. We just got busy writing our game, which is cool. But we saw the project setup, creating and controlling the hero, spawning our enemies, controlling the size of everything, handling collisions, and we didn't make it to the scoring section, but we might see that in a subsequent one, or you can look up some very good tutorials online about that.
Very nice.
All right.
Very cool session.
Whew, that covers it.
Yep. I love the cape on there. I'm still. That was a good addition.
It was perfect because it looked like the light bulbs were flying.
Yeah.
So.
Yep.
Okay, let's call it. I hope you guys join us for our next session. We're going to be stuck in 2 dimensions still, looking at GameMaker, and we're going to have a good time. So join us. Take a little break. Oh, I'm sorry. This is not a little break. This is a meal break.
A little longer.
So we're going to take a little longer break. So if you're joining us live, it's going to be a bit longer. We're going to go have some lunch, and we'll be back at the top of the hour.
See you soon.
Welcome back. Hopefully you had a great meal break. We're about to get into, personally, something I think that is very exciting, and that is the topic of GameMaker by YoYo Games.
You may have a slight bias.
I do have a slight bias, and I'm okay with it. I'm quite all right. So let's go ahead and take a look. We've already, of course, considered Construct 2, another 2D game engine, and now we're in GameMaker. And then, of course, following me will be Unity, and then we'll wrap up the day with monetization and store submission. But this is what we're going to do right now. We're going to get into some GameMaker essentials. And the good news here is that because Mr. Jeremy set the precedent with Construct 2, you're going to find that I won't have to re-explain certain things about Construct or about certain assets or things because he already kind of talked about that. I really like that. So I can spend more time in GameMaker, and I'm going to try to up the demo a little bit over Jeremy. I don't know if I can, but I'm going to try. It's a little friendly competition, but you'll be the judge. Let's find out.
I wouldn't call it friendly.
Okay, so I'm going to get now into my GameMaker. Now, can you see my screen?
I'm seeing the Bing.
You're seeing the Bing. This is unacceptable.
See, I don't know what that is.
Jeremy's like, I already one-upped you. Let me just make sure that.
So you've got that application on your computer that automatically sets the Bing picture of the day as your wallpaper, I think, right?
I do. I actually like it.
Yeah, it's pretty slick.
Okay. Does that look better? Except I need to change just briefly. Sorry, folks. This is so that your viewing pleasure is fantastic. Are we good? Can you see this box floating around?
I see it.
Yay!
Looks like a new project to me.
All right. So the first thing I want to talk about is where do you get YoYo Games? GameMaker. So I have the URL at the very top of the screen here. Let's see, YoYo Games GameMaker Studio. And if I bring this down, you'll find out that, of course, they are talking about all the various features that they have with their GameMaker product. But this is the family right here. And I'm right now using a version that is, I'm actually using one similar to the Master Collection. But everything I'm going to be doing in this, you could do with the free version. Everything. So, you'll enjoy hearing that. Plus, the exports to the Windows 8 are free, meaning that you can export to the Windows 8 store without having to purchase the standard or the professional studio. That is really cool. So if you want some more details, just check out that website. Now, back to GameMaker. I have it open, and this is what I want to do. I want to create a game from scratch. I'm not going to start with any starter template, nothing. Let's see. I'm not going to call mine anything to do with bulbs or lights, or I think this is going to be called something like Interstellar War. Yeah! Woo. What do you think about that?
Epic.
Okay, so here's the first thing I think that is important when you are doing anything at all in this environment, and that is understand what assets you're going to be using. So I'm going to go over to the sprites area, right-click sprites, and I'm going to create a sprite. I want to, first of all, focus on the sprite that will be the graphic representation of this spaceship that we will be controlling in this game. So I'm going to, for naming convention, SPR_player, and then I would like to load this sprite. Now when I click that, it's going to take me to my folder area, and I have this gaming assets folder that I already created, and boy, I tell you what, if I could just pause here and just say something so important about this particular thing. If you are going to be starting a game, don't start by opening up the tool and then get started. That's not what you do. You get your assets done first. That's what you do. Because now it's just glorious right now. You could just use them, and you're going to have so much fun. Otherwise, you'd get there and go, oh, I got to go create my graphic. Oh, no. You don't want to do that. So let me go ahead and start off with the ship right here. Open it up, and then it brings it up into my sprite properties area. Now, the thing I want to do here is I kind of want to create the game where most of the graphics and so forth are going to be about 64 by 64 pixels, and this is a lot bigger than that. So I'm going to edit this sprite. I'm going to go over into the transform area and stretch it. Say I don't want to keep that aspect ratio, but I want this to be 64 by 64. And I want that to be an excellent quality. Boom. Brings it there. I might say, you know what, and I also kind of would like to do something with this image, and that is go in here, maybe change the color partial like this color right here. I'm going to eyedrop it like that. And now I'm going to change the new hue to something maybe a little bit more bluish. So I have the ability to even just make these on-the-fly changes to existing graphics. Really cool. Now I'm going to say OK. Have my nice little ship done, and I'll go ahead and say good. I'm done with that. And the next part, you heard Jeremy talk about this in Construct 2. We need to think about collision, but we actually worry about that right now. So I'm going to go into the Modify Mask here. Actually, after I click Center, so I'm going to put the center of the object right there where it is, so you can see the little crosshairs. I'm going to modify the mask, and I have so many options I can use for what represents. Now, I could use something called Precise, and notice here, when I do that, if I zoom in, man, it is precisely that ship. But if I do that, that introduces a little bit more work behind the scenes. If it's not necessary, I won't use that. Instead, I'll use something like maybe, hey, diamond is pretty good. That's close enough for me. I'll use that for my collision. That means if anything hits in that area, then that means it was a collision. So I'll say OK. So I've taken care of that. I say OK. Now I'm going to move on to my next sprite. I'm going to create a sprite now for asteroids. SPR_asteroid. Once again, I would like to load a sprite, but I'm going to do it differently this time. I'm actually going to edit the sprite and then choose from this editor that I'd like to create one from a strip. What does this mean? Let's find out. Here's my asteroid sheet. And by the way, all these resources complement so that resource media site on codefoster.com/media. Open up. Number of images. Well, it looks like I have 5 across and 6 down. So that gives me 30. I know that there's 5 in every row, and I know I want this to be 64 by 64. I'll say OK. And what will this render for me? How about one of those? A nice turning asteroid. This is great. Look how easy that is. Say OK. Once again, I'll center this in proportion, and with regard to modifying its mask, I will use an ellipse. That'll work for me. I could even, if I wanted to get real fussy, I could turn in here and I can worry about this area. But remember, it's revolving. It's an animated thing, so it's probably factoring all of that area too when it gets spun around. So I'll just leave it the way it is and say OK. And done here. I also want to add another sprite that's going to represent explosions. SPR explode. And say OK. Or no, I'll edit this sprite as well. Same thing here. I'm going to create from a strip. Here's my explode. And say open. And same principle here. I got 4 by 4, so 16 in the map. Images for 64 by 64. And there we go. Now, there's my preview. Ooh, nice explosion. Excellent. Check that. Got that rolling. The only thing I have to do now is I don't have to worry so much about the mask of it because it's not really going to be something that you run into. It's something that happens when you run into something. So I'll say OK. And we're good there. Now, of course, I'm also worried about my sounds. And this is what I like about GameMaker right here. I just follow these little menu options down and start loading my assets accordingly. So I'm going to create a sound. I'm going to call it SND _ let's say blast. And then I will find this in my gaming assets. I have a blast MP3, and I'm going to open that up. And everything's good there. I'll just say OK. If I want to hear what it's going to sound like, I can click this button. Nice. That's going to work just great. But I also want to add another sound, SND _ music. And this is going to be from my assets folder. And this is going to be the background music that's going to be playing when this game is played. So again, if I want to hear what that's going to sound like, I can click here and listen in. Highly suspenseful. Very scary. Good. All right. We'll hear more of that later. I'll say OK. And just click Save for everything that I've done so far. Now, we also have a background. I would imagine, in fact, I would even ask Jeremy, if you were playing a game where there's spaceship and asteroids, what could you possibly imagine a background being?
Cheese.
He said cheese. But we're actually going to have stars. So I'm going to create a background, BG underscore space, and I will load the background once again from my assets folder. I'll do this little star thing here, and I have my background, and I'll say, okay. Doing pretty good. So let's just pause a moment before we do anything else and think about what we've done so far. We've established what the graphic asset elements are going to be for this particular game. And that's pretty fun. We've also identified not only the background, but some animated stuff. We've even introduced some sound. Now, we don't know how all of these assets play yet together, but that's going to be the next part. How do they all play? And you know, oh no, this is going to be horrible. I just realized I don't have an asset that represents a laser being shot from the ship. I didn't get it, and I'm on live. What to do? Let's go back to GameMaker. I'm going to go back over to sprites. I'm going to right-click, create a sprite. I'm going to call SPR laser. And I will edit this sprite. And in editing it, I can go in here and say I actually really do want to add an empty thing to start with. And let's go ahead and edit that. So I would think that maybe if I just kind of draw a little bit in here, like little laser stuff here. And that's a little yellow that I just added. I'll add just a touch of like some redness here as well. So it's kind of scary looking, maybe a little bit of white. What's the whole point here is that we're creating a little bit of something that I can then transform right away and say, you know, maybe what I'll do is I'll smooth that out, like blur it up a little bit. Maybe a big blur, that's okay. Then I can draw maybe another blue line like right down the center to make it more exciting. So we're not going to be focusing on my artistic skills, but I'm just highlighting that you can create a graphic on the fly if you need to. So I'm going to say save. Now what's cool here is that now that I'm done, I can go in here and modify the mask, set the center, modify the mask, and look at that. It automatically puts a rectangle right there to identify that that's the dimensions of the laser. So if anything hits that area, well, no one wants to get hit by a laser, but that's what it looks like here. I'm going to say OK. So I even have that. I'm going to say OK. So I have all my assets pretty much ready to rock and roll. What's going to be next? What's so exciting now? Well, now we have to create something very similar to what Jeremy did in the construct area, and that's the world that we're going to be living in. So I'm going to go to the rooms area. With rooms, I will create a room, and you can see it right here. I'm going to establish that it will snap to a 64 by 64 dimension. I'm also going to indicate 1366 by 768 is going to be the size of the room. And I also want to go into the backgrounds area. If in the event that I was on a monitor that had a really huge resolution and I wanted to not have this like go full screen, I can choose what the border around the game would be as a background color. So I'll make that black and say OK. And then my background image will be my space scene. How exciting. All right. So just get that rolling there. And yes, I think, yeah, that should probably do it right there. I think that's right. There we go. Okay, so I'm going to click Save. And now what can we do from here? Well, in order for us to put the elements of the game on, such as our player and asteroids and so forth, they can't just be put on as sprites. Sprites are what they look like, but their behaviors are going to happen when we turn them into objects. So for every single one of my sprites that I have, I'm going to turn around, I'm going to create an object. I'm going to do that right now. So I'll go over into this objects area, right-click it, and I'll create an object. Usually the naming convention is obj underscore, so I'll create my player first. Will my player have a sprite? Yes, it'll be the one that we've already created. Excellent. And I'll say OK for that. And now I'm going to create each one of my objects right now doing that same approach. Obj underscore asteroid. My sprite will be the asteroid. And OK. Same thing also for our explosion. Obj underscore explode. And there is the explode. And say OK. And we also have laser. A very unique laser, compliments of yours truly through GameMaker. So L-A-Z-E-R-S-E-R, excuse me. And my custom-made sprite right here. And I'll say OK. Now, once they're objects, we could do something pretty exciting. And that is, we can start to create events regarding these objects. Let me demonstrate. I'll go into this object player. And one of the things I could do right away is go down. I'm going to zoom in so you can see this. There is a button here, very important. It's called Add Event. That button is what we can use to add events related to the player. So I can say, hey, when this player gets created, which will be maybe the dramatic scene, let's go ahead and go into our sounds. We're going to play a sound. How about our music? And yes, we will loop it. Cool. It's so simple. When this thing is created, play some music. Okay, what else do we got? How about this? When we happen to press a button, let's say specifically the left arrow key. So I'm trying not to go too fast, but you understand. I'm going to press the left arrow key. What will I do? How about this character will move in that direction? Oh, it's so easy. And then I'm going to say at a speed of 7. That must be cool. And I'll say OK. And then I'm going to add an event for the key release of the left. Now notice the key press of left was move. What do you think the key release of left would mean? Anyone? It would mean I don't want to move anymore. Stop. OK. I'm going to do the same thing right now for the right key. So for the right key, I will move to the right, speed of 7. And if I also add the event that says, hey, we've let go of the right key, stop. Very cool. What key on the keyboard do you think would emit laser beams? Spacebar. Hey, what a great pun, too. Space. Get it? OK. So we're going to add event.
Spacebar is where you get galactic drinks.
Exactly, right. So when the key is pressed, the space bar, we are going to introduce something very cool, and that is bringing in the laser. How will we do that? Watch how simple it gets. Over here, I say I want to create an instance of a moving object. It says, what object do you want to create? I want to create a laser. And how fast do you want it to go? Oh, I don't know. Let's say 4. And the direction. Think of directions as 0 to 360. What would be up? Anyone? Go back to geometry. 90 is correct. So 90 is what I put here. I will make this relative to the position of the object that the event was based off of and say OK. So now we'll go back over to the room that we created. And you can see this little area down here where I'm moving my mouse. This lets me see the full range of that whole area. So I kind of want to get in the center here because I want to drop our player onto the board where the player is going to start. So I'll go over to the objects and say let me go ahead and get object player, and I will now place that player about right here on the screen, maybe one over. Whoops. Code Foster's tweeting on my screen. I tell you, he's trying to steal the thunder. Okay. And I'll save. And now, I'm going to go ahead and run this code. So by running this code, if we could just understand that it might take a while for the very first time for it to load up and do all the things that it's doing, but it's getting everything compiled, and when it's completely done, it's going to actually show a splash screen, which is going to be what a Windows 8 app would do, and then it's going to get into the game portion of it. So, just waiting for that, this is where violin music would have been appropriate, for some of the building phases of this. Still waiting. It's for the suspense of it all. Uh-oh. During the build phase, I might just have to launch it again. Must have been too excited. Let me say save. Let me just click save on that one more time and try this again. This time I won't close the build window in case there really is a bug that I need to address. I just didn't want you to have to look at all the boring command line stuff in the log prompt that was down below. So again, virtual violin music, etc., etc. And this is doing what it can to get things rolling. And uh-oh. During the build phase. Let me see here. Let me try changing it to a target just for a moment. See if that gives me something better. All right.
That's better.
So you can see I can move my space dude at the bottom of the screen. Now, as I'm moving space dude around, what do you think will happen if I move to the edge of the screen? Oh no! Come back, Jack. Okay, well, so that's a problem for me. So I'm going to stop the game. I did that by clicking Alt F4. And I now have to identify, okay, I have a problem here with that particular logic. So I'm going back over to the object for the player. And here's how simple I can solve this. I love this. This is so cool. I can add an event that says, if you happen to intersect the boundary of the screen, if you're trying to do what you just did, we'll just stop you. So I'll just move this here and say, stop. Okay. It's just that simple. I can no longer move off the edge of the screen. Giddy up. Now, next thing I'm going to do. I wanted to be able to, remember, shoot laser beams. So when I said press space, move the instance of the object laser, we never really saw that happen yet. So let's run it again. Please be kind and just run. Don't do any delays of nonsense. Everyone wants to see a laser. Okay, so moving around. And drum roll. There's my laser! And I can shoot lots of them. Looks more like missiles, but we'll deal with that later. Okay, so.
The tech guy's thinking it looks like a toothpick.
They're toothpicks! Okay, so we have that. Now we need to introduce the enemy of this situation, and the enemy is the asteroid. So I'm going to go over to the room, and as I'm peering in here, I'm just going to scale this out so we can see this area a little bit better. I want to go ahead and introduce Mr. Asteroid to this equation. So I'll do that by going over to the objects area, and change the object that we're focusing on to asteroid. And now I can start to put, let's say, I'll put one here, here, here. I thought here and there. Let me just make sure that I didn't, oops, yeah, I got to delete that dude. Okay, and maybe one over here too. Whoops, right there. Okay, so why am I adding those asteroids at the top up there? Because I want them to fall down. So when I go click on the asteroid and I go to its events, guess what I'm going to do? I'm going to make a move. So I'm going to say add event. When you are created asteroid, this is what will happen to you. You will move. But what direction will I go? You will go either this way, or this way, randomly. And your speed will be 8. The power of 8. Okay. Now, what would I want to have happen if an asteroid moves off the screen? One said bounce it like Pong. The answer is when something goes outside of a room. That's what that says, outside the room. When this asteroid leaves the room, you shall jump to your start position and you will move randomly yet again. This time, 9. Oh yeah. So, let's see what chaos we just created. And action. Of course, I should have said that way after I pressed the green button. Because we're just waiting, chilling. Here we go. Oh, cool. Okay, I gotta be careful. I gotta move. Sorry. Whoa. Okay. So, well, what am I so worried about? What happens if they do hit me? Oh, man. That's because I didn't say it was a bad thing. But what happens if I shoot at them? Ooh.
You sure those are lasers?
I will. Those are some slow lasers. Woo. Okay.
Those look like they're flying at the speed of toothpicks.
Yeah, they're going pretty slow. Okay. So I gotta do something about this. So what I'm going to go do right now is go back to the asteroid object, and I'm going to add a special thing here. Here we go. Add event, collision. If you, asteroid, collide with a laser beam, what will happen? Well, wouldn't we want a nice little explosion? I would think we would like an explosion. This is what we're going to do. So I'm going to pause there. I'm going to go over to this thing called timelines on this side and create a timeline. TL_explode. And the first thing I will add to the timeline is the actual, and what I would say is this is the changing of the asteroid sprite to an explosion. So I can do that by cruising down to the change sprite action and say, you shall change to explode. And say, okay. Then I'm going to add my next step in the equation. And this is going to be at, let's say, the 30 increment. And I will add to this one a destroy yourself. I know that sounds horrible. But you know what? Once it's gone, it's gone. So I just have to say, okay. But then, my very next step that I want to add at step 31 would be now that that asteroid has been destroyed, we need to bring them back at the top of the screen. So I'll go ahead and say, let's create a moving object. And the moving object will be, actually, I just even thought of an easier way to do that on the cuff, which is so exciting. Let me go ahead and delete that step altogether. I could have actually, instead of destroying the no, I needed to do that. My bad. Let me just add this again. This is me trying to be all efficient on the fly, but I will create my asteroid object. So the asteroid will be created, and I will just start it somewhere around the 600 pixel mark, and the speed will be 10, and I'll just say OK, and then also allow for a random movement down, boom, 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 also 10, and say OK. All right, so I've created what's called a timeline, and I'm saying OK. And now for me to execute upon that timeline, I'll go back over to our asteroid, and I'll say, when you hit a laser beam, you are going to be involved with a timeline. So I'm going to set the timeline. The timeline is going to be explosion. I will want it to start immediately, and I don't want it to loop. So explode, be done with you, and gone. Say OK. Oh, one other thing. I should have remembered this, of course, in our timeline. My goodness. Let me add another step. I can make this at 1 because I'll want this to happen right after we change the sprite. We need an explosion. So how about this sound? Play the blast sound. No looping. Say OK. That sounds good. Save everything. And let's see how we've done so far with our game logic. What I love about GameMaker, and I don't know if you've seen this yet, is that GameMaker allows it so that you're really just thinking through the logic and just executing on it. Oh, yeah. Now, I don't hear... Oh, no, I didn't hear an explosion yet, so I'll have to check that out. Maybe I should have done that at the time it was... Oh, they're not being recreated. I obliterated everything. I win! Okay. So I actually probably needed to have the sound. Let me just click on that here. Say OK. Probably going to delete this step and move that over into the asteroid explosion step. So when a laser hits the asteroid, I will go ahead and add that sound over here now. There it is. And blast sound loop pulse. Great. OK. So what we have so far, and I knew, and I know that I'm getting a little short on time, but I wanted to do the following. I wanted to make sure that I demonstrated probably most of the key aspects of what you could do in GameMaker in terms of just getting started. And that was, think of it this way. You created or acquired your graphics, your assets. You found out what music sounds you wanted to get. You just basically register them in GameMaker, create your room, and then you just start to add all these rules. If this, if that. But do you notice I haven't done one line of code? Not one. This whole game so far has been purely drag and drop. And that is a testimony to this product. Now, if I choose to do so and I'm feeling power, I could code if I want to. And there is easy way. There is actually an action item I can drag onto the screen, and it's called code. That means do whatever I want, which is where a lot of the true hardcore GameMaker devs spend their time. But maybe just for fun, what we could do is check once again into our game that we've created in just minutes, right? And really, just minutes, we've created this game. And now as it's pulling back up again, let's see if we can get sound. Oh, man. So I wanted to have this victorious explosion sound. Oh, well. I must have destroyed an instance before it was supposed to be destroyed or something to that effect. But I won't troubleshoot this in front of you, but I think you get the whole gist of it. So here's where I want to go next. I'm going to actually shut down. I'm going to save my work and shut down GameMaker. And I'm going to open it up again because I want you to see a different aspect of it. So I'll go back into GameMaker, which it's going to load. And the reason why I shut it down and open it back up is because what I want to do is I want to be able to demonstrate something that's in the very opening tabs at the top over here. So I'll start with tutorials. Let's say that you are very interested in GameMaker. You've liked what you've seen so far. You're like, maybe this does rival what Jeremy did in Construct. Maybe you feel that way. So, and you're like, how would I yet learn more about this product? Well, every one of these tutorials, which I just clicked on the first one just now so you can get an idea of what it does, I think this is so awesome what GameMaker did. You'll notice we're in the same world we were just in. Here's my sprites, sounds, and backgrounds, but now we have a tutorial pane over here. And it just says, this is what you do. All right, go next. I can do that. Then you scroll down, you understand, it's telling you what the game plan is, the planning phase, the levels. Okay, I understand it. Now you're going to add your sprites, and it starts to go through and give you all of the step-by-step tutorials on how you can add a sprite, how you can add an event, all that kind of stuff. So at the very end, you're creating a clown that looks like a light bulb. It kind of does, really. It kind of looks like a bulb. So I'm gonna go ahead and close this down and exit. And I want to go back into GameMaker again. This would probably be my only feedback for the GameMaker folks, is that every time you want to switch something out, you have to actually reopen the product. So I'm coming back into the product again, and now I will just pan through and just show you that the tutorials, without me clicking on one, some of them are like 1942, Breakout. You could start to create a kind of a 3D looking like a game like you'd see some of the social games out there. Not the type that you'll see next. If you're into classic asteroids and want to learn some physics, if you want to get into particle streams, game center integration, surfacing, and some of those cool things. And then it even introduces resolution and scaling for devices.
Now, actually, there's a question in the chat room right now about whether GameMaker will create a app for the Windows Phone. Can you speak to that?
They asked for the phone, you say, and the answer is yes. But that one you have to pay for. Windows 8, the operating system, is a free export. Meaning, when I say free export, I mean everything I just did right now, I could compile it and I could turn around and provide it on Android, iPhone, Windows Phone, all that. If I pay that one-time fee for the export privilege to that operating system. It just happens to be that Windows 8 is free right now. So take advantage of it. You know, export all day long. You can, HTML5 is free, and so is Windows executables. Excellent question, though. And yes, Windows Phone is savvy. You will enjoy doing games for Windows Phone for sure. But wait, there's more. It's not just tutorials. You may say you had me at hello or at space or at asteroid, but guess what? There's demos. Exactly what the tech guys are saying. Ooh, by the way, that's important for you folks to understand. We have angry cats.
Yeah!
Angry cats in space.
Even better.
We have card games, and all the tutorials, the completed versions are here. So if you wanted to play it first just to see if you want to do the tutorial, oh, what a commercial for GameMaker. Then, all right, here's another drum roll. Windows 8 Functions demo. What does this mean? This means that in addition to the fact that you can run all these games, they have provided a fully functional demo. And by this, what I mean by that is that the full source code is openly exposed. It's as if you're opening up this project. And if you want to capitalize on the things that makes Windows 8 awesome, like live tiles, notifications, the ability to share, the ability to properly scale yourself at different resolutions, every one of those things that I just mentioned, it's in there. It's like spaghetti. It's right there in the Windows 8 Functions demo. And you know what's even crazier is that most of the stuff that's in that demo, they're one-liners of code. It's not like you're like, oh, what's the exhaustive process? It's like one line of code to execute and say, change this live tile for me, and do this, and do that. And it's just one line. It's great. I wish it was that easy sometimes in our projects in Visual Studio when we're doing it through code and natural APIs. They've made it so easy that you can easily get into this and start to integrate all these Windows 8 functions and features. So, thought you should have seen that. And I think just for fun, just so that we can do a little comparison, because, you know, I noticed that, Jeremy, when you did your Construct 2, you said, I think he said something like, "This is a game that is similar to Angry Birds." Now, I don't know his voice, but it was something to that effect. And now I'd like to show you what our version looks like. So I'm opening up Angry Cats. And here it is. I'm just going to run it. And let's find out what kind of game you could make if you had the time and you had less than 40 minutes to do it. Or more than 40 minutes to do it, I should say. And it's just loading up. Of course, I could examine every line of code and every single step that they did to make this game, which is awesome that they provided that. And here we go. Angry Cats. All right. Sweet! Woo! All right. Okay.
Do cats pop?
Oh man, that cat flew. I shouldn't have gone that far.
Oh, that hurts.
Okay, it does hurt. All right, so I'll go ahead and close that. I just wanted you to see an example of what another game could be that you get right away just by going ahead and doing the demo. It's crazy.
It is crazy.
All right, so let me go ahead and calm down. Because I'm telling you, GameMaker is cool stuff. You're going to get excited if you start to use it as well. So easy to create games. Shut this down. And the bottom line is this. Each one of the game engines has unique factors. And what I've found is that in the community, it's not which one's better, Construct2 or GameMaker. It really isn't. It usually falls along the category of which one is more intuitive for you. So you may have watched Jeremy's and you may have seen Construct2 and say, I think that's for me. Or you may have seen this one and say, oh, I think that one's for me too. You might have some of their other quirks and so forth, but I think at the end of the day, wouldn't you agree, Jeremy, that for the most part, the gaming engines usually produce about the same level of game. It just kind of comes down to what's your preference for how you like to approach.
I totally agree.
Game.
I've seen excellent looking games that were created with Construct2 and that were created with GameMaker. I don't know what the name of it is, but on GameMaker there's a game that was created where you're parachuting down a tower. That one was extremely impressive.
Parachuting a tower in GameMaker?
It's like you've jumped off of a tower and you're controling character as he parachutes down.
Oh, I think it's in there, but I haven't personally played it myself.
That's a good one.
There's a couple other good ones in terms of ones that have, of course, made it into the store. There was just an article recently of a gentleman who used GameMaker to really do well financially because of the game that he released out into the market. So, I mean, that's the other thing too. And of course, we're going to talk more about this when we get into the afternoon session. But I think that's something that is really important for everyone to understand is that, for me, creating a game is almost something along the lines of, it's something along the lines of, I just lost my train of thought. Fulfilling a childhood dream. But it really does come down to money, too. Because, if you're going to spend your time doing something like this, you might actually want to earn. So these tools are designed for the very reason that, as Jeremy mentioned earlier, you might not have a full team of folks that you could do a whole bunch of crazy, almost like multi-million-dollar project type games, but they do get you ramped up pretty quick so you could do something. And you'll find out that some of the simpler games out there, it's some of the simple ones. It's not usually always the ones that have the multi-million-dollar budgets. It's sometimes the simple ones that end up earning a lot of money because it's so easy to interact with and play. We can't stress enough, like Jeremy mentioned before, if you think you have a game idea like that, where the concept is cool, it's simple, I'm jealous, because those are the ones that usually do really well. And the simpler it is for people to get engaged and enjoy, the more likely they're going to want to have that game. So these tools can do that for you.
Yep.
All right. Well, we hope that you have enjoyed those demos. Well, that's going to wrap up this module on GameMaker. I hope you enjoyed it as much as I did. It really allows for easy game creation, and you can easily go from here, get into those tutorials and demos. You got the sense of what you got to do. You got to add the sprites. You got to create the objects. You got to create the room. Go have fun. And if you want some more help, shameless plug for my content that I have on my site on GameMaker. Just go to aka.ms/4GameMaker.
Awesome. think people are going to have fun with that.
I hope so. Cheers. We'll see you in the next module, where Jeremy steals or Adam steals our thunder with Unity.
Welcome to our next session, Module 5, on what's my favorite gaming platform, Unity. Although I gotta hand it to you, that energy might be kind of tough to follow. That was pretty impressive.
Well, thanks. It feels wrong that Jeremy's not on the scene, too.
He can shout from the side.
Yeah, he can just shout.
He's there. He's over there.
Okay. All right.
So Unity is an awesome framework, and there's a free version and a pro version. So before we kind of get into that, let's talk briefly. You can do a lot of stuff with the free version. You can target, I think, all the major mobile platforms, so it is multi-platform capable.
Cool.
The pro version gives you a bunch of different lighting effects, shaders, pro water effects, so some really cool things. They have a nice chart on their website where you can compare free versus pro version. It is an amazing 3D development engine. There's some impressive 3D games. You can also use it for 2D games as well. Some beautiful 2D games. You can compile your code in C#, or I think all of us in this room right here are pretty much web guys, so we come from the JavaScript. You can use JavaScript, which is actually fully compiled, and we'll look at some demos of that as well. And the cool thing now, recently they announced support for Windows 8 and Windows Phone 8. So you can export for any of those platforms, all the major platforms, and target a wide audience. On Windows 8, you can export to Direct3D and C++, Direct3D and C#. You can go to XAML and C++, XAML and C#. So some really cool export options. So let's get into some features of Unity. It's multi-platform, has a built-in animation system, as we'll see some cool demos. It has built-in AI. You can write your own AI, or you can use some built-in AI as well. You can develop materials and custom terrains, and we'll look at that. And you have the ability to control special effects, particle effects, lighting effects. You can control nearly anything in the game to create any sort of world that you want to. Advanced environmental effects, fog, real-time lighting and shadows. And I demoed earlier the asset store, where you can get an amazing amount of free and paid models and audio files and script files. And we'll look at why you would want some script files very shortly. So let's get right to it. Few slides, lots of demos. Shall we?
Yeah, I've got the best seat in the house. I'm very excited. Let's go.
Alrighty, over here to Unity. Let me exit out of.
Did you escape out of your deck?
Just did.
Duplicate screens.
Let's duplicate.
Oh, that looks good.
Alright, so this is the Unity interface. Let's come in here and do a new project, and we'll walk through what the various aspects of the interface are. When I first opened this up, let's call this Jumpstart Awesome. When I first opened this interface, it was a little daunting. I didn't have any idea of what these different panels were for, what these panes were for, and I thought it might be actually more complex than it is. Now that I know it, it is very well laid out, and it's very easy to follow, as you will see shortly. So the first thing you'll see on this new project dialog here is packages to import. These packages contain various things you'll want to include in your project. So if you want a first-person shooter or third-person, you can import this character controller class, which we're going to use. Now, you don't want to import everything because these take up space, which means your project is going to be bigger and your exported size of your game is going to be larger. So you want to pick and choose. Now, you don't have to pick them all here. You can actually pick a couple and import them inside of the game. So here, I think I will use my character controller. And when we use these, I'll explain each one. Skyboxes, because I want some sort of sky around my environment. I want some terrain assets, because I want to be able to have a world that I create. I want trees and grass, so I'm going to import my terrain assets.
Cool.
And I personally love Visual Studio. It's what got me on the Microsoft platform. It's probably responsible for me sitting here today. And so I like using Visual Studio to debug and develop my Unity games. So there's a package, Unity VS, which I choose to use. You can actually configure Unity to develop, to use Visual Studio as your IDE just for your editor purposes. But if you actually want to develop, you need a third-party product if you want to debug, you need a third-party product, Unity VS, to do that. And I want to include some water effects. Actually, I'll do that one later so we can see how that process works. All right, let's create this project. And it will restart. Every time you open a new Unity project, the environment will shut down and restart again, just to make sure you're starting from scratch.
Does it shut down and restart if you just simply add another package like you just did?
It's only for a new project.
Just for new projects. Okay, that's good to know.
And a Unity project, while that's loading up,
yeah,
let's look at a particular project here. So this folder, you think of Visual Studio, you get a solution file, a project file.
Sure.
In Unity, everything's kind of laid out in these folders. You actually open really a folder for your project. And it has things in special folders that you don't want to mess with.
Okay.
You don't want to come in here and start reorganizing things because it's tracking where everything is. You want to do everything through the interface. There are a couple minor exceptions. For example, in Blender, which I had opened before, you can actually save a Blender file right into your assets folder, and Unity will automatically detect that and import it into your project. And then anytime you make Blender changes, it will re-import that object again. That's one of the exceptions, though. In general, you don't want to mess around with that folder. You want to do everything through the interface.
Sure.
So we've got this basic interface here and an initial scene. Think of a scene as each level or each world that you're going to deal with.
Cool.
So what I want to do in this scene is I want to go ahead and create a terrain. Let me make sure I brought in my terrain assets right there. So the layout here, this is everything in my project right now. All my assets, so my 3D models, my textures, everything is under here. Think of this, if you're a developer, as like a solution explorer. This shows you your files in your project. Up here are properties of the current scene. Now, we don't have anything but a camera. That doesn't do us much good right now. So what we're going to do is customize this, add things to it, create this world all from scratch.
Let me ask you this while you're doing that. If you add these terrains or these other assets down below, are there certain assets that would only work for certain platforms, or could all of this work for Windows 8 or this environment or that? Or is there any restrictions?
There are some minor restrictions. For example, if you're just as one example, if you're developing code for Windows Store, WinRT libraries have different restrictions on them. As such, you might not be able to use a hash table. So if you're using a hash table in your C# code, then you're going to have to find another alternative, another type of list to use in your code. So minor restrictions, but in general, it runs cross-platform pretty well.
Okay. Good.
All right, so let's go ahead and create a terrain. So everything in Unity starts with a game object. It's your container for everything else. If you have something here, chances are it's a game object. So let's go ahead and create a piece of terrain. Now, the navigation in Unity, as I talked earlier, I've got a 3-button mouse, so I can actually use my mouse wheel and scroll this. I can hold down the scroll wheel, which is essentially the third mouse button, middle mouse button, and move this around. And this is in 3D space, so I have X, Y, and Z. And you can actually, this is called a gizmo, you can click on this and go through different views. You can go top view, front, left, bottom, back, and we'll look at some of those in a little bit here.
It's truly called the gizmo.
It's a gizmo.
That's cool.
That's cool. Gizmo. Who was Gizmo? Was that from Gremlins? Gizmo. That's
Exactly.
right, the movie.
Okay.
I'm dating myself here. So I'm going to delete, actually, let's keep that for now. This terrain, what I want to do is add some sort of color to that terrain. So notice we get some built-in terrain tools here. So this window right here are all the properties of our currently selected object, all of its behaviors, how it's going to act. So what we want to do is create a texture. This is pretty boring right now. This is a basic plane. You're going to see how we're going to turn this into an amazing looking world.
Really?
Yes, believe it or not, in a few simple steps. You too can do this. So let's go ahead and choose a texture. I'm just going to say edit texture, add texture.
All right.
Because I've already imported my terrain assets when I started this project, I can just choose one of these right there.
That's pretty cool.
Just like that. Now, okay, granted, it's not the best looking thing. So to preview, this is my designer, right?
Okay.
I can see some 3D stuff in here, but when I actually want to go and look at what it's going to look like in my game view, you go to this tab. That is based on my current camera. That's what my main camera is looking at, and it looks pretty boring right now. Let me move this down just so you guys can see everything here.
Yay, you're a winner.
All right, so this is pretty boring. If I click on play, it actually starts running my game from wherever I'm at. You can be in the middle, you can move your cameras around and start this game from wherever.
Okay.
So right now it doesn't look like much, right?
It doesn't.
It's pretty boring, I'll be honest. Let's get a little bit more exciting. I'm going to add light. So I'm going to do a directional light, which you can think of as being like a sun.
Oh.
Not a sun like my son Asa. Sun as in the sky.
Sure.
Gives life.
Yes. Okay.
Now, notice that we've lit this up quite a bit. You can control your intensity here.
Oh, wow. That's cool.
So nothing amazing, but it's nice to have that feature. You might want to lighten up your scene a little bit.
Exactly.
Now if we go to our game view, again, nothing special. We can't do anything. We can't interact like this. We need to add something to be able to do that. So what I want to do next is add a first-person controller. You can do a third person or a first person, but I want this game to be what I'm looking at, right? So under standard assets, you have character controllers because I imported that. That was one of the packages I checked off when I started this character controller. If I didn't have that, I could just click on character controller right here,
Exactly.
and away I go. But since I've already got it, I'm just going to take a first person,
Uh-huh.
and I'm going to drop that on the edge here.
Okay.
So the one thing that I see right off the start is it's split right between my plane there.
Oh.
I
ouch.
don't like that. Yeah, that can hurt, and I could actually fall through into nothingness.
Yeah, that's bad.
So what I want to do is I want to be able to select this and do some operation and move it above the ground.
I see.
It's kind of like I teleported and landed in the wrong spot.
Yeah, very bad.
So in comes these little guys up here.
All right.
Here I can move, which I can also do with my middle mouse button. Or I can move an object. And now notice I have really 4 options here. I can go, see the red here, I can go in my X dimension, I can go in X direction, I can go in Z, or I can go Y. So I just want to scoot this up.
Whoa. And did you have to click on that green thing?
You have to click on the arrow that you want. If you do the center here,
Yeah.
that is, it's kind of dynamic. It goes in all directions. But if you want to constrain to one direction, you just simply do that.
Kind of like the Wonkavator. Very cool.
The references are going like wildfires today. So if I go ahead and run this, now I can interact with this terrain.
Whoa! This is getting exciting.
Very exciting. Still kind of boring, I'll be honest.
I don't know.
A lot more exciting suddenly, okay?
Yes.
What becomes real exciting is when you fall off the world, but I'll show you that when I have more things on my world.
Okay.
Now, let's make mountains, shall we?
I like.
Let's do mountains. So I'm going to click on my terrain. One of the things you want to make sure that you are in scene and not game view. And another very important thing while you're developing is right here, when you click on this and you are in game mode, any changes you make, you can actually make changes down here to your game. As soon as you click stop, those changes are discarded. So you want to make sure you're not in this mode and you come over here and you make a lot of changes.
Ooh.
Always want to make sure you undo that. There is an option. Let me actually see if I can find it real quick.
How do you know if you're in that mode?
So you kind of learn to just look at it, but there's also another setting. Let me see if I can find it. It's been a while since I actually said it. There is colors, play mode tint.
Oh.
So let's go ahead and change that to red.
Yes, that's scary.
Now when I play, notice my interface. It's very hard to get caught in that trap then, right?
Now
I
right.
know.
Somehow I know.
Somehow I know.
Yes.
So let's go ahead. Now we're going to click on our terrain, and let's go ahead and add. Notice when I mouse over this, raise or lower terrain. I'm going to come into my top view here. Actually, I don't have to. I can just, I'll show you what that's like. If I right-click and go top, there's my top view. If I want to go back to where I was, my first-person controller, you simply double-click on that. And now you're back at it. And I can just rotate this around. Zoom back a little bit, scroll back on my mouse wheel. Now let's go ahead, click on my terrain, and I like the star shape. I think star makes pretty cool mountains. And I'm going to increase my brush size here. It's a little bit too big. But now we can see, check this out. Ready?
Oh, man, it's there. The power you have right now is amazing. That's amazing.
I'm making this world like it's
You're like a deity.
Saturday and I'm going to rest tomorrow. This is good.
Very
Pretty cool,
man.
okay?
I'm impressed.
Let's undo some of this. I want to make my mountains a little bit off in the distance here.
That's too bad.
Oh, no. There will be more. There will be
good,
more.
Good.
But now also, so this was the start with a larger brush size. If I want to just go small, I can just do this, crank my brush down, and just do localized kind of mountains here.
Okay.
Little hills. And there are terrain toolkits that you can get. These are built-in tools. There are some really advanced toolkits that you can buy through the asset store to do development and really kind of scale these assets out with amazing worlds.
That's great.
But this is going to be cool what we're building here. Have no doubt. Now let's check this out. I like our red view here. Okay.
That is very cool.
Pretty cool.
Yes.
So what else makes a good terrain? What else is good for life? How about we do trees? So I'm going to say, I go click on my terrain again, and I have a little tree button here, place trees. I click on that, edit trees. Well, I need to define a tree. By chance, there's already one included in my assets package. If I just search for tree, oh, you know what I didn't do?
What?
Import package, tree creator.
Tree creator.
Yes, standard assets / tree creator. Notice it's not down here. I didn't import it yet. That gives me some more options. So that's how you can import a package.
So this is important. You don't have to start over.
Don't have to start over. You do have to wait just a second while it decompresses them, copies them, sometimes compile scripts. And then as soon as this is done, we're going to go play some trees here. Edit trees, add a tree. Oh, let's do big tree. Big trees are always good.
Big tree.
Now, I can go crazy here. I can actually say mass place trees and do, what is that, 100,000 trees if I wanted.
What?
Look at that. I just made my own forest.
Wow. What happened to your mountains?
Oopsie. Alright. So I'm going to undo that because that's an excessive amount of trees.
Yes.
Let's try 1,000 and see what that looks like.
Okay.
You know what? I still don't like that. Let's do a little bit more. Let's do 10,000. Okay, that's better. Now I can actually come down here and change my brush size. Say, you know what? I like one there, there, there. This is a pretty tree line. Pretend that's my driveway. There we go. All good, okay?
Yes.
Now let's run this and the evil red on the outside. Pretty cool, okay? Our world is advancing. Watch this as I fall off the world. Goodbye, cruel trees.
Wow, I never knew it was translucent on the
So
other side.
while I'm falling, note this. Remember, I'm still running the game. If I click on first-person controller, notice my y-axis is still dropping and falling right here, and falling and falling. So this is live. You can see these properties live of what's going on in your game. So let me stop that. What else do we need? We need water. Water would be cool, right?
Sure.
All right, let's bring in some water. Import package, water. I'm going to use the Pro version. Import this. Are you ready to be wowed?
I am.
Are you sure?
I'm like stoked here. You're stealing some major thunder right now.
I don't know. Your
In
energy.
fact, you're probably going to create thunder for all.
No thunder in this demo. I disclaimer ahead of time. There will be no lightning and thunder today.
Oh, okay. The disclaimer.
Maybe next time though. Advanced effects. That would be kind of cool, actually. Thank you.
Oh, good. I'm glad I can help. With
All
your
right.
thunder.
So our water's been imported. Now's a good time to talk about prefabs. Prefabs are prefabricated objects.
Okay.
So if you've got stuff you want to bring in your project, you can create a prefab. You can use other people's prefabs. Think of them as a building block made of other components. So if you had a skeleton, that might be made of many different parts. You could create a skeleton prefab with many different parts beneath it. So some of the things I'm going to be doing today are taking others' prefabs and moving them in my project. How do you tell up here if something's a prefab? And if you look, this is blue. Blue means that's a prefab. Generally, it's made of other components. All right, let's use that water.
Okay. Oh, wow.
I want to scale this out much bigger too. So I'm going to change the scale here to 100 by 100 by 100. Make this quite a bit bigger. Now I notice right now this is completely on top of my earth. In fact, if I run this, there's no water around me. So I need to lower this down.
Oh.
So it's good to just rotate, and you can actually see right here, it's above where I'm at.
It's like you created an atmosphere of water.
I know. So as I said, I can just click on this and move it down, and now watch as it approaches the mountain down here.
Oh, wow.
You can kind of see it go through, and it gives you a good idea where the levels might be correct at.
That's pretty slick.
So I want to do that, and now I want to actually move it over a little bit. So let's go here. Let's give the world a little bit more water like that.
Yeah.
And let's see what that looks like.
Oh my goodness, look at that.
Let's run that. Not bad. I get reflections there.
That's insanely awesome.
Cool.
Yes.
Now I can still fall from the world,
Okay. Oh, it's still translucent.
but I have really cool water.
You do.
Let's save this project, and I want to save this current scene I'm on. It's a separate operation. Saving your project and saving your scene are two different things. I'm going to save this scene. I'm just going to call it main. This is my main scene of my project. All right, so we've got water. What are we missing here? It kind of looks like we're in a movie studio, right? We've got this blue screen in the back, right here.
Yeah.
All right, let's change that, shall we?
So while you're doing that, I'm just curious, like all these cool assets that you're adding right now, I know that's part of the product, but can you create them inside of Unity, or are there like other products?
That's a great
to create
question.
those?
So Unity is not an asset creation tool. Generally, you want to create your asset somewhere else, import in Unity. Now, you can do some cool things with them in Unity, but the creation aspect of it, you want to do generally outside.
That
Now,
seems like it can be a business on its own.
Yeah, and if you want, if you want to create prefabs, you can do that inside of Unity. So maybe you have, like we were talking before, a bunch of bones. You could actually assemble them, lay them out in Unity in a prefab, and export that and sell it as a Unity package to other folks.
Cool.
In fact, now I'll tell you what. If you want to get crazy,
I do.
Crazy. You know how crazy we're going to get?
Do tell.
Can you identify without looking at the top of the screen here
It's a bulb.
what that is?
It's a bulb.
It's a bulb. I'll give you a hint. You're not even close.
Really.
That would be a burger.
I'm hungry now.
So I'll do something inspired by my son here, because in Unity you can really do anything.
Okay.
So I've got...
Are you going to introduce hamburgers into this world?
Let's do it. Let's bring
It's
in
a perfect world.
Let's bring in a hamburger.
This is great.
And I'm going to bring in hamburger.unity package, which is a prefab for a burger.
Wow.
Now, we're not going to do anything with this burger quite yet, but I just want to bring it in. Now, that didn't actually put it in my scene. I actually have to bring it up here, drop it in.
I see.
Oh, sweet, wrong view here. Burger. There's my burger.
I see.
Look at that tasty burger. Doesn't it look delicious?
Wow.
Cool. I'm just going to move that off to the side for now. Because the one thing that I wanted to touch upon, whoopsie, let me pop this window back in here. One thing I wanted to touch upon was we are seriously missing something in this game. This looks like a movie right now. It's got a blue screen in the back. Let's change that. So edit, render settings. And in my render settings, I'm sorry, render settings, not project settings, render settings, over here, skybox material.
Skybox material. That sounds like it might have something to do with the sky.
You are correct.
I'm.
If I had a prize to give you,
But it's
today would
that
be the day.
intuitive. That's what I love about it.
So you can choose different ones. Now watch as I click on them, you get dynamic kind of updating here. Yep. So I'm going to use this one. This one looks pretty good. I like sunny skies.
Nice.
Now let's run this. Now we have a world
Oh my
with reflection on the water.
Beautiful.
Very beautiful. Now you can actually control these waves. You can make them change color, make them more look ocean, have waves coming in up and down. You can do, I mean, there's ways to do flowing water, all sorts of cool stuff.
That makes my explosions not look so good. That's great.
That is very cool. Now, what else do we do? How about...
So is all the graphics engine behind all this? Is it OpenGL, DirectX, both?
Well,
Neither?
so it depends on the platform that you export to, because it's going to depend on your destination devices, what they run on. So in this case, well, we'll get to that.
Okay.
That's a very good question.
Okay.
If I forget it, then shoot a rubber band at me and be like, I reminded you. All right. Let's go ahead and add, I know. Let me show you the asset store from here. Earlier, I displayed it from the browser. Let's do the asset store from inside of here. Because you can bring assets right into your game right from the asset store here.
And by asset store, you mean like go pay money for asset store?
Some pay money, some free. And am I connected here? I should be connected. There we go. So while that loads up, let's go back here. I love that burger. So we have some actually questions here. So can you import height maps? Bump maps, if I'm assuming what you're talking about. For texture, yes. And does Unity create, well, OpenGL, DirectX, or both? In this case, I'll just show you the screen. Let me go back over here. We'll touch upon the screen again, just to make sure we don't forget it. When we build, let's go down to Windows Store. And this kind of depends on what the destination technology is going to be. You can export for your Windows Store apps to Direct3D C++, Direct3D C#, which I heard has a minor performance benefit over this, but you might want to go in if you're a XAML developer and include some overlays, things like that, and there's some XAML code that you have. And you can do XAML C++, XAML C#. Also to note, the interface for Unity you can run on multiple platforms as well. Not just develop once, run anywhere. You can develop on multiple platforms as well. But I like Visual Studio, and Visual Studio is here. That's what keeps me here. So I've purchased some assets in the past. Earlier, I made a search for a dinosaur. If we just want to say birds, search for some bird assets. We got a whole bird pack, everything here. But I want to look at the assets I've already procured, so I can click on this link here.
Oh.
And I'm going to bring in a bird flock. Now, I've already purchased this. I think it was like a whopping $5.
Okay.
And
For a flock of birds.
For a flock of birds.
Because you need a flock of birds in your game.
In any world with trees and all that, I think you definitely need a flock of birds.
This is crazy.
So that is in my project. I'm going to also bring in one called 10 Simple Meats.
What?
You'll see why. I know it makes no sense at this point in time. I'll import that.
Okay.
And I've also purchased, I have a dungeon props pack, which I'm not going to put in this world. That one doesn't quite make sense there, although the hamburger could be said doesn't make any sense either there. So I'm going to import some dinosaurs.
This is a fascinating world.
My son, I'm inspired by my son. I have a son, Asa. He's going to be 3 soon, and he loves cheeseburgers and dinosaurs. So I figured they were appropriate to have in this world, right?
What?
So I purchased this whole dinosaur pack, and I just wanted, he loves Spinosaurus. So I'm going to come down here and find my textures for Spinosaurus. And I'm going to actually find my models for Spinosaurus. And import these guys. Now, I could have just done the whole package, but we've been sitting here for a couple minutes while everything gets imported. So this will be a lot faster. All right, there we go on that. Now I've got my 10 Simple Meats. I've got my bird flock. So let's do that. I open bird flock. Let me go into my prefabs and pop one in here. And we'll set it up a little bit and move that back.
And you're putting what there again?
This is a flock of birds.
That's a flock of birds.
Flock of birds. It doesn't look like a flock of birds.
Yeah.
But just you wait.
I'll wait.
Are you waiting for it?
I am.
Are you ready?
I am.
Okay, let's do this.
There's life.
Look at that.
Oh.
A pretty good looking flock of birds, right? It makes sense in the world that I'm in. I have birds.
Wow.
Now you can see on the side, all those objects were created dynamically. There's scripts controlling them. I don't have to worry about that code. Somebody else wrote that code, but I can see the objects there on the side running.
Wow.
Pretty cool.
That is cool.
All right, now let's bring in that dinosaur that I added.
Yeah.
Dino time. Spinosaurus. Drag him up in my scene view.
For what it's worth, I think you're the only person who ever created a game with dinosaurs and hamburgers. I'm just saying.
It's all meat, right? It's all meat. So my dino, let me run this.
Okay. What? It was that simple?
That's simple. Look at that dino. Now, this dino happens to be walking. His default animation, which will change in a second, is walking.
Yeah.
But now, notice the light coming on that side.
Yeah.
If we can actually get around to this side, we'll probably fall off to Earth. You'll notice this other side is a little darker. It's dynamic lighting in Unity.
Oh, wow.
A little dark on that side. Bye-bye.
Oh, man.
So let's stop that. We've got our dino. So
Okay.
click on my dino. And remember, this is all the properties for the dino here. So I want to change his default animation, which is walk. There's one defined for him, idle.
Idle.
Idle sounds a lot better. He's just sitting around. He's a lazy dino.
Makes me more comfortable.
Yes. You don't want this guy chasing you, which we might have him do.
Okay. He's enjoying the water.
There. Now, he's just hanging out there.
Yeah.
He's idle, breathing. Copious amounts of oxygen in the ancient worlds.
Okay.
All right. So we've got a dino.
All right.
Let's see what else can we do. I know.
Yeah?
We want to feed the dino.
I guess I know what that's going to be.
Dinos love what?
Burgers.
Dinos love other dinos and other dinos. If you watch the Flintstones, you can surely have
that's
dino
true.
burgers.
That's true.
I think it's very feasible. So what I want to do is 2 things. I
Okay.
need to define what my first person view is going to look like, because right now I have that one floating in mid-space. I have no actual weapon. So my weapon, so to say, I want to be able to see a cheeseburger in front of me, and I want to throw hamburger patties over to Dino.
Cool.
Sounds good, right?
Yes.
Perfect. All right.
A kid's game.
Kids game. Feed the Dino.
Until they get attacked.
So what we can do here, let's go ahead and change the position
Okay.
of this burger to be inside of our view. Now, we can see the current camera preview. This burger moves around on its own. I want to actually make it a child object of my first-person controller, so it moves around with me.
Okay.
So I'm going to take that burger and bring it down in front of my camera.
Okay.
And now,
Oh.
notice on the bun the lighting effects, right? It's
Yeah.
dynamic lighting effects.
Yeah.
So,
did you
but
do that?
that's in a spot that I don't really quite want it.
Okay.
I want to scoot it over just a little bit more.
All right.
Maybe over this way just a little.
So the relationship of that object underneath the main camera is what makes it now follow you.
It's a child object, basically. Yep.
Cool.
So now I've just actually brought it a little too far. So you might have to just play around with the position of it a little bit. Let's move over this way some and zoom in.
Okay.
Try to make this a little easier.
All right.
Go back to this burger and we'll scoot it over a little bit.
Okay.
And let's see how that looks. Still, it's kind of obstructing my view a bit. Go over here, over here. Looks good.
Okay.
Good enough. Now, since I want to throw
Yes.
an actual patty itself, I don't think dinosaurs, so I read, like buns, they just like the meat itself.
Okay.
That's a well-known fact.
I thought so.
Thought so? Okay. So here's just a patty I'm going to throw out here.
Okay.
This is what we're going to throw, okay?
Okay.
Now, this actual patty itself, let's create that as a bullet.
A bullet.
A bullet. And I use the term bullet because this is translatable to almost any game that you want to do. So your burger could become a big shotgun, and the bullet of a burger could become your projectile, right?
Right.
So in this case, it's the same concept, same exact thing. I can just change my models. I could actually turn this very easily into a gun. I could purchase one from the store, design one myself, and away I go. But I like the burgers and dinos. Sure.
Flying patties work. I
Yes.
understand.
Now, so I'm a software developer, but I know maybe some of the folks attending today are not software developers. So what I've done is tried to get some scripts, mostly off the net, for free, that were developed by other folks that I can use and drop them in my game.
Right.
So I'm going to pull in some scripts here. I'm going to create a folder called, you'll never guess, create folder scripts. Now, how you lay your projects out is up to you. Some might want to prefer to put this underneath another folder, under standard assets. It's all up to you. That's the power. You can kind of define your own project structure.
Okay.
And in scripts, I am going to bring in a couple demo scripts I have here. And we'll talk about each one, and I'll show it briefly as I go through this. Another component, let's see, did I bring in Unity VS? Perfect. So let's go ahead and save this and open one of these scripts.
Whoa.
If you don't have Visual Studio configured, or you're not using a third-party plugin like Unity VS, then by default, you get the mono develop interface. And that's the same that happens on other platforms as well. I like Visual Studio, so you can configure it as your editor, and that doesn't cost anything to do that. But now if you actually want debugging in it, Unity VS, you need a third-party plugin to do debugging
So
for that.
editing, yes. Debugging, no. But debugging, yes, if you get the...
You
yes.
got it, buddy.
Okay.
You got it. So this script here is JavaScript. And if you come from the web world, then you might love JavaScript. JavaScript, some folks say, well, why would you use JavaScript? Why not just use C#? You can actually use both in the same project. Both of them are compiled, fully compiled behind the scenes. And this isn't the typical JavaScript that you're used to. Notice that you can really say that, for example, here, when the dinosaur gets close, we're going to play an audio clip.
Okay.
It's type audio clips. You can actually type your variables here. So it's a little bit more strict in that sense. So remember, behind the scenes, it's going to fully compile down. So a lot of the samples you'll find might be in JavaScript. A lot of the samples might be in C#. You can use those. You can use Boo, the language Boo, if you so desire as well. So my code here is in JavaScript. But just for the folks that like C#, let's go ahead and create, we'll just call this Dino script. Double click on that. And we can get our basic DinoScript class here. Start happens upon initialization for whatever object that we assign this to. As of right now, it's just sitting there as a script. Update is called once per frame.
Whoa.
So that's essentially kind of like your game loop for this object it's assigned to. A script needs to be assigned to something. So let's go ahead and take our dinosaur script and go select our dinosaur. And we're going to drag and drop this over on a dinosaur. Bam. Oh. Now we have a dinosaur script. What does this script do? Let's go back to that.
What does it do?
Dino script. Let's walk through it. We have a bunch of variables defined up top. These are var, so they're public. Now behind the scenes, notice that the C# class inherits from mono behavior. Basically, the JavaScript class does that behind the scenes as well. You just don't see it.
Okay.
So these are all public properties. Why is that important? If you're not a software developer, just know that whatever shows up here, you actually have the ability to modify here. That's what these properties all are. And if they are defined as a certain type, then that means you can drag and drop that type onto there. So what's the dinosaurs? Here's called enemy's target, because again, I pulled a lot of the script off the net. This enemy's target, and I have a sound as an audio clip. So let's do this. I have an actual sound file in here. And
Are those values encoded, by the way, like default values in Unity?
What was that?
Were those values that were in the script become the default values in that little editor in Unity?
Absolutely.
That's
you got
great.
It. So they are the defaults, then you can change it over right here. So for example, if I change chase threshold to 20, it will be 20 here, but in the script it still remains 10.
As a default.
As a default, yep.
Perfect.
It doesn't actually change the script if you change here, but it does become the default used value by Unity. So we've got a T-Rex sound here. Let's go back to our script. And now watch as I'm going to try to drag and drop, I don't know, a burger onto what is the sound script. Notice, I get, you can't do that.
I agree. It does not make sense.
Right. So it says, no, that's not an audio clip type. You can't do that.
Exactly.
But a T-Rex sound is an audio clip type.
You dragged on that field.
Yes. It was pretty cool how they do that.
That is sweet. I just wonder how they recorded it.
Now, this dinosaur, let's change something about our bullet here.
Okay.
As it stands right now, this bullet doesn't understand the world of physics. It's just a burger floating in free space. In fact, if we run and we turn around right now, there it is. See?
It's very Twitter quotable. It's a burger floating in free space. Okay, continue.
So I want to change the properties of this burger. I need to give it some sort of physics behavior. I think you guys demoed something like that in your game demos earlier. We need to define some sort of physics behavior, and there's two ways to do that.
Okay.
So one, we want to give this a rigid body, which basically makes it understand gravity and also understands torque and certain forces, not collisions. So we're going to do two things. When we throw this, we want it to drop to the earth, so it needs to understand gravity. Secondly, it needs to understand collisions with objects. We're going to do a box collider. And watch, once I click on this, you'll see a box form around the object. And that is its collision detection zone. So if it falls within this box, yes, you can do it more specific, but for a burger, that's pretty good. So now, if we start this game and turn around, our burger's now gone. It's actually falling down into nowhere. All right, now, so let's go back to our scripts. Our dinosaur has a script assigned to it. We have a couple other scripts to assign here. We have our fire rocket script, which I'm going to attach to my burger. And what speed do I want my burgers to come out? I'm going to choose 20. Now, it wants to know, what is my bullet? What is my rocket? And I want to use that hamburger patty right here. So I'm just going to drag and drop that. Say, you know what? Use this as my bullet. If I wanted a picture of a bullet object, I would just grab some other object here and drag it over here. I could actually use a dinosaur as a bullet and throw dinosaurs out. You can really do anything. Some cool stuff. Alrighty, now I have a main character script. This main character script makes sure that I don't leave the world. And again, this is something I found on the net. If I leave the world, it's going to decrement our lives.
Okay.
So let's go ahead and assign this script to our first-person controller, which is essentially me. So we're going to take our main character, drop that there. I have 3 lives. Now our dinosaur, as of now, oops, I did it again. I dragged this out. Let's go ahead and pop this back in. Now let's... Sorry about that. I'm moving my mouse a little bit too much here. Let's go ahead and run this. And when I throw... Oh, there's one other thing I need to do here. I'll explain what I'm going to do in 1 second. Let me remove my Fire Rocket script off of my burger. And I actually want to assign it to my camera. And I'll explain that in 1 second here. Let me set my properties. My speed is 20. And I'm going to be firing this hamburger. The reason I did that is what you can't see right now is I've rotated this burger a little bit. And so what happens if I fire something from this burger, it actually uses this burger's rotation and really fires straight up in the air. So I'm actually going to fire it from my main camera. That's why I assigned this Fire Rocket script to my main camera. Now let's see what happens. Look at that. Look at those burgers fly. Look at those patties.
Cool.
They bounce on the ground.
Very nice.
But now, there's one bad thing, though.
What? The dinosaur doesn't
Look at
care.
that. Right through the dino. It's like Frisbee golf in the dino.
No.
And it just goes right through. So that's because why? The dinosaur does not understand physics yet.
I see.
So let's go over to the dino, Mr. Spinosaurus, and give this dino a box collider. Zoom in a little bit on him. Now, this box collider, you'll notice, is actually sitting pretty low here. See it right down there? This tiny, tiny little box here. So what we want to do, oops, see, sorry about that. What we want to do is change this box collider to be, let's move it up a little bit, and size, we'll say, I don't know, 6. Try that. 6, and say 6. Let's go a little bit wider. Let's go maybe till 8, or even 9. Now, this is our collision zone for the dino. You may or may not find that acceptable. You say, you know what, this is a complex shape. I want to include collisions only if you get it directly. Does it matter that much? If you're firing bullets at it and you're in the zone, that's probably pretty close. You don't need to be that precise. But in Unity, you have control over that. You can actually do a mesh collider, which uses this full definition as an area of detection for collision. The problem with using a mesh collider is computationally it's very expensive. A box collider is easy to calculate collisions on.
Yeah.
A mesh collider, it's got to calculate all of these. So we're going to keep that at this box collider.
Okay.
Let's save that and go ahead and run it. And let's see if we can bounce a couple things off our dino here. There you go.
Oh,
so now
ricochet.
we're bouncing them off the dino. So the other thing that we need to do is my script for Fire Rocket. Actually, my dino here. Let's see. In my dino scripts, Unity provides you with a function called onCollisionEnter. That's called automatically by Unity, and it detects if there's been a collision with a rigid body. It says, you know what, we're going to go in here and call this function, and a whole bunch of objects could be hitting that dino right now.
Exactly.
I could be throwing a Frisbee, I could be throwing a hamburger, or I could be shooting with a shotgun. Each would have different benefits. So I want to identify my game object as my hamburger coming in. There's different ways to do this. The way I'm choosing to do it here is I'm going to name my hamburger bullet with this tag, the string. And I'm going to go over into Unity and define that tag. So I'm going to go to my hamburger here. And notice, on every object you can say, here's a tag. There's a bunch that are defined already, player, main camera. I want a custom tag. So I'm going to come in here, and element 0, I'm just going to say this is called hamburger bullet. And now I can select that as hamburger bullet. So now my script, I can actually set a breakpoint on that. This is cool, so I'll show this. I'm going to set a breakpoint right here. Going to run that.
Hey, while that's loading, you know how you created that box around that dinosaur for collision?
Yes.
Could you have multiple? Like if I wanted to have a box around the head?
Absolutely, and that's another good way of doing it too. So I should have mentioned that. You can actually have a box here, you can define a box here. Depending on how your mesh is broken up, you can absolutely do that. Define a long box there, so that is another
cool.
technique.
That's cool.
It's cool, it's another commonly used technique actually for complex shapes. So now I'm debugging, but I actually have to go into my game and run it. So let's run this and shoot something at my Spinosaurus. Hello, Spinosaurus. Bam. I've now popped into my debugger. And if I look at this particular object here, its tag is hamburger bullet.
Nice.
I can drag and drop that down my watch. Actually, for some reason, that's acting funny. So let's just look at it here. There it is, hamburger bullet. So I'm going to clear that breakpoint and just run this again. And now watch what happens when I hit my dyno.
Mm-hmm.
He eats the hamburger.
Oh.
So let's catch that again.
Okay.
I'm going to make this a little bit bigger. I'm going to say maximize on play right here.
Okay.
I don't want you to lose track of the dyno. Spinosaurus likes burgers.
Mm-hmm.
All right, so let's feed him again.
Oh.
He bites it. He bites it. But we all know hamburgers are bad for you.
Mm-hmm.
So if you hit the dyno 3 times,
Mm-hmm. What?
that's it. Dyno dies. Burgers are bad for you.
That's a good lesson.
Everything in
What are you trying
moderation.
to tell your son?
3 is too much. Don't eat 3 hamburgers in a row, regardless of who you are.
Okay.
So how did that happen? That simply says, I like the laughs here. Let's go to we have a couple things that are at play here. We have our fire rocket script. We have our dinosaur action.
Mm-hmm.
When collision happens, we're checking our hit count. If our hit count is less than 0, we are going to play the dead animation, and that's how you do it. Animation.play, and you have some predefined animation that you're playing. So it's very easy to play any animation here. In fact, notice that when we have our collision, I just say, go ahead and play the bite animation, wait for that to finish, decrement our hit count, and then, of course, if we're less than 1, then we play die. So let's do one more thing with this.
Mm-hmm.
Let's see. Our dyno has a script on it for dinosaur actions. I'm going to take... Let's see if I can't get the dyno in this demo too. Let me turn my speakers on. So there's also proximity detection. I don't know if I'm far away yet. Let's find out. If I get close enough to the dyno, there you go. Oh, now he's chasing us.
What?
Big old dino's coming after us. And we feed him, throw him. We
Ooh.
just off the dyno. And a couple
Now,
more for
there
you
are
there.
some comments from some folks that are watching that
Yes.
they don't want you to hurt the dinosaur.
Well, he's only playing dead.
Okay.
He's just
Okay.
sleeping.
I'm just saying.
He's just sleeping. That's funny. But it's as simple as that. If hit count is less than 0, go ahead and play the dead animation, die, and just set in a flag.
Wow.
So let's stop that debugging there.
Okay.
Now let's do one more thing on here. I have another script on my main character. I was showing you before that I can fall off the world. So my script, what it's doing, it's simply saying, if you detect that your Y position is less than -1, in other words, you're falling off the world, because we started above that, reduce your count of lives, which by default was 3.
Mm-hmm.
If it's less than 1, throw some debug information out there, and load level 1.
Okay.
Well, that's not going to work right now, and I'll show you why.
Okay.
Let's start this. I'm going to mute my speaker so we don't have to keep listening to that. Okay, now notice, I fall off the world. In fact, I'll do this again so you can catch it. Watch, there's a little dynamic text being displayed here.
Mm-hmm.
That's done from the script. Lives equals 3.
Mm.
Watch when I fall. 2. Now we could do an effect on here that flashes the screen red.
Mm-hmm.
You know, don't fall off. You can actually, if you wanted this constrained, you can just put borders around here. You could put walls around here, mountains around here. So I'm going to fall off again, but now I'm going to do it one more time. Watch what happens.
Mm-hmm.
Now notice my lives. They're dropping and dropping and
that's
dropping
horrible.
and dropping. My script said don't do that. Load up level 1 when you die. So here's the problem. I don't have a level 1 defined yet. I only have my main scene.
Oh.
So let's go into build, which I do Control-Shift-B. It's actually the same thing for Visual Studio.
Mm-hmm.
And here are all the platforms that you can target.
Can you scroll down that list? I think a lot of people are curious what are the possible outputs. Is there anything that specifically addresses HTML5 apps?
So
Would that be a web player?
You do not. You have actually a web player, but that is a component that needs to be installed in a browser to run the game in a browser. In fact, Unity has a really cool gallery online. You install the web player, and you can play all these demos right in your browser. But they are still running in an engine. They're not HTML based.
Okay.
All right, so what I need to do is add my current scene, the one I'm looking at, and that becomes scene 0.
Okay.
So now I need scene 1. And what I'm going to do is in my bird flock, they had some demo scenes in there, and I'm just going to use one of them. I'm going to open it up, and it does nothing but show some demos of their birds.
Okay.
So that looks like something good when you're gone, right? The vultures are flying around.
I think so.
So I'm going to just say the same thing. I'm going to go in my build settings, Control-Shift-B,
All right.
and I'm going to add this current scene. If you don't do this add scene, they will not be included in your final output. So you must add your appropriate scenes in. You could have 100 scenes in your project and only use 2 for your final build if you want.
Okay.
So now that I have those scenes, they're 0 and 1. You can actually do this by name too. In my script, when my lives get less than 1, I'm loading level 1. You can actually load a level by name as well. I'm just going to use this.
Okay.
Now, this in of itself isn't that great. Let's go ahead and create a game object of some GUI text. I'm sorry, let's do 3D text here.
Oh, yeah, you might as well do 3D.
3D text.
Capitalize on it.
I'm just going to make some large overlay text here, and we'll do font size. Let's see what 100 looks like.
Oh, okay.
Now, hello world, and let's do something appropriate since we're dealing with burgers. You ate it.
I like it.
And I want to move this text over a bit. In this direction.
Okay.
So let's see what that scene looks like. Perfect. That looks good to me. I'm going to save it. And let's load up my main scene again. And run the game. And I fall off the world. Now I'm at 2. I'm at 1.
That is awesome.
So now we'll watch what happens here. And there's just a slight, you can tell, a slight mild rotation that goes in here. You can have other buttons to restart your level. You can do really anything that you want here.
I guess there could be an angel resource pack too, right?
You could, yeah.
There could be. You never know.
All right, so let's jump back to a couple slides here. That we've shown some of the power of Unity here.
Have a lot of fans that have indicated they've really enjoyed what you've done so far.
That's good. That's good to hear. So we showed our demo, and what'd you think?
Loved it.
So in summary, with Unity, you can use your imagination. You can do anything on the layout that you want. We showed creating terrain, adding assets to it, projectiles, character movements, building. And if you want additional samples in Unity's asset store, you can pull in projects from inside of there, run them in Unity, or you can run them in the browser. And they have a whole bunch of free games that you can download, complete games. A really neat one, if you want a first-person shooter, is called Boot Camp. You can download Boot Camp, import it in your project, open up the scene, and run a first-person shooter, which is pretty well detailed and refined. So some really awesome stuff, great learning resources.
Wow.
And I hope you enjoyed this on Unity.
I sure enjoyed it.
All right, I love Unity. It's pretty cool. Thanks for attending today, and we'll see you for the next module. Welcome to our last module of the day, Module 6. We're going to cover monetization and store submission in this, and
Very
gaming
important.
analytics. Thank you for hanging with us so far today. We've got another good session coming up for you. And so let's dive right into monetization. So monetization strategies, there's many different ways that you can make money off your application, wouldn't you say?
Yeah,
Many,
lots.
many ways. You could have a free application. You can have a purchase, which in the Windows Store is a minimum of $1.49. You can have a time trial of your application, expires after X number of days. You could actually even have timed features. You can have in-app purchases and consumables if you want to buy gold coins in an application or more levels for your application. There are third-party commerce engines, and we'll talk about those just briefly in a little bit. You can use Microsoft Ads through the Pub Center. You You can use a third-party ad sharing network. At Microsoft, we try to give you many, many choices on the way to make money on your application. Possibly more so than most other platforms, I would like to say. We provide a lot of choices there, right?
I know for most of the platforms, they're going to take something like 30% of the revenue for handling the commerce for you. You know, they're providing you a great service. And with the Microsoft platform, it's going to be a 30% cut only for the first $25,000. And after your app has made $25,000, then they're only going to take a 20% cut. So you're going to be making 80% of your profits after $25,000.
That's pretty good.
And like you mentioned, you could use third-party commerce, and then it's all yours.
It's all yours, unless your third party takes a lot of that. But yes. So let's go ahead and look at what some of these options look like here. There's a very famous game, Cut the Rope. Now, this is a free install. So the idea with this, that you get the game for free, and you have the option of purchasing some additional levels later. But the actual game itself, you get a good experience. It's free, and I think Jeremy will cover that a little bit on how you do that on store submission.
Right.
So another game here, Halo Spartan Assault. This is an outright purchase of the game. $6.99, you click on buy, and you have the game. Now that doesn't mean you can't have other in-app purchases. Maybe you want to do other levels in there or advanced features in there. But from a basic level, that's what the buy interface looks like when someone goes to purchase your game. Now, if you want to do a trial, you set that also upon upload. And you can detect features while your application's running. You can do feature trials or a full application trial. In this case, we're looking at a screenshot for Bejeweled. So you can come right out and buy this for $4.99, or you can try it for X number of days. A third scenario is you can have someone try your application and certain features expire after a certain amount of time. They can actually purchase them for an amount of time. This one here is from Cut the Rope on how you would actually purchase this once the game's running. So it's a free game. You play a bunch of levels. I love this game. Then you can go on and buy the full game and get a whole lot more levels. So this looks like it's an outright purchase, but because of the way that this is integrated into the game, this is an in-app purchase. And once you would click on buy full game, the API controls the interface here to confirm the purchase from the Windows Store. You click on buy, and you go ahead and purchase it, and it's now per your Microsoft account, per your email account, whatever you've registered with, this game is now yours, and it can actually travel across devices.
And by default, I think this is nice. By default, it prompts me for my password again right there after I hit purchase, so that if somebody's picked up my tablet because I set it down, they can't go to the store and spend a whole bunch of my money without my password.
Like if the kids load it up and they want to buy an awesome dino and hamburger game? Yes.
I think there's a maximum price for the store of $9.99. So, real close to $1,000. Do you think you'll be able to get that for your dino game?
I don't know. There was a lot of excitement over that. This one here is an example of ads in an application. This is Card Games Chest. A whole bunch of card games in a suite for Windows 8. And at the bottom of the screen, on the lower left-hand corner, you get various ads that rotate while you're playing the game. Now, this is a great strategy for making money. We'll talk a little bit more about that. But the idea here is when people are playing the app, they want to unlock additional features or just get rid of the ads or both. And they can click on the Remove Ads button, and they'll be prompted to purchase it, and the ads go away. Now, when you write your application, you have to detect they've done that purchase, that they've purchased that particular feature, and make sure that you don't show that anymore. So you do have a little bit of code in that, but some of the gaming frameworks do have those features integrated, so it's a couple clicks and away you go. Next, Jeremy touched upon this quickly on the revenue share, but here it is in front of you to take a look at with revenue sharing up to 80%. So by default, everybody's 70% across the board, up to $25,000. Above $25,000, you keep 80% of the money. Nobody else does that. So it's another cool way if your application is very successful that you keep even more money for your game. Another option that we allow is third-party commerce. So let's say you want somebody to purchase through PayPal in your application. You can easily integrate. There's actually a PayPal SDK that you can load up into your Windows 8 application and have somebody purchase more levels or whatever feature in your application. There is no revenue share with Microsoft. Microsoft does not get a cut of that. That is between you and the third party itself. It gives you a lot of flexible options. There's a lot of different commerce providers, payment providers, and I'm seeing growing numbers of SDKs for integration into Windows 8 WinRT applications.
There's actually one website to go to. Are you going to talk about that?
Which one?
Services.windowsstore.com.
Excellent.
Yeah, services.windowsstore.com will show you all of these third-party partners that you can basically just plug in to your Windows 8 app and take advantage of.
And that's a good point. You don't want to think that suddenly you can just go home and say, I'll write my own credit card processing service, because there are certain security features that somebody needs to implement. Writing your own payment provider takes kind of quite a bit of work, so you want to make sure that you incorporate that into your application using an established source. I just don't want to make the point that you can go home, collect credit card numbers, and start keeping them, because you can't. There are definitely some restrictions there, but there are many providers you can integrate with. Let's take a look at what the Pub Center looks like. So the Pub Center allows you to define ads. And pop out of... Can you see it? Are we good? We're good. Alrighty. Let me sign into the Pub Center here. The Pub Center is where, for Windows 8 applications and Windows Phone, that you go to set up your application to receive ads. There are only two things that are required here. You register an application, and you say it's going to go to Windows 8 or Windows Phone. We'll call this Feed the Dino. Now you have an application ID. That is one of two pieces of information that you need to use this in your application. The second is an ad unit. And the reason that you need ad units are to define what sort of ad sizes are going to be in your application. So let's go into create an application ad unit. And we want to call this we'll call this 728 by 90 bottom bar. The reason that you might want to name your ads something important is if you have multiple ads in your application, that when you go into analytics later on, you can see which ad is maybe bringing you more money, being displayed most. And ad unit size. You have several sizes to choose here, and you can see where they show up in your application. These are just recommended placements. They don't have to be in those locations, but you do want to make sure they flow well inside of your application. Now, there are ways in the various frameworks that we've discussed to get ads in your apps. Construct 2 and YoYo Games GameMaker. There are plugins that you can get, right, gentlemen, to be able to incorporate Pub Center ads into there.
Yeah, actually,
Michael off camera. What's that?
a colleague of ours named Ryan Joy wrote the plugin for Construct 2. So I'll go ahead and drop his information in the chat window if you want to tune in there and find out where that is.
Perfect. And since there's an ad SDK that you can download for your WinRT applications, because Unity can export to Windows 8, I showed you through the build window, you can just simply open up your XAML C# project, drop in your ad SDK in there. There are also third-party plugins that you can purchase as well that integrate with the various stores on there as well. So you can get in-app purchases through Microsoft, Pub Center through Microsoft, using a third-party component. Or if you just want to go in and use the code yourself, you can do it manually as well. So we've set up our ad here, and you can specify your categories of ads that you want to be shown. So it's a game, so maybe you want to stick specific to the gaming realm. Save that. Now your ad unit is created. You have the two pieces of information that you need to be able to display your ad in there. And it says to enable this ad in your application, insert this ad unit ID and application ID in your code as explained here. It's a very easy setup. Use your ad unit name and this ad unit ID and your application ID, and you are all good to go. So let's switch back to the slide deck here and talk about which way you want to go on how you're going to do your application. You have many choices, right? So you can go free. You can go free with ads. You can go free with in-app purchases, maybe with ads too. You can have a trial. You can pay once for an app. You can pay once for the app with features enabled via those in-app purchases. You can have all of the above choices, maybe with consumables in your application. Consumables are, let's say you want somebody to purchase extra power for their characters or gold coins in a game, something that they use over and over again. Maybe they want to purchase a pack of gold coins, and then they want to purchase another one and another one and another one. So those are consumables. Maybe you want some sort of subscriptions to your application. There are many choices to consider on how you want to make money off your application. It's been said that you want to change your strategy potentially as you go on. You might try an application strategy now that you realize a few weeks after deploying your application, it might be better. So you might start free. A lot of people are using the application. You might say, you know what, I want to release a new version with in-app purchases. So be prepared to make some changes to your strategy that you're going to be using. If it's a brand new application, consider an outright application purchase and then maybe in-app purchases, or maybe even provide a free app with in-app purchases. One of the reasons you might want to include it purchase up front is maybe a lot of people don't know about it. You want to start recouping some of that development cost. So you may want to have it purchase and then additional in-app purchases. Later on, once you get a large user base, you might say, you know what, I want to put out a version of this that for new users that have ads. But you want to be careful because you don't want old users who've previously purchased it to start getting ads. So you have to do a little bit of feature detection as you write your game. You can provide in-app purchases for various levels, additional levels you want to purchase for your game. In all of the games that we develop, we might want to add extra levels. Maybe new dinosaurs that you can purchase, extra levels, extra dino worlds, goal and capabilities. So just be prepared to make changes on the strategy and various releases for your application.
All right. I think we should talk about store submission. After all, you've just created an awesome game. You may as well submit that to the store and start making money, right?
Definitely, definitely.
Absolutely. Okay, so here's the thing. The Windows Store is a really good, it's a great marketplace, especially right now because it's still a relatively small marketplace. I don't know how much longer we'll be able to call it small because it's growing like gangbusters.
Sure is.
It really is. But you don't have 2,000 of the same exact kind of app in the store yet. And so if you make an app that has any kind of differentiation, if it's unique at all, you're going to be the only one in the store like that. And so you're going to be able to, you're going to seriously have some opportunity. And that's really what we're looking for as developers. So it's a great store and it's a great opportunity, and we want to package up our project and we want to put it in the store, okay? So let's go ahead and take a look at what it is that the store is expecting from us, all right? The store is expecting this. This is an AppX upload file, okay? It's one file. It ends with .appx upload. And the store doesn't care whether you started writing in Unity or GameMaker or writing from scratch or whatever. However you wrote your application, this is what the store needs. Now we're going to fill out an entire application for submitting an app to the store in just a second, and we're going to provide it with one of these AppX uploads. But because we're all developers and we're all geeks, what I'd really like to do is dissect one of these for you. Okay, so this is kind of like physics school, and we're going to take one of these apart. So I'm going to jump over into my file system, and we're going to look at an AppX upload that I've created elsewhere and for other reasons. Now, I just talked in the chat room about a project that I do called CodeShow. CodeShow is a Windows 8 app using HTML and JavaScript that's sole purpose is to teach you how to make Windows 8 apps using HTML and JavaScript. So we actually, Adam and Michael both work on this project with me, and we are currently working on the Windows 8.1 version of it. And this might be a really good time to invite you guys to join us tomorrow. We're going to do another jump start, and we're going to be talking all about the updates in Windows 8.1. So if you've seen our jump starts from before, you can find those at aka.ms/jump480, jump481, and jump482. If you've seen those, this is going to be the refresher course. This is going to be the addendum that adds on everything that you need to know now that Windows 8.1 is out, okay? So we're working on CodeShow for 8.1, but I'm going to go ahead and dive into Windows 8 code, and this is all out on codeshow.codeplex.com. It's all open source. And if you look in the Windows 8 JavaScript package project folder, you'll find an app packages folder. This is where by default, whenever you create a package for the Windows Store using Visual Studio, this is where it lands. So, and we're not going to necessarily, well, I guess it would probably be helpful to show that real quick, so I'll get Visual Studio opening in the background. But whenever you build a package for the store, it lands in this app packages folder, and you get two versions of each thing. So you get a folder with all of the goodies inside of it, and that's good if you're trying to distribute it to somebody else, another developer on your team. You just want them to install it, whatever. But it also gives you these AppX upload files. All right. So I'm going to take one of these AppX upload files, and I'm just going to make a copy of it, so I'm not working on the original. And I'm going to rename that, and I'm going to give it the last name zip. Do you want to change it? Sure. Now it's a zip file, right? Let me go ahead and extract that. So now I have a folder, and that's over here. This is what's inside of that zip file, okay? Now I'm going to take one of the files that's inside that AppX upload file is an AppX file. I'm going to take that and I'm going to rename it to zip. So we've got two levels of zip files here. So I've renamed that to zip. Now I'm going to extract that one. We're going deep here. We're going 2 levels deep. Now I've got another folder and I'm going to break that open. Now because this is an HTML and JavaScript app, an app that was written using HTML and JavaScript, you're going to see all of your HTML and JavaScript resources here. You're going to find default.html. Here's a JavaScript folder with a bunch of JavaScript in it. You're going to find all of your CSS, all of the other frameworks that we've used in here. There's a folder of images, and that's where all the raw images are. This is your AppX upload file dissected. This is what it looks like inside, okay? And this is exactly what the store is expecting, even though there are a variety of ways to get it. So by the way, if I open Code Show in Visual Studio, the way to build one of those packages from a Visual Studio project is quite simple. When you have your project open, and we're looking at Code Show right now, you just go to Project, Store, and then you choose Create an App Package. All right? So that's the AppX upload file. That's what the store wants, and we've dissected that. We've dissected that in its entirety, 2 levels deep, and looked at the raw guts of, let me get to my right slide, we've looked at the raw guts of the AppX upload file. Now, what is it that the game engines are going to give us? Scirra Construct 2 delivers for you a Visual Studio project. So that's pretty cool. It gives you all of the Visual Studio, it gives you all your assets, your HTML, your JavaScript, and theoretically at least, you could go in and change that to your heart's content and do whatever you want with the JavaScript and do whatever you want with the HTML before you package that up into an AppX upload file and submit it to the store. Now I say theoretically because the way that Construct 2 builds your code, the stuff that you've written in your game engine, it's pretty hairy. It's pretty difficult to parse that as a human being and figure out what's going on, and especially to modify anything. Now, if you want to overlay some things, so if you don't want to use the add framework that comes with your plugins, you've got something special going on, you can easily overlay things in that project and then build it. So that's pretty slick. Michael, do you want to tell us about what GameMaker offers us?
Basically what it does, especially for Windows 8, is it's just the AppX upload file that you get. And of course, they're dynamically generating that every single time. So even though there is a way that, and some have figured out a way to get to the source and actually create a Visual Studio project from it, anything you would do in GameMaker from that point forward would destroy or be destroyed. So you have to be careful. But the actual, once you get the actual created AppX upload, it's the same thing that you would use to go ahead and submit to the store. And they provide a lot of things as far as metadata that you would typically do, let's say in Visual Studio, like what are going to be my tiles, what are going to be, what do I want the name of the package to be, what's my certificate as my developer with my account. All of that can be done through the GameMaker IDE.
And then Unity has, it's going to deliver for you a Visual Studio project, and it's got a few different options. You can deliver just a raw C++ DirectX, or you can have delivered to you the C# XAML. So I think the guts of it are still in DirectX, but you can overlay with XAML using that option.
Yep.
Then you build, then you have your AppX upload file. Yep. Cool. So that's what the different engines give you, and that's what the store is expecting. Okay, so let's take a look at what it looks like to take this AppX upload file and actually submit it so that you're going to be in the store.
I want to see it.
Let's do it. I'm going to go to, make sure I'm not still sharing my slides. I'm going to go to this email or this website URL that you should probably commit to memory as a Microsoft developer, dev.windows.com. All right, dev.windows.com takes you to a link that has, it's the Dev Center for developing Windows apps, and one of the components to it is the dashboard. Some of the other components, by the way, is all of the sample projects, all of the documentation for the entire WinRT API, and all of that. But you also have your dashboard. And I'm going to go to the dashboard, and I'm already signed in, as you can see up here, signed in as Code Foster. And so it shows a number of apps. Some of these I've created, and some of them I'm just working on, and some of them have failed certification.
Oh, I wanted that name, Fake App 87.
Oh, no, I'm sorry, but that is
you got it taken. Okay.
I definitely got that one first. But if you wanted Fake App 88, you're getting out of luck, because I'm just about to take it.
All right. Oh.
Okay, so what I clicked, I don't want to do that too quickly, so I'm going to actually go back and show you that again. From my dashboard, I click Submit an App. Okay. If you don't have any app, if you just recently got your developer token and you're brand new to the dashboard, all you're going to have is one tile on there, and it's going to say Submit an App. Okay. Once you have more than one, then you have a link on the side, Submit an App. So I'm going to click on Submit an App. And that's going to take me to my application. My application is multi-stage. It's very nice because I can do some of it today, some of it tomorrow. I can get distracted if I want to. So it works like I do. The very first step is called app name, and it's super simple. There's one thing you need to do. Okay? Well, after you sign in. So everybody, close your eyes.
I saw it.
Did you see it? No. Okay. So the app name is the only thing that's needed here. Right. I could use this to just reserve a name.
Oh,
for instance, let me go ahead and reserve Dino Burger.
Oh! Do it!
No, I'll save that one for Adam. He might want that one. I'm going to go ahead with the almost as popular and in demand Fake App 88.
Okay.
Reserve the app name. It has to look for it. It's looking in the app
Don't
universe.
Don't be too cocky. It might. Oh, okay.
Okay, it's reserved for our app. Good. I can save that. And now listen, this is important. Okay. I now have an app on my dashboard. I have an application that's in the process of being filled out. That's important because from Visual Studio, if you want to create a package that's already packaged for the store, you have to already have your app built.
Ooh, yeah.
The application for it anyway on your store dashboard. You don't have to have the whole thing filled out. In fact, all you need is this app name.
You mean to tell me that from Visual Studio I can't do this part? I have to go do this here?
Well, sort of. In Visual Studio, there's an option to reserve your app name, but it just takes you here.
It just takes you here. So really, this is important.
Yeah. Yep. And this is my workflow. I come here first. I save my app name. Actually, I usually do that a few months before my app is completed, just to make sure that nobody steals Dino Burger.
Yeah, and I didn't want to give the wrong impression to anyone. You should come here first and get your app name and get this stuff taken care of as much as you can. There's a point where you need the AppX upload, but as much as you can, you should probably start here. Don't get confused by what I said. Visual Studio provides you a link to come here, but just remember that URL. He said dev.windows.com.
Now let's jump over to Visual Studio. I'm going to close the project the code show project that I was currently working on, and I'm going to do a new project from scratch. New project. We're going to choose a JavaScript project using the hub template.
Cool.
We'll call this Fake App 88. It's residing in my temp folder, which is the perfect place for it. There we go. Now let me run this app, and you can see that with zero effort, this is what a hub template gives me. Here's my Windows 8 app. What? All right, there we go. I've got a Windows 8 app. All I would really have to do is replace, let me get fancy here, I'm not, I thought I was in PowerPoint for a second, sorry. Replace this image with an actual image and replace some of these other ones, replace some of my data, but I have a working app here. There's an item. Some of these sections have little chevrons on them, which means I can dive into that section. It's a working app. There we go. Now, if I want to, I'm going to close that app and go back to Visual Studio. If I want to put that app in the store, I already built the beginning of my application in the store, right?
Yeah.
So I want to go ahead and submit this. I want to package it up to be submitted. So I'm going to go to the project menu, like I showed you, Store. Can everybody see that? Let me zoom in a little bit.
Using native magnifier.
All right. Project. Follow my mouse. Okay. Oh, and now I'm not in the project menu anymore. Using native magnifier. Okay, so I want to go to Package, or Project, Store, Create App Packages.
I'm with you.
All right. Is everybody else with me? So here is an option. Are you building this package for the store? If you say no, then you can just build a package. It won't be the AppX upload, but you'll build a package and you could give it to your colleagues and install it on their machines, but it's not ready to go to the store. It doesn't have your store certificate built into the package. It's not going to work.
Okay.
But we have already created our application, so we just say yes. Now it asks us to sign in again. Everybody close your eyes. You're on the honor system. This is a special program I have to white out the screen while I'm typing my...
That's impressive.
Yeah, isn't that good? Let's try this again. Sign in. Oh. Well, that is just flat not working. Well, that is interesting. Haven't actually seen that feature before. I'm going to reopen Visual Studio,
Sure.
open my fake app, and see... Oh, it was over there on my recent. See if just a restart, restart is usually going to fix.
Now, I know I mysteriously replaced Adam Tuliper here, but I just wanted to confirm. Did you mention that you were actually using the preview version of Visual Studio 2000?
Yeah.
We're dealing with, right now we're dealing with the preview.
I love having that as an excuse. Yeah, this is Visual Studio 2013 preview. If
Trying to
anything
bail
goes
them out.
wrong, it's not my fault, right?
Okay.
But by the way, it works just fine. And
Oh,
I
it
think we
works
should
now.
blame
Okay.
Magnifier.
Oh, it was Magnifier, okay.
There we go. All right, so it needs me to sign in. Visual Studio itself is going to look at the store, at my account, and see what applications I currently have in process. Do you see one that looks familiar?
Yes.
Yes, you do. Fake App 88 next. It's now able to query the store and get the details about Fake App 88, the publisher, the official publisher name, the package identifier, things that I could look up on my own and go right into my package AppX manifest, but it's easier to let it do it. Now, this is where it's going to build the package. So I'm going to copy that location. I'm going to take all of the defaults here and just hit create in the interest of time.
Okay.
Now, in case you didn't copy that location, an easy way to get to it. Now, I'm sorry, let me not pass over this.
Okay.
This is going to give us an opportunity to launch what we affectionately call the WAC.
Ooh.
As
the
in,
WAC.
that's WAC. This is WAC 3.0, though. The one that comes with Visual Studio 2013 Preview is WAC 3.0. This launches a series of tests that take long enough that I don't want to do it on camera.
Wow.
Yeah. It might take, I think it takes 5 to 8 minutes. It takes a little while.
Okay.
It runs a lot of tests, very extensive, and you definitely want to do this before you submit an app to the store, because if it fails WAC, you're going to fail your store submission anyway. So you may as well find out early. I'm not going to launch WAC. I'm going to hit close. And now, where did it actually build my app, my package?
In the URL in the clipboard.
Exactly. It's on my clipboard, but if you forget to grab that, you can right-click on your project and hit Open in File Explorer, and it put it in the App Packages folder. Wow. Okay, let me dive into there. Again, this gives you two things: a folder with all of the AppX file and a PS1 file. This is a PowerShell file that you can use to install this application on somebody's machine. So if you zip this up and deliver it to your buddy, and he has Visual Studio and a developer license on his machine, he can install your app right there.
Groovy.
Groovy is exactly what it is. But if I come back up a level, because I chose to associate this with the store, I have an AppX upload file. I could dissect this and see everything inside of it. It wouldn't be any surprise. This is what the store wants. Okay, so we got that part completed. We're working in two different workflows here. Here's Fake App 88 in the store. Let's go ahead and fill out the rest of this application. I'll save some time on some of it so I don't bore you with details, but I want you to see all of this. So step 2 is the selling details. This is where we implement what Adam taught us about monetization and our options for monetization. If we want to give this away as a free app because we're just a nice person, we can choose free, and then we don't have to implement any other in-app purchases or advertisement frameworks or whatever. It's free.
Correct.
Now, if I don't consider myself an extremely nice person and I want to actually make money, which is not actually a not nice thing to do, that's a double negative, so it's a nice thing to do. Let's charge people $249, okay?
Why not?
Why not? But let's definitely, I highly encourage you to give them a free trial period. The conversion rate on apps that have a trial period is pretty high, and the initial download rate of apps that have an initial trial period is like 70 times more or something like that. It's huge.
Wow.
And think about it. You see an app, it looks appealing, there's a trial mode, you say, hey, why not? I may as well, right? So let's give them 7 days, and that's all done. I don't have to implement anything in my app around trial except for that one box.
No code.
No code whatsoever.
What?
If I want to, I can query in my code and find out if I'm in trial mode, and I could do some things different, but I don't have to. And then after 7 days, it automatically says, hey, you're going to need to buy this. That's what the developer chose.
Gotcha.
Very easy. All right, I can choose that my app uses a third-party commerce system for in-app purchases. I'm not going to choose that right now.
Nice that we have that option, though.
Absolutely. I can choose what markets this is sold in. Now, one of the viewers of today's show asked in the chat a little while ago, why don't I see Headless, the Headless Chicken app, in my store? By the way, I'm in Brazil. And the reason why he didn't see it is because whoever submitted that app determined that it's not ready for the Brazilian market. They don't have all the titles in Portuguese. We don't think it's going to be of value. We don't want to put it in that market yet. And so they did not check the Brazil marketplace.
Do you mind if I say something here?
Sure.
So the other thing that you need to be careful here is you might have the inclination to select all of the markets and just think, well, I won't care about the language thing. I'll just make it English and that should be good enough. And that could be good enough. But you also have to understand that some markets actually have some, especially when commerce is involved, they may have some rules and there may be some regulations that you need to be aware of. So be careful, especially when commerce is involved, that you understand what those rules are, and you do have to do your due diligence.
Yep. Now I have selected all, so we're gonna make this one available to all markets.
Nice.
Nice. I get to choose a release date. If it gets certified, should it go in the store automatically, or do you want an opportunity to do some marketing or something first? So we'll just say immediately.
Okay.
We'll pick a category. I don't know what kind of app this is. This is a blank app. Let's just say it's a food and dining app with no subcategory. And there's some other options I'm going to pass over. I will say, don't check that this app has accessibility considerations if you haven't done explicit work to make it accessible. If you check this and you haven't done certain things, you will fail, okay?
Okay.
Let's save that. That's going to take us back to our workflow and show us that we're done with step 1 and 2. It's nice and intuitive. I like that.
Wow.
Let's go click on services. If you want to integrate with Azure Mobile Services, this is a good way to tie that together. If you want to add some in-app offers, so if you have an in-app purchase, you want to sell a level pack 2, you would include that here. You would give it a unique product ID, so level pack 2, something like that, something that you can query in your app. And then you would determine that costs, like you're proud of this level pack 2. I mean, the initial game is $249, but this level pack is $220.
That makes sense.
That makes total sense, right?
Yeah.
And it's good for only one day.
That's great.
Yeah, I think I'm probably going to sell a lot of these, and then I'm going to go ahead and hit save.
Okay. And of course, that link there says you could add some more if you wanted to.
Absolutely. Yep, I could add many offers there if I'd like to. I then go into the age rating and rating certifications. Now, on this one, you have to read these carefully. And if you don't know which one to choose 12 plus. Because if you choose too young, then if you have anything like, if your app even requests the capability of accessing internet and you don't have special things in place, then it's going to fail certification. So choose 12 plus. And there's a bunch of information there that you should most definitely read. Since you've chosen some other markets, you need to have certification for certain markets. There are lots of safety checks in place. Cryptography is a super easy one. That's just saying, no, I don't have strong encryption in this app that's going to require a special license from the federal government in order to export, okay? So
that was easy to answer.
Exactly. No, and yes, I'm sure about my answer of no.
Look how many steps you've done.
Exactly. Now here's the beauty. Here's the magic. Here's where it wants the packages. So I go to the packages page, and all it wants me to do is upload the package. So I flip over here, and here's that AppX upload file.
Yeah.
I drag that over here, and it says, all right, cool, I'll go ahead and upload that for you. In Windows 8.1, there's a really cool ability for it to accept packages that represent your executable and packages that represent your resource pack. So if you want to build huge games, you don't have to upload a massive executable for each and every architecture. You can upload your different architecture executables, and then you can upload your resource pack separately, which is really good for the user. They don't have to download a ton of things.
Sounds like something that might be in that HTML5 refresh tomorrow.
It might be.
It might
Absolutely.
be.
Now this is giving us a little validation error on it as well. It should, but that's just fine. We're just going to skip that. Now, as soon as you fill out the packages and you don't get the validation error, the last two steps are really straightforward: description and notes to testers.
Right.
Okay, you go into the description, you describe your app, you give it some keywords. This is where you take screenshots of your app. And to take screenshots, by the way, all you really do is you run your app, and then you hold down the Windows key and print screen, and you'll see your camera will flash like it just took a picture.
Yeah.
And in fact, I just took a screenshot. So let me fly up in the air. Take another screenshot.
Oh, live
I know. We want to go back out. We want to.
Where did they go?
Let's go look in my pictures folder now at the screenshots. And you'll see that I have taken these 3 screenshots of Headless. All right? Those can be uploaded, and I give them captions. This is what your public is going to see. I say take very extra special consideration of the way your icon appears, how you describe your app, whether or not you have a trial experience, and I think you should, and what screenshots you have available. Those 4 things are really going to sell your app, okay? If there are 8 different apps in the store that do something similar to yours, people are definitely going to choose yours based perhaps on just the icon alone.
Cool.
That's a reality. Okay.
Sweet.
So we add some notes to the testers. This is if you have some sort of an app that you need to tell the testers you need to sign in with a special account in order to test this functionality. Maybe they have to sign in with a special account to test the app at all.
Right.
So you need to give the testers some special notes. And then once you're done with that, this button here lights up and you're able to submit for certification. You instantly get an email saying your app has been submitted for certification.
Nice.
And then in some period of time, under 2 weeks-ish or something like that, I've seen it happen in as few as 3 hours.
I have too.
You'll get another email that says your app's been certified, and then shortly after that, your app is in the store.
You might even give one sooner that says it wasn't certified.
Yeah, you might get one sooner that says
And
it
if
wasn't
that happens,
certified.
they'll explain, and then you have to go through the process again, or repeat some of those pieces again.
Yep, absolutely. Okay, let me see if that does it for the store submissions section. I believe we covered everything. And we're ready to move on to
Game analytics. I'm so excited. This is the final portion of the final module. Very cool.
I'm feeling a little verklempt, though.
Well, let me tell you, this is pretty cool stuff. I'm really going to enjoy this because I didn't even understand that this existed until I really started getting into gaming in the last year or two. And when I started to understand this more, I could see how some get real successful with what they do. Would you like to be successful at what you do with your game? You must listen to this portion. You will hear this and you will think, okay, I don't even know how I could submit a game without doing this. So, let's roll. Let's take a look. Gaming analytics. Let's first identify what it really means. Think of it this way. You could look at it as a report of all or potentially all aspects of gaming data. And I mean anything you want to know because you're kind of in control of all of this. Report is one thing. A live feed, a live report could be another. There's some ways that you can pull this off. And so analytics really says, what's going on? That's really what it's about. But not only what's going on, but what's going on that's important to you in order to know how to, 1, strategically understand what to do, or 2, understand what you need to fix or react to things that are going wrong. So that's really why analytics. If you think about it, analytics had existed for a while in websites. People who understand that notion of they want to understand their traffic to their site. They want to understand who accessed their site. They want to understand all the data around all the traffic and the decisions made. Many of you understand that if you had a website out there and you wanted to understand the analytics of it, you implemented some kind of analytics engine so that you can get feedback such as, when I promoted this on Twitter or did this, was there a jump to the number of hits and views on this particular page? Well, guess what? You can do that in your game. It's exciting. It's very exciting. So we want to know how to implement that and leverage it. But the thing is that every single gaming engine is going to implement them differently. So this is not going to be a how-to. It's going to be a, here's what you need to know in terms of the term, what analytics is. And I'm going to give you enough to say even what you get out of the box, which is coming up, and then some options that you can have moving forward. So I like that last line on this slide here, though. It says analytics replace guessing with strategic data. Don't say, I think this is what people do. Say, I know exactly what's going on. Then you can make some strategic decisions. So out of the box, if you take a look here, what Jeremy just showed you was how to upload your app or your game into the store. But once it's there and it's starting to go full, throttle and people are starting to use it, we at Microsoft provide you information so that you can understand what's going on. So what we're looking at right now is what's considered the summary page. This gives you a little bit of understanding, like what's the current ratings. Now this is actually from an app that I submitted, and this screenshot is from a while ago called Tile of Time, an app that just basically shows you the time on your start screen. And you can start to see the downloads, and you can start to see some of the various pieces of quality information. This is just the summary page. When we move to the next page, we can start to see usage. How is it used per day? And you can see that we can follow that for the last minute, 12 minutes, whatever the case is. It's pretty cool. I'm sorry, month. I'm saying minute, but I meant month. You can also get this demographic type of data. Where are people downloading it the most? And what age group? And down to gender. Now, again, this is what you get out of the box, but this is all regarded analytics, something that can help you understand your data. Recall that from the beginning, we talked about planning your game. Now, see, if you're planning your game correctly, that meant that you understood who your target audience is. And then the data that you're going to start to see on screens like this would indicate if you're getting to those folks that you want to get to. So make sure you're reading this stuff, and you get this for free. This is part of your developer account when you submit your app to the store. Now, you also get an idea of the quality, which can say, okay, are we primarily in that 5-star rating, or are we starting to see a lot of things hit lower? This can give us a little bit of a gauge if people are happy or unhappy. Of course, it's going to be up to all of us to look at the actual reviews and read them and see what people are saying as far as the things they like or they don't like. But this can at least give you a little bit of a metric that says, what's the overall satisfaction of the app? But analytics, as we're talking about here, can go beyond even what Microsoft provides in the store, in the reports that we give you for your being a developer or having an account with us. You can implement a third-party analytics engine. And when you do this, you are in control of many things. So I want to talk through some of the statements that are on the screen, and I think you'll appreciate it. Suppose that you're making a game, and now you've started to ask that question, did the user even look at my options screen? See, you might wonder that, but with analytics, you'll just know. It's the same thing as if someone went to a website and did they view a certain page on the site. You'll know if you have analytics. Well, same here. The process works like this. You will have within your gaming engine, so for example, I use GameMaker. GameMaker has some API calls that can be indirect calls to third-party analytics engines. An example of one is Marked Up, and there's even a Google Analytics for games. So you could use these little different third-party engines, and you can integrate them in with your gaming engine, so to speak, and then you can start to raise events within the app that says, someone looked at me on the options screen, and then that information gets sent to the source where you're looking at your analytics, and you can start to see what's going on. And here's that next question. What is happening right now since we last updated? See, the Windows Store reports, you have to wait a full day before you can get the next jump of data, so to speak. But with analytics engines, you can find out live data right now as it's happening, so you can see trending data. Why do the reviews say that my game crashes? Now, the Windows Store does provide a crash report for you, but it doesn't really tell you why your game crashed. It just says you're crashing, and it might even give some error messages of some degree. But again, if you implement the analytics engine correctly, what you could do is raise events in strategic areas where you do your own exception management, and you can find out exactly what's going on because you're the one who's delivering that information from that event that was sent. The other one is how far do players actually go in the game? That could be another thing. You're wondering, when people play this game, do they go to level 6? Do they make it here? With analytics, you can find out. So it doesn't even have to be, did they go to the screen? It can be a condition of, did they make it to this level? Did they achieve this status? Did they do this or that? So that's why you would want to implement analytics in your game. Because when you do that, and again, going back to the very beginning when we're saying plan your game, you can be so fine-tuned and zeroed in that between the planning phase and now up to the analytics phase, you can really make some decisions to make your game as successful as possible, reacting to the community's wish list, if you will, and increase your monetization possibilities. So you should definitely consult with whatever your game, I have here framework, but it's really gaming engine documentation. You should consult to see how you can implement analytics in your game using that approach. So that's it with regard to analytics. I'm really excited that we were able to cover all these topics with you today.
Yeah, that was a lot of content, huh?
Tons of content.
Lots of stuff surrounding the creation of games. This is an exciting field, and it's actually one that developers, even without very much experience in game development or in development in general, it's one that you can really get in. You can really get in without a computer science degree, without 10 years of experience. You know, you can just kind of start and you can start making games and you can get great at it. We've worked with a lot of students in the last year or so, and I know I got an email from one of those students recently saying, I just submitted my 10th app into the store, and that's pretty awesome.
That's fantastic.
Yeah.
That's very good.
That's really good. So I hope you guys are as excited about this as we are.
Yeah.
Can we have Adam back on the screen?
Adam, come on out.
It was great to have a third man on the show.
Wait, hello, Adam.
Adam in 3D.
Hi.
Yeah, we got all three here.
A lot of fun.
You want a hamburger?
Yeah, sounds
hungry
good.
right
I know.
Ready for dinner.
Very cool.
Actually, for some of you, it's time for breakfast,
Yeah,
right?
wherever you are in the world, you might be hungry. So cheers to that. As far as the summary is concerned, with all three of us here, so what would be your final line with regard to monetization strategies, Mr. Adam?
Analyze your application after you release it and do iterative changes to your strategy. Find out what works.
What would you say about store submission, Jeremy?
It's a relatively, it's kind of a no-brainer process. You got to put it in the store sometime. I'm just glad that it's a process that's simple and has a lot of good visibility so that I don't wonder when my app is going to be certified or if or what's going on with it.
Yeah, and as far as the analytics are concerned, you get some out of the box with the Windows Store account, and it's good data, but you might want to strongly consider having your own analytics in there so that you can capture what's important to you. And that is going to wrap up this module, and thus also wrap up this entire Jumpstart. I had a blast. I feel like the energy levels were high. It was pretty fun. What'd you guys think?
I think that the energy level was high.
Oh yeah, it's hard to top your energy level. It's impressive.
It was fun. Fun. So thank you very much for spending the day with us, and we look forward to continuing the journey, whether it's through tweets or emails or whatever, and finding out what you were able to do. We already know some of you are making games. Continue with your mission to create some games and have a great journey doing that.
But before you tune out, make sure you go.
There's more.
There's a little bit more. Make sure you go to the website, the one where you're watching the stream right now, anyway, and complete the poll. There's a poll there waiting for you, and those are really super helpful for us.
Video.
Absolutely.
Right below him.
About there.
Or is it above? I don't know.
Is it above or below?
It's below.
It's below the
Okay,
video.
below the video.
So do that.
Right by the
Do that thing there.
And also, make sure you tune into our Jumpstart tomorrow. I think we're going to have almost as much fun, at least 2/3 of the fun. Adam won't be here,
I'll
but
be here.
Sorry that you won't be here, but
I'll be here in spirit.
he'll be here in spirit.
I'll be watching it.
and he'll be here in 3D.
Very good.
Okay, sayonara,
Thank you.
everyone.
Thank you very much.
Bye.